the sides of a triangle because you might not come up with a triangle.
Yeah, you
That's
will.
not how it works.
So there are no
And it
no
might
three
have been
values.
a phrasing problem, but so let's say if I have two sides of 1 and 1, and I give the third like a 10.
Yeah.
Will that be a triangle?
1 and 1, and give the third a 10. Yeah, you could do that.
Can you hear me, or am I cutting out?
No, I think he heard you then. Like he just said yes.
It's 10 and 10 and 1, you
Okay.
said?
Then let's move on. So
1 and
what
10.
Oh, okay. I'm sorry.
Yeah.
10.
Yeah.
I thought you were 10, 10, and 1. No, 1, 1, and 10. You can't.
I'm just asking if that would make a triangle.
I think he said yeah. He's confirmed it twice. That right, RC?
Yeah.
Yep.
I literally cannot hear him. Like, can you
He
can
says
hear him?
yes. He said yes. He's confirmed it twice, and he's definitely confirmed.
No.
You can have a triangle with 1, 1, and 10.
No, I
RC
thought he
says you
said
can.
No.
I thought he said 10,
Wow.
10, and 1. I'm sorry.
He
No,
corrected
Travis.
himself.
Travis, no,
He
he said.
I corrected myself. I thought I was thinking 10,
Why
10, and
can't I
1. I
hear
apologize.
Arsim
No, you
myself?
said that, and then I
cannot
said
hear him.
no, 1, 1, and 10, and you said yes.
Check if you have him muted.
All right.
What's up?
Let me be very
I
clear.
do not have him muted.
You cannot
No.
have a triangle
I
of
have
1, 1,
him
and 10.
on 100%,
Okay.
and I
10,
cannot
10,
hear
and
him.
1.
What the fuck?
Thanks, Travis.
Jump out and jump back in.
All right, it's all right, Travis. Can you please keep out and stop helping RC?
Sorry.
Wow, Bev.
Now
Bev.
I'm hearing you. Okay.
Listen, Bev, you corrected RC by saying 10. No, 1, 1, and 10.
Yeah.
Because RC thought it was
I can't hear you.
Robot.
Breaking out.
10 and 1. RC said yes the first time. Yeah, whatever.
Yeah, let me be very clear. You cannot have a triangle of 1, 1, and 10. You can of 10, 10, and 1.
Right. Well, he didn't ask you about 10, 10, and 1. He said
I'm sorry.
1, 1, and 10.
That was my own problem. That was my own problem.
Okay.
I apologize.
It's
Okay,
just
so
that you
there
said
is-
you
there are
said
certain-
yes and confirmed twice.
Bev,
and then
Bev,
changed your mind once Travis had said.
I made my own lapse suspenses here. I thought he was saying 10, 10, and 1 in my own mind. I corrected myself. It is 10, 10, and 1 you can do.
Okay, no problem. But then that means what I said before, that there is a certain set of rules which tells you
Yes.
that you can only come up with certain triangles, right?
Yes.
Do we agree on that? Okay, great.
Yes, we agree
Great.
on that.
Thank you. So regarding the original question, my original question, what is the problem regarding the distances with those flight paths?
Because these flights, these distances, do not allow that these be the sides of triangles concurrently with other sides of triangles. If you have these 5 points.
Like, that's just the distance, right?
Yes.
I mean, going from one airport to the other, what triangle do you mean?
So if I, for example, go from Honolulu to Santiago to LA, that's going to be one triangle. And then if I go from Honolulu to Melbourne to Santiago, that's another triangle. Those two triangles share a side, right?
I guess I do not have it, visually in front of me. That's the problem. And I do not live in the US, so I get no fucking clue.
Yeah, no. So it's just imagine two triangles that share a side, right?
Okay, so far so fine. Yeah.
Okay. So two of them, one of those points being, or one of those triangles being Honolulu, LA, and Santiago, Chile. Okay. That's one triangle. Another triangle is Honolulu, Melbourne, and Santiago, Chile. Those are two different triangles, but they share a side. If you try to ask yourself, does the side that they share, is it equal? to what the logarithm tables say that the other two should be based on it, you'll find out, wait a minute. Once you get to those 3 triangles, aka you're using 5 points, you're screwed. They never calculate to being the same thing. That you always get different values for these distances.
And let me guess, the interior angles are greater than 180.
Well, that's actually a tangential point, no pun intended, to the the whole problem set, right? Is like what I am actually trying to say here is that if you want to quibble about interior angles, you can do that, right? And you will see that, yeah, they're greater than 180. But that's actually not the point. The most verifiable thing that we can do is say, do we know these distances? And the answer is yes, we know these distances.
No, you don't.
Okay, well, that's my challenge to flat earthers. If you think that you do know these distances, or you know that they're incorrect, then show me how you know that they're incorrect, because I can show you how I know that they're correct.
Wait a minute, RC. Is that?
Sorry.
Are you asking us, or is this a challenge for flat earthers only?
Yeah, it's one of two.
Taking part in this discussion. Does that make you a flat earther? Right. That's what I'm trying to get at. You've aimed this problem at flat earthers for some reason.
Yes,
it seems like a geometric problem that shouldn't require on anything to do with your cosmology or whatever you believe about anything, right?
Yep, it should just show you that.
So why are you mentioning flat earthers then?
Because it will show you that these points
you're
can definitely not
flat
be
earthers.
Bev, it's because that you can show that these points are definitely not coplanar if these distances are correct.
Okay.
Okay, I'm still at the point in which I have 2 triangles which are sharing one side. What's the problem regarding that?
But he also said that the distances change, if I'm not mistaken. Did I hear you correctly, RC?
I said if you try to calculate the distance of the shared triangle side, given the sides of the opposite triangles of the side they're sharing from, then you're going to start finding that, wait a minute, like if you try to take all of these 5 points and calculate the distances between them, just using the 2 sides of the other triangles or things that you do know about it, you're always going to get different distances, aka it's not on a planar surface that these are being calculated on. Like the laws of planar geometry do not apply to this because they just don't follow that.
So they're not.
Am I the only one that doesn't understand what he said?
5 points? What 5 points? I'm putting together 2 triangles that are sharing one side. That gives me a square, by the way. What 5 points?
No, what's up? That doesn't give you a square. If you have 1, 2, 3, 4 points, and then you add a 5th, okay, that's what I'm trying. That's what I showed you in the data. The 5th is Tokyo, and that's what I put in there in the chat. So if you take all 5 of these points right here,
before anybody jumped in, you told me that I am having, or we are having, 2 triangles which share a side. That's 4 points that I've come up with.
Yes,
so
and then I said I added 8.
What is the 5th?
The 5th is another one that you can use to verify. Hey, using now this 5th point and a reference to the distance between all of those other ones. It's so that you don't have to have a coordinate system in order to verify, hey.
What coordinate system? Sorry, no coordinate system. This is simple geometry.
What's
you do not need any kind of coordinate system.
Exactly. That's what I'm trying to tell you, is that with a 5th point, you don't have to appeal to a coordinate system. All you have to do is know the distance from all the other 4 points to that 5th point. And that allows you to verify, hey, these other 4 points are indeed where they're at.
What? How?
Because if you try to take an arc and you draw it along 3 points, then you're going to get an intersection at 2 different places. But if you add a 4th point, then another 3 of them are going to be fine. If you add a 5th, then you know where that 4th is.
If I draw a circle from what? What is the center point of the circle?
You're asking yourself, where can this thing be along the arc? If it's this distance, then you say, okay, it's got to be somewhere around this arc.
Radius is center point. That's what I'm asking for precisely.
Yep. It would be one of these 5 points, the 5th point, which would be Tokyo.
One of these 5 points, the 5th will be Tokyo, and which one I'm choosing?
You can choose
Let's
anyone
choose
you want.
one.
I said Tokyo is the one I used to verify the other ones.
And why would the distances from one point would be the same for every other flight path? I don't get that.
It's because if you actually try to say, hey, can this distance that I get from Tokyo to Melbourne, would that allow me on a planar surface, given the other 4 points or the other 3 points besides Melbourne and Tokyo, would that allow me to lay it along that arc? And the answer is no, it doesn't.
These sides for these triangles that we have at the very beginning are all different values.
Yes.
It's not a square. It's not a perfect square. So what do you
I
mean
know.
by having a circle and then checking if everything is on the same on the circumference of the circle? Like, I don't get that at all so far.
So imagine if I have. It's kind of like your. Can I have a triangle of 1, 1, and 10? Right. It's the answer is no, because like there's no way that you can fit that 1 on the arc of that 10. The arc of the 10 is way too big, right? So there's no way you can orient that 10 in order to make it fit with that 1. And there's no way you can orient that 1 to make it fit with the 10.
Those are the kind of numbers that kind of you can come up with the flight path. Like, again, it's not a square.
I understand it's not a square. Nobody said it was a square.
I mean, it's not a perfect square. So
no, but nobody said it was a square. I was giving the square example to show everybody else that give it, especially with somebody like Bev, who claims to know a lot of geometry, and he was able to answer these simple questions, that you can use distances to figure out, hey, are points coplanar or not? And that there are rules that we operate under, whether...
That's another claim. That's a geometrical basic claim.
It's a basic geometric proof. It's a basic geometric proof.
Whatsoever. That length gives you what?
That length between points can tell you, hey, are these things coplanar or not? Can they exist on a plane or not? And the answer is no. Just like with your 1, 1, and 10 example, that in no existence can those line segments be coplanar and form a triangle.
Sorry, those 3 lines that I had as an example, 1, 1, and 10, are coplanar.
Yes, but you can't form a triangle with them and have them remain coplanar.
It's another question. You had the question if it's coplanar or not.
Yeah, exactly. And it works both ways, bro.
What?
So let's say that for in some way, shape, or form, the segments A, B, and C, right, with your 1, 1, and 10 are connected. Would those lines be able to be coplanar and be connected in any universe?
Mate, you
answer's
had
no,
another
right?
question.
I would
have to arc.
If they are coplanar. Yes, I know. That's what I just literally asked. And the answer is no. You would have to take that segment of 10.
So
you have to arc it around or curve it around in order to make it. So no, they can't be coplanar.
No arc. No arc is needed to determine if the 1, 1, 10 would be or could be a triangle or not. They are coplanar. Okay.
Okay, and my question is there any universe that you can connect those ends together of the side of 1 with a segment of 1, 1, and 10? Is there any universe you can connect those together at their ends? The answer is no, right? Okay. So now let's imagine a universe. We can prove that, hey, are they not coplanar, right? Now let's imagine a universe where they are connected together somehow. Is it possible for them to be coplanar?
But we just determined they are not, and they cannot be.
They're now our inverse is true, right?
How is the inverse true if you already determined if it's true or not? That was our first question, right? So this is logic.
If you can assert that all 3 of them, if you assert that all 3 of them, a line with the length of 1 and a line with the length of 1, another line with the length of 10 are connected together, then you can assert, yeah, if they're connected together, they're definitely not coplanar if they are.
Hey, Meisty, would you just mind in the chat thread putting in the distances for these locations?
Yeah, I did.
He already did.
The only thing I would offer too is like maybe channel 2 also.
He has.
Okay, it's already in the chat.
I've put it in there as well.
And is it in live stream 2 or live stream 1?
Yeah, it's
because
in
I'm
live
not
stream
sure.
2. Yeah.
Stream 2. Okay.
Again. Yeah.
Yep. And
So again, the question, if lines can be coplanar, then yes, any line segment,
What's up?
any distance
That's not
can be
the
put
freaking
on the
contention.
same plane. No problem.
That's not the contention, WhatsApp.
Then what is?
The contention is, can you have these lines be straight and coplanar of a 1, 1, and 10 sides, or 1, 1, and 10 length lines? The answer is no, you can't do that and make it a triangle. You have to either curve the line,
do that and
or
make
you show
it a
that
triangle.
these lines,
Yeah.
or you can either curve it, or you can show that it can be used to say, yeah, these lines are coplanar, or these points are coplanar.
So if I curve it like any of them, then they will not be distances, will they?
Good job. So now you've
get
arrived at
what I just said?
You've arrived at the premise, right? Either these distances are wrong, right, or these points aren't coplanar.
That's not what I meant. Distance
Well,
is
that's
measured
the whole
as
point
a
of it.
straight line. Distance is measured as a straight line.
Unless you're on the surface of a 3-dimensional object.
That's not even true, because, for example, when you are using a map
You're
that
just
is
wrong now.
representation of the 3D world, then you are using a straight line.
Meisty, listen, are you under the impression that if you travel across the country with an atlas only, let's just say, and you use the atlas to get across Indiana, not that Indiana has mountains, are you under the impression that the legend is a 1-to-1 scale with, or is a proportional scale? Like, even make it across the United States. If I'm going to map out what I am going to drive across the United States, do I expect that if I stick to these highways only, that I'm going to drive exactly 2,472 miles? Right? Like, just because
I heard you ask like 4 questions there. Which one are you actually asking?
Well, I actually think I only asked you 2. One, I started across Indiana, and then the other one, I made it bigger across the United States because the United States has mountains. Right?
Good job.
So I don't need you to patronize me. I'm
just asking, what are you asking me?
Are you under the impression that if you look to see what the legend tells you, how to measure off the distance in one state to the next state to the next state, that's exactly how many miles that state is?
On an atlas? No, I'm not under that impression.
Okay, so there you go.
Okay, but this is not using an atlas. This is using flight planning software.
It's same thing.
Like, no,
same thing.
not at all. Because as you might know, Travis, airplanes don't go up and down mountains.
No, but they do have to remain on course if they get blown off course because of winds or this, that, or the other. So
okay, this isn't with those course.
My question is okay. So my question is then, if I look to see if I want to drive across the country and drive 2,472 miles, or if I want to fly the same distance, is the distance on Delta going to show me a distance similar to the one that the map says?
Yeah, you're gonna want to look on ADS-B data.
You just said yeah. So is it a yes? Is the Delta mileage going to show me roughly the same as the Atlas mileage?
I couldn't make any claims for Delta, but the ADS-B data will tell you the correct.
I asked you.
No,
if...
I cannot make any claim. Listen again, since you're apparently deaf. I said I cannot make any claims for Delta, okay? But I can for ADSB because I work with ADSB and I know how ADSB works, and it will give you an accurate measurement.
Okay, great. Okay, so just to be pedantically a dick, when I said originally, are you under the impression that if I look up the air flight miles, that they will be the same as the land scaled miles? And you went, yeah.
Yeah, they're going to be about the same.
Okay.
What?
You just need to think about now what we just said in the past 2 minutes. I'll just leave it at that.
I simplify it for you. I simplify it for you, RC.
Are you asking me?
Airplanes
Are you
do
asking
not
me? Hey,
travel in a straight
Travis,
line.
are you asking me? Are the like me driving them? Are they going to be the same as the flying ones? No, I don't think that the driving miles are going to be the same as the flying miles. But I thought you were talking about if I look at a general map and I say, hey, I can see that the United States is about, I don't know, making this up. How many miles wide is it at this point? I don't even remember. Let's say it's 3,000 or it's 2,500 nautical miles wide. Okay. You're going to see something that goes from coast to coast be about 2,500 nautical miles, depending on exactly where it takes off from and exactly where it's going to. I thought that's what you were asking. I didn't know if you were. It's now. It seems like you're saying, is the driving miles, me driving on the road, going to be the same as me flying in the air? The answer is no.
Okay, right. Because again, to be a pedantic dick, that's what I said at the beginning. I said, do you think that the Atlas is going to give you an accurate driving miles? And then I said, do you think the air flight miles are going to match the map mile, the Atlas miles? So
well,
I thought
those are two different questions. Those are two different questions.
Oh my fuck.
No, they're not.
No, they are, because you said Atlas miles, meaning from the map, how big is it going to be, versus driving miles, which is how far do I drive?
So how far off are your nautical miles going to be from the Atlas?
I couldn't tell you.
No, please don't deviate.
I could tell you, Travis, that these distances are correct. They must be correct in order for us to do fuel correctly in airplanes.
Travis, can you not deviate the topic if I ask you nicely? Can you do that for me, not to deviate this much the topic, because this wasn't the topic. My question simply was, what is the problem regarding the distances that is, for example, given in a chart like that RC Maesty posted? Like, I'm still on the problem that we are having, different sides. And he came up with circulating something. I mean, drawing an arc in between those. I don't know why any of those points that are given by the distances would be on the same circumference of a circle.
What's happened is because that you can't take distances of these lengths, just like with your 1, 1, and 10, and connect them together on a planar surface. And have them actually
no question regarding the planes so far. So far, I'm only asking why would they be on the same arc in the first place, because that's what you brought up.
Yes, because if you're going to have them along the same arc, the argument is that you can orient them any way you want, and there's no way you can orient these distances on a flat surface and get them to connect together.
Orienting a 2D plane is just, twirling it around, like nothing changes regarding the relative distance.
I'm saying orienting the paths. You cannot take these distances and say, is there any distance from this point that this city can be along if the distance from that city to the other city is what I know it to be?
In reference to what?
Didn't make any sense for me.
In reference to the fifth point. So what's up? If you have, for example, 5 points, okay, and from each of the points you know the distance to the other points, okay. Are you with me so far?
No, wait. Can I just clarify?
No. Hold up. What's up? Are you with me?
That's what I said. Sure, you are
Okay,
drawing
great.
up more lines
Now-
than you did
now-
before, by the way, because now you just said distances to every other point. We didn't
Okay.
have that
And
before.
that's what this
Okay.
is. So, is there any way that I can have all of those cities remain connected together and cut one of those distances in?
At one of those distances for what? And
Is there
where
any
would I cut
way
it?
that I can have those cities with the lines given and distances known remain connected together if I cut one of those distances in half? I take half of
You
that line
never
out.
mentioned any distance cutting in half, and when
Oh
we are
my
talking
gosh,
about a
what's up?
flight
All right,
path, why would you
just forget
fucking
it. What's
cut
up?
Listen,
in
You're
half
just
any
like
distance?
Can I
purpose
just
player.
get one clarifying thing? You've got distances, and I'm trying to follow along with this conversation. And you've got distances. Distances reference to what?
To each other. That's it.
That's it. So all we have are distances, and we
In
lay them out.
reference to each other
And we lay them out on what?
on a flat surface.
What flat surface?
Any flat surface you want.
What? How? What? You just want me to draw my own, like anything?
Yeah.
Oh wow.
Try it.
Okay.
Try it. Now, is there any way you can orient those distances between those points on a flat surface and connect them together? The answer is no. There isn't.
What are you
Why
talking
would I
about,
connect
dude?
all of them together? That would mean that every flight path is going into the same point. Why would I orient them together to one point? What do you mean by that?
I didn't say
in the
orient
first
them to
place?
one point. I said, can you connect those freaking distances from each city to the next? Can you connect them with those distances and put
Yeah.
that on a flat surface in any
Okay.
orientation you want? The answer is no. You
Yes,
can't.
yes,
No.
Yeah.
yes, I can.
Okay,
All right,
stop.
show me. Show me. Show me
Okay,
this.
okay,
Show me.
stop saying show me, show me, show me. Listen, I thought about this earlier. I'll ask you again. Can we do this in the United States? Can I pick
Yes.
Seattle, Las Vegas, and Louisiana, or New Orleans,
Sure.
and Chicago?
Sure.
Okay, I can connect each of those points. Yes. You're not proving anything, dude. That's why I said earlier, these are just distances.
Yes, and these distances alone show you that, hey, these points cannot be on a flat surface together.
Okay, first of
How many
all,
points do I have? Tell me again. How many
my
points?
gosh,
Five?
this
Do you
is
want 4
5,
or 5
what's up?
or 6? How much?
5.
5 points?
Yep.
Okay, so
No
you're making a
problem.
pentagram.
Oh my gosh.
Why are you saying, oh my
I'm
gosh,
not
you're the
sure
one that's
about the
acting
shape.
insane?
I'm not sure about the shape of that object
If
whatsoever
you have
because it
if you
wasn't
have a
described.
pentagram, if you have a pentagram that had a stroke, yeah, sure.
Okay, so then what's an oblong 5-sided object?
A pentagram that had a stroke. We'll just call it that. The strokey pentagram.
Okay, so why don't you just go with what I
That's
said
it.
instead of making fun of it?
Because a pentagram is a symmetrical object that you can use. This is not
Right,
a pentagram.
I didn't know what else to call your object except that it has 5 sides. So pardon me, Mr.
It's not
RC
five.
Vice.
It's not 5. It's not 5 sides. There are 5 points, and each of the points are connected to the other with a known distance.
Okay, so there's an inverted point.
There's nothing inverted about this.
Okay,
You guys are making this so much harder than it is.
Okay, it's a 5. This is a 5-sided. It's a 5-sided connect the dots.
No,
Correct?
it's not. It's not 5 sides. It's just simply here are 5 points. We know the distances between each point and all the other points. That's it.
Yeah, so I don't
So-
get it. You got
so-
distances, so what?
So if you take each of those 5 points, knowing the distances to the other 4 points, is it possible to lay that out on a flat surface and have all of those lines be straight? The answer is no.
If you phrase the question that way, then it certainly can be done, for example, as a pentagram.
All right, show me. Because not with these
In
distances that I gave
Livestream
you.
2. In Livestream 2.
It's in Livestream too. If you phrase it that way that you just
Oh
did for
my
the fifth
gosh,
time, and I
no.
cannot
I
believe
said with the
what the fuck is your
distances,
problem.
with the distances that I gave you.
Okay.
So show me the distances
You
that
gotta
I
lay
gave
it
you.
out.
Yeah, go ahead. Lay it out any way you'd like. You can't fit it on a flat
Sorry.
surface.
No. Wait a fucking
Okay,
second.
wait a
You
minute.
brought
Okay,
up
listen,
the problem
listen,
itself.
listen. I
Please,
don't
can you
even
not
know.
overtalk me whenever I talk, please?
Okay.
Like you're doing it for the third time at least. So I did not bring this problem. You brought this problem. Can you
Yes.
present the problem itself?
Yeah, sure. Take each one of these 5 points. Using the distances that I gave you, connect each one of the points to the other. Only using the distances that I gave you. Then attempt to put all of those 5 points with the distances that I gave you on a flat surface and see if they're straight lines or not.
Wait, you are telling me to do something in the first place, but you brought the problem itself.
I
Why
know.
won't
And what I'm
you
trying to show
show
you is that
us?
it's impossible to do what I'm
You're
asking
not
you to
showing
do.
anything. You are talking.
Yeah, it's not possible to put these on a flat surface. That is a geometric proof that the Earth isn't flat.
Wait, that's a claim, and you are not showing anything. You are just talking. It's only
Yes, I
me in
showed
this
you the
conversation.
distances.
The one who had the question, "What is your problem?" is who is showing anything so
No,
far.
I showed you the distances. And I said, these can't fit on a flat surface. No matter, I've tried it 80 different ways. There's no
You haven't shown that
orientation that these
whatsoever
5.
yet. Not yet.
All right. So you claim that they can fit on a flat surface with these distances?
Sure.
Okay, show me.
I like this, what I'm showing you for the past, I don't know, 2-3 minutes.
No, with the distances that I gave you.
Okay, look,
Again,
this is where
the exact problem, that's yours, okay? Either you bring something that you actually...
I gave you the
that you can
distances. Now do it
actually
with the distances that I gave you.
demonstrate. That, do you know what demonstration means?
Yes,
You can
it's with the
demonstrate your problem.
distances that I gave you. Why are you not using the
Or
distances
don't
I gave
talk
you?
about it.
Oh, now we don't want to talk about the distances that I gave you.
Okay, look,
I would talk about it all day if you had anything to show for your claim.
again,
How about
Meisty,
distances?
Meisty, again, listen. I asked you if it can be done in the United States. The distances don't matter. That's misdirection. I chose Seattle, Las Vegas, New Orleans, Baltimore, and Chicago. 5 different locations. I can draw a line from each one. Boom, 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 boom. The
I mean, do you
distances,
get that you haven't...
the distances don't matter,
didn't get a
Meisty.
scale, for example?
Well, that's
haven't
why I asked
presented the
Bev.
problem
Hold up,
itself.
I'm just making a flight plan with the ones that you want on here. Well, that's why I asked Bev the question that I did, because Bev showed us that the distances matter a lot.
Sure they do, but that's, by the way, is including 2 different questions at the same time.
Just
One
a
is
minute.
that you said
He
before.
didn't show us any
Yeah.
distances. You said we just did the sides of triangles. That's the sizes of the
And then I
sides of a
gave you the
triangle.
distances between the cities, and now Copernicus wants new distances, so I'm going to give him some new cities with some distances.
No, just stick to the ones
Sorry,
you
nobody
give us.
actually. Nobody wants new distances because so far we haven't talked about the original problem yet. Okay.
Because you just keep going around in circles saying I haven't presented anything when I presented the distances.
Travis is going, not
and
me.
I said
Okay,
that these
Travis is going,
distances.
not
Hey,
me.
hold up, what's up? Then I told you that these distances cannot fit on a flat surface and remain connected together with straight lines. You said, yeah they can. I'm saying, show me.
Claim. That's a great claim, but you have a problem originally. You present something for that claim. For example, a scale. Like, a scaled demonstration of those lines that you mentioned.
Sure. You want that? You want that too?
I would like it. I do not want
Sure,
it, by
no
the
problem.
way. I just would like
must
it.
it be? Do you want it to be physical or can it be digital?
It's digital. I do not live
Oh,
right
okay.
next to you
So
to
you
show
don't
me
care. All right.
on a
Well, here you
paper.
go.
So
It'll take me about 10 minutes to get it up here on my computer. Give me a second here.
Sure, no problem.
$10 minutes. Well, I see at the beginning, the first claim was they can't be on a plane. So I'd say, what elevation are all of the airports at? Because that would surely be the easiest way to find out if it's on a plane.
All of them are fewer than 10 feet above sea level.
All of the airports?
Yes.
Wow, that's handy.
Okay.
But are they all at the same
it would be interesting
elevation?
to me, but yeah.
You carry on doing your thing. We're just talking amongst ourselves.
Sure.
You keep on it, Micey. I just say that if they're not on the same elevation, then they have no chance of being on the same plane. Unless you're talking 3 points, and then 3 points are always coplanar.
Could be made to be coplanar, yeah.
Well, yeah, 3 non-collinear points will be coplanar. Mathematically. Geometrically. Since that's how you define the plane.
At least 3 points,
Yeah.
Exactly.
Or you could, I mean, like, geometrically, if you were to have a coordinate system, you could say x equals 0. Y equals 0. And that would define the plane. Cartesian coordinates.
In a coordinate system,
Yeah. So you don't actually need 3 points within the coordinate system.
In there, of course, not.
Yeah.
But that's a different kind of question. We are just,
yeah.
talking about like simple geometry.
Yeah. Well, I was thinking.
All right, there you go.
Question was.
All right, just gave it to you. There you go.
Cool.
Wow.
So these are curved lines. Okay.
Yep.
So what's the question regarding them, or the problem? They cannot be straight, or
nope.
Or
There's no way that you can orient the. There's no way you can orient these 5 points to have them be straight on a flat surface, because that would then be shortest distances, which would then invalidate the fact that these distances are indeed shortest distance. So
okay, so are these distances, or are these flight paths?
They're the shortest line distance between these points.
No, you don't get my question yet.
I understand your question. I understand your question.
Just simply a length in between 2 points. That is a straight line. Now, the flight path that would, let's say, the airplane itself would record would be very different from that, because it starts from the ground.
They're
Goes
not
up,
very
it gets to an elevation. So the paths
they're
would
not
be
very
different.
different at all.
They're path value would be different.
They're less than 1% off of what these are.
Less than 1%.
So you're going to have like a slight variance in approaches and a slight variance, for whatever the traffic is, but it's less than 1%.
Less than 1% of what?
Of the original direct line distance.
Meisty, are you under the impression that your arcs are to scale?
Yes, they are to scale.
Okay. Have fun.
In fact, I give
So
you the
these
exact
are
scale that it is right there.
Every line relative to each other and every distance is to scale, by the way.
Yes.
That's what we are actually asking precisely. That
Well,
any
if you want
line
to say
that we can
relation
see in
to each
here,
other, you want to say relation to each other. Well, that's kind of actually part of the challenge here. Is that is there any way that these distances can be on a flat surface? Can you orient this in any way for them to be on a flat surface and connected through
that's not my question.
shortest
No.
distances? No, but that's my challenge to you.
That's not my question.
Well, I don't care. That's my
Yeah, but-
challenge that I originally gave you. That's the problem. You want to talk about the problem? There's the problem.
Sorry. Again, so is this actually scale or is this just a
Yes.
somewhat draw up?
Yes.
Scale to what? What to what? 1 to what?
It's about 1 to 1.3 million, if you'd like to know.
Where does it write it? Where do you get
Okay,
that
well,
from?
give me 1 second here, and I'll show it. You can just go to skyvector.com and look at it. So this is flight planning software.
Anytime I
Skyvector.com.
actually saw a map and used a map for this kind of thing, I always saw it's called a legend, right? On the
Yeah, and I
usually
just
the
told you where
bottom
you
left.
can find it. If you want to go to skyvector.com, you will see the legend on it. I don't know why you just keep ignoring me telling you where exactly you can find the legend. You could read up as much as on the legend as you'd like.
So in this sky vector, could you plot out 5 points and ask them to connect them for you?
That's what I literally just did.
No, you drew it by hand.
No, I didn't. Why would you say I drew it by hand?
Because I'm looking on my phone and it just looked like it was
No.
drawn by hand.
No, this is scaled using actual flight planning software.
So why didn't it just draw straight lines connecting each one?
Because you can't draw straight lines connecting
Yeah,
each
you
one.
can't. Okay,
Have it to remain to scale.
Okay, listen to me very
Because
carefully.
then the directions would be off.
Okay, look. So without those lines, if you took all those lines off, you're telling me that map there that's on the screen, if there were no purple lines, that would be to scale as well.
It would be to scale in terms of distances, but not directions. And so that's why that you see. That's why you see that. That's why you see these arcs, is because it shows you a meta representation of the direction, because the Earth is curved.
Yeah, but that's not the way.
Flat.
Yeah, right. But again, Meisty, they don't fly down, back up. They fly straight across, bro.
Yeah, and that you go that straight line that you fly, you are going south, and you end up going
have
north.
a huge contention to that claim that this is a scaled map. Because
all right, go ahead.
This, do you see what I posted in live chat?
Yeah.
So this is called a projection of the world.
Yes.
Now the projection of the world is not to scale and distorted as heck.
Yes, but distortions, you can still draw distortions to scale as long as you know what that scale is.
Again, this
you
is
asked me
a
what my
projection,
scale
not
was. You
a
actually
map.
asked me what my scale was. Scale was specifically for distances. Directions are represented in terms of the magenta line.
No magenta line whatsoever. I don't even know why you would bring that up. Again, this is
Well,
a
because
projection.
that's the whole argument. What do you mean? Why would I bring it up? What's up?
Because it doesn't make any sense. Again, this is
Oh,
a
I know it doesn't
projection.
make
It's
sense
not
to
a
you as a
map.
flat earther, but my challenge to you is,
It's not.
hey,
I'm
go
not
ahead,
a flat
go
earther.
ahead and put
Let's
these on a
deviate
flat
from
surface.
that. Okay. This is a projection. It's not a map.
Jump.
So it's already cannot be to scale.
Yes, a projection can be to scale as long as you have that scale corrected for direction, which I do with the magenta
Doesn't
lines. I already
have
told you that.
the right proportions. Do you
Yes,
get that?
And that's why I
No,
told you.
projection doesn't. No.
And that's why I told you that you can use things like the magenta lines to indicate what direction are we going or not. And that will show you the correct scale for distance.
And the map itself is not to scale. Okay, do you get that?
Oh my gosh, I just told you how it is, and you're just saying nuh-uh.
So the drawn up distances that you draw up, I'm not sure if you did it or the software did it just by clicking on, you know, different airports. It doesn't matter. It's not to scale.
Okay, I just told you how it is to scale in terms of distance, and in direction, they make up for the distortion by showing the magenta lines over the exact location where they're going to be. So yes, it is to scale.
I can, yeah, okay. Okay, you want to think that the projection is a map, then that's your problem.
Yeah, if you have a distorted image, it's already not to scale. It's already
Incorrect.
distorted.
If you know exactly how the distortion works, then you have a correct representation of each
You
location.
don't.
Oh, stop. You have a correct representation of each location, and you know how that distortion is going to affect what that magenta line looks like, then yes, you can call it scale.
So, mate, again, it's not how it works, because the distortion doesn't mean that we know
All right,
how
well,
it
you're just wrong
distorts.
as to what
We don't
scales
know.
are.
Did you get the last part that I said because you were cutting in? What did
You're
I
just
say?
wrong as to what scales are. I'm not going to hold it against you, but you're
What
wrong.
did I say? What did I say? You cannot. Okay? Can you not cut in the next time if I say it?
How about you
Yes,
actually repeat why I say that I think it's to scale?
Again,
Can
a
you?
projection is distorted because we cannot determine how it's distorted exactly.
Yes, we can.
Good. Then there wouldn't be a distortion in the first
Yes, we
place.
can.
Do you get that?
Yes, we're trying to do it on a two-dimensional surface, so we can't exactly see how it's distorted. As represented by the magenta line in terms of direction, as represented by the scale in terms of distance.
No, we call it distorted, the projections, because we do not know where would the distortions
That's
actually
incorrect.
happen and by what
That's incorrect.
magnitude.
That's just incorrect. It's the opposite of
So
what
you're right
distortions
now,
are.
you're claiming that you can develop into 2-dimension a sphere surface. That's what you are claiming right now. Do you know that?
Yeah, as long as you know how you're distorting it, then you can correctly represent it in terms of direction and distance.
If it can be correctly represented, then it wouldn't be called a distortion in the first place.
As long as you know what the distortion is exactly, then you can represent it. And that's what I did right here.
Okay, you know what? Then tell me what is the formula for the distortion that gives you when you are going from a sphere to a surface, developing a sphere surface? Then tell me that.
I don't know it off the top of my head. Would you like me to look it up for you?
Work it up? Sure, I would love to see that. You working it out? Yeah.
Sure.
Working out how it actually distorts. I have never heard that before.
Well. Everybody went quiet.
There you go. What do you reckon to that?
Huh?
Because we're waiting for Meisty to crunch the numbers.
Meta scale. I like that.
It's just a joke because within 5 minutes, RC Meister will give us the actual distortion equation.
Yeah. He was trying to tell us that something about it not fitting on a plane. Right. Well, I consider a plane to be a two-dimensional surface, and like we said, it depended on the elevation of all of the airports whether they could possibly be on a plane in the first place, right? So that would be the first thing to sort out with, right? Now, all of this sort of stuff, is that going to go on a plane, or is it not going to go on a plane? Or are you just sort of bending those lines so you can get them to fit on a plane? I don't get what the point of
that's
it all
right.
is.
The
I
excess.
haven't got a clue.
That's what I think he means, yeah.
I mean, that definitely
My
isn't the
problem is-
shortest distance from that bit at the bottom where it says distorted distance, right? The shortest path, as everybody knows, is a straight line. That curved
problem
one, it
is-
almost looks like a circle.
I think he means the distance is too great, right? And that circle would be too great. I mean, that line would go past. So in order to go point to point, it has to curve. I think that's what he means.
All right, there you go. I just provided you actually a really nice Excel that'll take you step by step through.
No.
how
You're
each one
doing
of these
it. No. You're doing it.
Travis, you can suck it, and if you can take this freaking Excel, and you can look at exactly how each of the distortions work on any given map. So you can suck it up and do your own work with it, or you can actually recognize, like, yeah, there are formulas that we use, which is his original response here, that they're not oh no, you can't calculate distortion. Right here it is. This is how you calculate distortion.
Meisty, can we have some clarity on that curved line, please? Can I ask you a question?
Sure.
Is that line curved because of the claim distance is too long to be put on a plane? Is that what you're saying? So the line has to be curved?
No, it's because of direction and because of distance. So with the distances, you can't accurately represent on a flat surface, a three-dimensional one, unless you provide an equation for what that distortion would be. In this case, we're distorting for a curve that exists on Earth on a flat surface. Thus, if you want to take that bearing and that distance in order to keep both of them correct, based on how this is representing both distance and direction, then you have to do it along that curve.
So the curve is a longer distance, is what you're saying. So I was right. You're representing a longer distance with that curved line.
No, it's both. The line represents two things. It will always represent a location, and it always represent a bearing. Okay, that bearing or your direction that you're going is represented by the direction that magenta line is in terms of longitude, latitude. Okay, and that longitude, latitude coordinate is going to give you exactly where that is, aka the path that it's going to take.
I'm confused here.
Well, I'm sorry.
So you're presupposing that you're on a curved surface. Hold on. Are you presupposing a curve? So RC, please allow me to put this question out. Are you presupposing a curved surface?
No, we measure and we know a curved surface.
So you are presupposing a curved surface.
No, you don't presuppose it. You know each of these distances. You know each of these directions.
Oh my God. That's my point. If you just are going by distances, that's all you have is a distance. There's no
reason. Bev showed us. And as
Excuse me?
Bev showed us, that's more than enough to understand, hey, geometrically, is this on the same plane or not? Bev already showed us that.
I think you're contradicting yourself here.
No, not at all. Bev is.
You're
but-
representing a curved line, right?
Wait a minute. What do you mean? What is it that I'm doing and what I've said? Because surely everybody's heard me say "fuck all" here, RC.
Exactly. I was
Right,
wondering
so
the
what
same
is
thing.
it that you're claiming just now? Or is it some sort of obfuscation with a misdirection for some sort of bullshit that you're just pulling out of the air?
No, not at all.
Because
It's
you're
just-
struggling.
Oh, I'm not struggling with anything right now. The only
Okay.
thing that you guys are struggling with
Right,
is like,
no,
how do you
no,
weasel
don't-
your
not
way
you
out of, how do you
guys, no,
weasel your way
no,
out of
fix the
these
problem with
distances?
me first, RC. What is
Yeah,
it
my problem with you.
I've
My
said
problem with you first, Bev. My problem.
that
Hey, you want to hear
nobody's
it?
heard me
My
say?
problem with you first, Bev, is that you are shown how able to do 8th grade geometry at least, and be able to do basic geometric proofs about how distances work.
So you're
And now
talking
you're
with
listening to
me
all your
and you
hold
lay a
up, hold up,
low
hold up, hold up.
blow to
Now you're listening to your
wow.
compadres here. Now you're listening to your compadres run around in circles that, oh, no, distances don't prove anything. When your bro here, Travis, just said that, and you just sat there with your thumb in your nose.
Right, okay. You were talking. I didn't want to interrupt anybody, but since you've brought me into it, I'm going to do this now, right? You'll look at the drawing that you've given us. Now, that curved line at the bottom that you said is longer, that had to be curved because it was longer, is 5,800, right? That one that goes across that looks shorter than the actual distance of the line is actually longer. It's 6,800. So your
can it be
meta
the
scale
scale?
that what the fuck is going on? You're the one that's talking about distances. You brought me into it. I'm just asking a simple question. What the fuck's that about? Why is the longer line, even though it's curved, longer but yet shorter in distance? What's going on, RC? Please explain.
Did he leave?
He left.
Yeah, he
Left,
knew
yeah.
that line
Oh,
would kill his ass.
dear.
Yeah. He thinks
That's
we're
where I was
he thinks
going,
we're
by the way.
stupid. Yeah.
He
When I
tried to bring
mentioned the
me into it,
projection, that
right?
was the first contention.
Yeah, he tried to bring me into it to confuse everybody because he was struggling.
Yeah, we picked it
didn't
up
work.
right away. There's no way you can account for that curved line, mighty boy.
Poor
Terrible
guy.
behavior.
Had to actually fucking
Terrible.
disconnect like right away. Wow.
That's embarrassing, really embarrassing. Like to go out like that after you're acting so intelligent and putting people down. He's talking with me and he takes a swipe at Bev. I don't get that.
Mm-hmm.
It's called arrogant. Arrogant.
Yeah. Yeah. Sheer arrogance. Yeah.
I hope everybody listening saw that. His tactics. Obviously, the failing. I mean, he's did well. He's on his own. But, I mean, he's having to bullshit for the model on his own with no other distraction tactics. And once you learn how they try and do it, I mean, he said, Bev, you don't understand geometry. As if that's meant to trigger me into some sort of other argument, right?
Yeah, but he's talking with me.
Mm-hmm.
I asked him the question about that curve. And he brings you in and he starts insulting you. He could have at least insulted me. I don't get that.
Oh, he was in the corner. That's all he could do from there.
Yeah. Yeah.
And this is called arrogance and cognitive dissonance. Thank you for listening.
For real, yeah. Like you think you can draw a curved line and then try to convince us of something? Like seriously?
Well, he called us in, right? From a bullshit like Pythagorean formula question that was really easy. Hello, look at it.
Well, Bev spiral. Meisty, are you serious, bro? Like really?
Anyway, we came in here just to simply talk about the problem that RC Meisty has. And it seems like he's unable to actually talk about the problem he has. Simply.
It's cog this, absolutely 100% cog this.
when he sees that shorter is longer, longer is shorter, that's when the code is,
That's why he,
and it
yeah,
cannot
that's why he
operate.
broke down. Yeah. I mean, you can't
I mean,
have
nobody
opposing
could.
thoughts. It's not possible.
Well, how about my prediction, right? You don't understand scale.
Well, yeah, it's even worse than that because
Yeah.
even the 559.20 line is straight when he's got 58.80 is curved all the way around. And then that one that's 6.8, golly, dude. Why would he do that?
He's not even talking to us anymore.
Yeah.
Oh, yeah.
He's talking to Travis. Did Travis leave? Yeah,
Yeah,
Travis
yeah.
left. Also, that's an
He's in
interesting
the
point. Let
he's in the
me
up
point
room,
it
yeah.
out.
Yeah. Did RC go
Yeah,
up there to
did he?
talk to Travis?
No. Just
RC
one
didn't go up
thought,
there now.
please.
No.
Just one thought. So Travis came in as we were talking to RC, and Travis left as
Right.
RC left.
Yeah,
Okay.
yeah. So he didn't want to come and talk to us
Okay.
about this problem. He just wanted to talk to RC about another problem, I think. It seemed to be anyway, Travis. He seemed to want to talk something else, didn't he, than what we were talking about.
Yeah, that
It's
was
not a problem,
frustrating.
but
Yeah.
don't do it while we are in the middle of something.
Yeah, yeah. Bev seems to refute. He's talking about Travis now, right?
Yeah.
Well, right, nice. Yeah, yeah. Just try
He's
and
trying to pit you against Travis.
put a wedge in between me and
Meisty,
Travis. That's nice.
you little sneaky little.
Yeah.
At least
Server
he wasn't
problems.
shouting.
This is like high school stuff.
I was just thinking it's like
The
Mean Girls.
kinda. Yeah.
Yeah.
Reminds me
Yeah.
of Mean Girls, like point blank.
Yeah, he did. I mean, he called us in here, and we did say at the outset, like try and be nice and let's find out what his problem is. Let's see if we can get him to explain exactly what the geometric problem is. Stick to the geometry and keep to it. And I don't think he explained his problem at all.
I think we were polite and nice with him.
I mean, if
But
you can
was
make
I
the
nice,
length
by
of the
the way?
lines anything and no particular scale, then just draw it with straight lines. Write the numbers on that you want. If it doesn't matter how long the line is to the representation of the length of it, then
Well,
fuck it, just
that's what
draw it and put the straight lines on it.
that's what I try to ask him first on in reference to what? Like, what am I drawing him on? Anything. And it's like, it's what he did. He literally drew circle lines that some are longer. That's crazy, man.
Just
Yeah,
drew
but
any sort of shape he wanted. He didn't even stick to straight lines.
Yeah.
he also said that the distance is longer. That's why you can't represent it on a plane. That's why he curved the line. And then when I called him out on it, he changed his mind on it.
Well, if you're going to curve it, then why can't it be on a plane? Like, I
That
mean,
too.
That's what I said in the first place.
Just,
There is no problem with curving lines being on the same plane
yeah.
whatsoever.
Yeah, but in his mind, he's curving it because it's too far on a plane. On a
It's
great
actually
circle,
not,
which
is it?
I should have
No,
called them
it's
out on
not.
that too, because they think great circles. On a great circle, it would be longer. That's what he was trying to show there.
But it's an aeroplane. It can do that.
Yeah,
Right?
of
It
course.
literally can fly in that path.
Yeah.
Like,
Yeah,
there's
yeah,
nothing
yeah.
stopping it.
Sometimes they'll go out of their way to catch a jet stream and then
Yeah.
divert back. I mean, just to speed up and then get back on track.
Yeah, I don't, like I say, all we wanted was what the actual argument was. And it failed. He can't coherently put forward his argument.
I think I caught his argument and he didn't like it. I think that is precisely his argument. That on a globe, that path is longer, therefore it cannot be drawn as a straight line on a plane. That's what I think he was saying. And that's why he curved it.
He can't say that though, right? He's forced into the position where he can't say it
Yeah,
because it's ridiculous.
But he put the longest path as almost a straight line.
yeah. It's like, wow, man. I mean, I don't know what to say.
Goodbye. That's what I would say. Goodbye, RC Maesty.
Hey, did Left Lane pipe up at all and tell us how
Nah.
amazing he thought Meisty did?
No, even Left Lane couldn't cheerlead this one.
I think
Come
we're
on,
hoping
Left Lane.
for
Come on,
RC to
Howard.
come back.
Come on, Howard. You know what? One of the comments, did you guys see Howard's comment? Like, non-pilots are challenging a pilot now. Wow, this is really interesting. Like, yeah.
Who is the pilot?
RC.
He's just an
RC is the
entry level.
pilot.
He's just an entry level pilot. It's not
No,
like
but he
he's a
does the
commercial.
curriculum for all of the subjects and teaches the teachers the entire curriculum. I don't know for America
He
or
told
whether it's
us,
just his
like,
little bit. I don't know.
I think he's just the
hour ago
bobblehead
that
that the
he
pilots
was-
put up
yeah.
on their dashboard.
I think he's playing with Microsoft Flight Simulator, and now he thinks he's an actual pilot. That's what I think, by the way.
They call that a crop duster.
I won't tell you what I call a crop duster.
Yeah, I'm about to say too. That's what he did. He came in here and crop dusted, like metaphysically, just crop dusted the room, and they got called out on it.
Oh, he called us over here specifically for this argument.
Just a crop dust, yeah.
Well, I don't know. He wanted to draw some shapes, I think.
Well, see, he's been posting that silly, thing with the distances on it, and that's all he's ever posted. That's the first time he's ever put it to some sort of map.
He'd been like crop.
This was the first time.
Yes, very first. He's always only ever posted those distances that you saw in the beginning. That's all he's ever put out.
Nice. Always like it when we get a
Hey,
picture.
can you imagine?
Pink. Look at the colors.
Sorry,
Isn't it? Go on.
Can you imagine if he posted that and then afterwards saw that that discrepancy and he was just like, "Oh shit! I hope they don't see it. Please, dear God, don't let them see it."
No, he was arrogant enough to call Bev out on being not honest or whatever he called him out on.
Yeah,
Then
and
Bev was like, "All right, let's go for it."
It is actually further, right? That distance that he's got marked at 5.8 is actually longer than that distance he's got marked at 6.8.
It's longer than the 5.920. He's got 5.88 longer than two distances that are marked as longer.
And then he's drawn it even longer because he's gone round in a fucking circle. I mean, that I haven't traced it yet, but I mean, that does look like a quadrant. He's just drawn a circle from one point to the other.
Yeah, you got to use that meme for this one. And at this moment, he knew he messed up.
I think he said something. If you need to give him an equation for the distortion distance, or so the distance distortion, that I haven't got a clue what he was talking about, right?
That's where he screws up on the distortion. What distortion?
An equation for the distortion distance.
That's where I asked him about the circle, and that's what he did a Scooby-Doo. So you are saying that the distance and a great circle would be too long to put on a plane, so that's why you drew it on a curve, right?
No, we go back to that beginning bit that he did as well, because I was biting my lip. He said you can't do Pythagoras, right? But you can use the law of sine, cosine, and tangent, right? Not. He seems to have forgotten that the law of sine, cosine, and tangent come from a right-angled triangle. Like
No, he said you don't use a right angle triangle.
yeah, he said you
so
don't use a right-angled triangle because you can't on a circle or sphere or whatever. Therefore, you use the law of sine, cosine, and tangent, which are also based on right-angled triangles. So I haven't got a clue what he was talking about, right? I don't think he does either. He's one of these ones, like, you don't understand geometry, but I'm not saying that I do, because he obviously hasn't got a clue about what that is. Right? In order to get the sine, cosine, and tangent numbers or figures, it's a ratio that you have to put them through tables to find the ratio of the sides to the angles. You need to have a right-angled triangle in order to get those numbers. So you can't apply it to bent lines because it wouldn't apply. You have to use the triangles in order to use the sine, cosine, and the tangent. It's a right-angled triangle. There's no getting out of it. Sorry, RC. Some people do understand geometry, no matter how much you say.
Oh, Bev, you should really look up things before you say them out loud.
Oh, nice, you've come back. Welcome back.
Yeah, sorry, I had to get my kids a couple of things, but yeah, you should really look up stuff like that before. You can use them with oblique triangles, no problem. There, Bevy.
So does that line represent a great circle? What you draw there without
No,
knowing it?
hold up, Bev. Bev, I want to hear you say, "Oh yeah, I'm wrong. I can use these with oblique triangles."
Yeah, you
Go ahead,
can
Bev.
use the
There we
functions
go.
of
All right, have a good
sine,
evening, Bev.
cosine, and tangent, but they come from right-angled triangles.
Yeah, and you can use them to find the sides, and angles inside of oblique triangles. So go ahead, Bev. I'll hear it for you. It'll be all right. You should look these things up, Bev, before you say stuff like that.
But I don't understand what you're saying right now, RC, because it seems that you are agreeing with me that you do need right-angled triangles in order to use the functions sine, cosine, and tangent.
Now, I will happily recognize, Bev, that yes, your logarithmic functions are a hell of a lot easier if you just have them plugged into your calculator. But you can definitely use them on non-right angle triangles, as long as you start dividing them up, and that's not a problem at all.
Dividing them up into right-angled triangles.
Yeah, good. Yeah, no problem.
So you use right-angled triangles.
Bev, no, that was never in contention. You were trying to say, and you said this earlier, you can play the tape back, that, oh, you can't use trigonometric functions in order to find these lengths. And
Don't
yes,
lie,
you
please.
can.
You were talking to me. And Bev only said that that's actually using right-angle triangles. And you said explicitly that no, you are not using right-angle triangles. That's what happened.
So do you want to just like deny what I just posted, or like you guys want to just keep squawking around?
Who is nobody is denying it. What are you talking about? Nobody is
Good.
denying
All right.
it.
So there's no problem then. Thanks. Bev thought there
RC,
was because he doesn't know
please
enough
don't
about-
try and
because he-
claim
because he doesn't-
feign
because he doesn't know
victory
enough.
out of this, because
No, Bev.
there's
Just
no
because you don't know
victory
enough
for
about
it in it for
using
you.
trigonometry for things doesn't mean that I got something wrong. You just forgot that you can use them on oblique triangles. That's all right, Bev. Don't worry.
Again, you end up making right-angled triangles, right? So the sine, the cosine, and the tangent comes from a right angle triangle, and when you're using them,
Yes, Bev, and can you use them on oblique
you
triangles or not?
break
Can you use them
triangles
on oblique
down
Hey, Bev, yes or no? Can
into
you use
right
them on oblique
angle
triangles or not?
triangles. It's pretty
Bev,
obvious.
can you use them on oblique triangles or not?
You know, you can just drop a
good job, Bev.
you drop a perpendicular from the
Good
honeypoint, and you
job,
will end up
Bev.
with two right
I knew
angle
you'd get it, Bev.
triangles. I mean,
I
We
knew
have a
you'd get
conversation.
RC.
It is spiraling, dude.
Yeah, RC, I don't think the point in contention is whether you can use them on oblique triangles. It's whether you have to have right triangles or not, right?
Put it in
Yeah,
its
and,
place.
and that was the whole point here, is that you can use these in order to find these sides if you'd like, and that was my whole point. And Bev keeps trying to imply that no, you can't. Anytime you got oblique triangles, which is what I presented here, which are oblique triangles, right? Then, or proposed oblique triangles, that you somehow can't use sine, cosine, tangent to start figuring things out, which is just not true.
The functions are coming from right angle triangles. Do you see
Good
what I posted?
job. That
You
was
see what
never
I
part of
posted?
contention.
Well, what is it that you're trying to say then, RC? Please.
Then yeah,
Using
what is your
using the
point?
basics of trigonometry and logarithms, you can find out that hey, these triangles with these sides, they definitely do not fit on a flat plane.
I haven't
Where does the
seen that so
logarithms come
far
into
yet.
play?
And so far, we've got right angles, triangles are needed for using the sine, cosine, and tangent functions because they've come from those actual numbers have been derived from a right angle triangle. And when you are using them within oblique triangles, you are then breaking that oblique triangle down into right angle triangles so you can use the functions.
Does
right?
that
Which is
negate
exactly what I've said, RC,
Does that negate
from the
anything I
beginning.
said, Bev, does that negate
You
anything
cut me
I
off.
say?
It's all right. Don't worry about it.
Bev, does that negate anything that I was saying?
I don't know what you were saying.
I think both of you are saying slightly different points that each other agree with.
No, Emerald, no. RC's come in with a really ridiculous point, and I'm just pointing out that if you are using any of these functions for triangles and sine, cosine, and tangent, you are using right angle triangles. Now,
And you can derive right angle
those
triangles.
right
Don't cut him
angle
off, RC,
triangles.
please. That's 3 times now.
Those right angle triangles that you are using have a right angle in them and 180 degrees. That function
No,
of
they don't.
those triangles are based on that. That's all
And
I'm saying,
these
right? Okay.
and these triangles do not, that I gave you with the points and the distances that I gave you, do not in any orientation work on a freaking flat surface.
Not
I
triangles.
haven't shown that whatsoever.
You're saying they're not triangles. RC.
These three sides, they definitely do not share the same plane.
So those 3 coplanar points you're saying of a triangle are not coplanar.
Not with these distances.
The distances stop them from being coplanar.
No, remember, we're not talking about 3 points.
Would that be the length of the side of the triangle stop it from being coplanar and having 3 coplanar points? RC.
No, the 4th and 5th point that I gave you is what buries you.
Just
and that's
talking
why
about
you're
the
avoiding it.
triangles to start off with. Let's start off at the basics.
Bev already walked you through it about 6
Just the
times.
triangles. Are you saying they aren't triangles? Or are they triangles for starters? Like, can we have that? 3 points. Is it a triangle or not?
These 5 points that I gave you.
3. Just start off with 3.
Bev,
We'll
Bev,
add the 4th.
Bev, are you gonna let me respond or no?
Well, can you answer the question?
Hey,
please?
where
We'll
were
just
you?
start off with
SD,
the 3.
with the interrupting before. Man. Seem to be
Answer the
silent now.
question, Maisty. Answer the question, please.
I was trying to. He's interrupted me twice now.
Because he anticipated you were going to answer a different question. Let's try to
Oh,
stay on
so?
topic. Point taken. Go ahead. Go ahead, Maisty.
Is it really taken? I doubt it. No. You guys can play. You guys can mire around in the muck all you'd like. I'm not doing it.
Scared girl. Scared.
What am I
Answer
scared about?
Let him
Answer the
answer, bro.
question.
Let him
Sorry.
answer.
Ask a question. What's your question?
The 3 points, do they make a triangle? For
Yes.
starters. Okay, right.
Yes.
Now, are you saying that those 3 points for that triangle are not coplanar?
Not with those sides, no.
Okay, so the sides of the triangle stop it from being coplanar.
Yeah.
Okay.
Yeah.
Yeah.
Wow.
Well, I guess
Because the sides are curved. Because the sides are
back
curved.
to
The
back
sides
to-
are curved.
So it's not a triangle then.
That's a spherical triangle.
Spherical triangle. That one you never mentioned ever, like in the past 1 hour.
No,
By the way.
I think I know what he's trying to say. Where basically, if you have a triangle on the surface of a spheroid,
It's not a triangle, is it?
It is.
well, no,
That's not a
I-
triangle
Spherical
anymore.
triangle.
they're going to call it a spherical triangle.
Right. That's what I.
Yeah.
Right.
I'm gonna call it. You know why? Because you cannot use
Listen,
the sine and
that-
cosine functions for
Travis,
that.
you're roboting.
Exactly.
Okay.
That's exactly what I.
You're roboting, dude. Sorry. Go ahead. What's up?
Or do you think, Platypus, that you can use the sine, cosine, and any other logarithm for a triangle that is a spherical triangle?
I'm sure that you could. I'm the straight up answer. I have no clue. I'm not very good with like spherical geometry or whatever the hell it is you guys are doing. I'm more of a basics kind of guy. I understand that there would, however, be some sort of limit where you'd have a non-spherical triangle, but then if you get the legs or whatever you want to call it of the triangle, the sides of each triangle, once you get them long enough, if they are on a sphere, then they would have to curve, which would eventually make it a spherical triangle. My question, I guess, him would be: Are we talking about? Are the triangles? Because I came in halfway through the discussion, so forgive me if you're going to have to go over something. The triangles that he's describing, are these supposed to be triangles that actually fit on the Earth?
That's the point that I was trying to make earlier, right? This isn't difficult, right? Every time you use sine, cosine, and tangent, the function of those triangles is based upon a right-angled triangle, right? Also, it happens to be the same as the Pythagoras, right? It may be for something to do with it. There may be a geometric link between the Pythagoras' formula, a triangle that for the trigonometry and the sine, cosine, and tangent, and the fact that it has 180 degrees, right? And you can predict all of the other things around that, but it's all based on a right-angled triangle that has 3 straight sides and 180 degrees internal angles, right? If you don't have that, none of this works. None of it. You
None.
can't use anything if you don't have those
Literally,
things.
by the way.
Yeah. It's no joke, right? There's no need to look anywhere else. This is the literal proof within geometry that you can get given. But you need need triangles, straight lines, 180 degrees, 3 coplanar points.
See, I'm a very hands-on visual learner, so for this to make any sense to me, I would need to have someone say, "Okay, hey, I'm a land surveyor, and I'm about to measure this distance from A to B, and I'm going to do that 3 times and make a triangle, but the distances are going to be, then they would say, okay, the distances are so long that it creates spherical triangle. But then I would say, well, wait a minute. How are you seeing over a curve? You know what I mean? You can't.
Oh,
You
that's
you
don't
can't.
go there. No.
Yeah, yeah.
Yeah.
You
You
just
sort of
can't.
What
going
I was
into
gonna-
going into their game, right? If you've got a curved line, you don't have the triangle, and it's not as short
Anymore,
as
and you
straight line distance.
cannot. Again, if you do not have a 2D simple triangle, right angle triangle, then you cannot determine a distance based on, let's say, one angle and one side. You cannot.
And RC
Not anymore.
and RC left again.
Yeah, RC left
he
like
didn't
10
wanna
minutes
hear it.
ago again. Yeah.
Oh my
Yeah.
bad. I might have
Could be
scared
his
him off.
kids.
He's back.
Give him a break.
Oh, he's
back.
typing.
Yeah, no problem with that.
Nah, he's
Oh,
Oh,
Yikes.
bad robot, Travis.
Domo arigato.
I don't think he's
yeah, we had to create a remix for that. Ooh.
he's
You're still doing
typing.
it, bro. Sorry, Travis.
By the way,
You must
he's
be driving through that
adamant
state again.
He's adamant not to talk about the original question whatsoever, right? Comes back in and tries to talk about triangles for the fuck of reason, by the way. I'm sorry.
Yeah, he doesn't want to go to that great circle thing that he drew.
Oh, the longer and shorter and the shorter and longer is what he doesn't want to hear again.
Yeah,
in my
yeah,
opinion.
that, exactly.
That's just, it messes with you.
But also his original statement, which was, it's longer, that's why you can't draw a straight line. Remember his original challenge? Was to do what he did using a straight line, and then he showed us what he did using a curved line.
Yeah, by the way, he was all the way through for like 20 minutes, was talking about simple points, 5 points, and drawing simple straight lines in between them. And then he came up
Exactly.
with that. Yeah, you're right, yeah.
Bada bing, bada boom. Just answer the question. It's easy.
Yes, sir, Red.
I mean, for me, it's not even about, destroying RC or even his
No.
argument, but, presenting to others that this is a fucked up way of thinking.
Yeah, this is not personal to any, this is just logic.
That this kind of method, or whatever he puts behind this kind of image based on the skyvector.com, is just not what he thinks at all.
Yeah, I don't like looking at that drawing and trying to think what he's trying to prove with it. You think like, okay, let's look at it logically and think, what's he trying to say with that drawing? Right? Is he trying to say you can't draw triangles? Well, you definitely could draw triangles from each of those points. Like you could do straight lines. What would that prove? Nothing.
Did you see what
Nothing
he just
regarding his
reposted?
original argument.
Yeah. It's a nonsensical argument, and just trying to get exactly what we came for was to try and find out what his argument was. We're at this point now. I still don't know how he was formulating an argument to put it forward. That still doesn't make any sense what he was trying to say, but I think we have learned that RC doesn't really understand trigonometry and the triangle function and what it's meant to prove. I mean, it bears absolutely zero relation, any of the sine, cosine, and tan functions, that they just don't apply to spherical geometry. They only apply to right-angled triangles.
Do you think you'd find any of these trigonometric functions on the wiki page for spherical geometry?
Circle geometry. I mean, that's different, right?
Or, sorry,
That's within
spherical.
Euclid.
I meant to say spherical. Sorry.
Spherical. Okay.
Okay. So you know
Spherical
where
geometry.
you know where the tangent function comes from.
Yeah.
Well, is there a tangent in spherical geometry?
I suppose it depends.
What do you mean? That sounds a bit vague. Mathematics doesn't do vague like that, does
Well, yeah.
it?
I mean, the mathematics isn't vague. My, complete understanding of it is vague.
Okay. Well, you know what a tangent is,
okay.
right?
Yes.
Okay. So what is a tangent?
Ratio of opposite to adjacent of a right angle triangle.
Okay.
Or do you mean
know,
like a tangent line?
Well, exactly. Do you know why it's called a tangent? Why that's called the tangent function? And a tangent is a line. Do you know why the relationship of those that seem to have the same name within geometry, right?
Mm-hmm.
Do you know why they have the same name?
Yeah. You can get you can equivalently formulate the tangent as the length of a line segment from tangent point on a circle to the x-axis.
Yeah, because the tangent function is based around the position of the right angle in the right angle triangle of the semicircle. And that is what you would call the tangent point, because it's where the right angle touches the circumference of the circle. And the function of that line is the tangent, right? It's the tangent point. That's where you put the tangent line that is perpendicular to the radius at the point that it touches, where the tangent point is. And that moving around the circumference of the circle gives you the ratios of the sides and obviously the angle within the right angle triangle. Since the right angle, which is where the tangent point is, that angle never changes. It's always just the ratio of the sides, the tangent function, right, within the logarithm tables of the but don't worry about that, right? The point is that it's a tangent point, and then the tangent line that's associated with it. That's what the bit you should be worried about within the tangent function, because that's all based within the circle, the tangent, the sine, and the cosine, right? But you don't have that in spherical geometry, do you?
I mean, if you construct, say, triangles from the center of the sphere to points on the surface, then you can construct triangles. But I see what you mean. Just points on the
Euclidean.
surface themselves, it's not like immediately apparent.
The moment you go into the sphere, you're making it into a three-dimensional object, and then you're into Euclidean. You're talking about a Euclidean three-dimensional sphere.
Sure, yeah, we can derive relationships about lines on the surface by taking advantage of Euclidean geometry, for sure.
No, you can't. You've got spherical geometry. That's all you've got. You've not got Euclidean. You can't have non-Euclidean geometry containing Euclidean. This is why
it's not containing. I mean, in spherical geometry, right, we care about just the surface. But
that's why I was asking about the tangent.
Yeah.
Right. So how do you relate the tangent to the surface?
Yeah. Well, what I'm getting at is spherical geometry is restricted to the surface, but we can also use Euclidean geometry on, say, a 3D sphere, figure out what the things look like on the surface, and then just sort of borrow those formulas and use them in spherical geometry.
You think?
I mean,
that's not the way geometry
it's not illegal.
Yeah, it is. It's because that's what
And
makes spherical geometry not a true geometry, right?
I wouldn't say it's not true. It's not Euclidean for sure.
It does. No, it means it's not a true geometry. It's definitely not a true geometry.
May I show you something, Emerald?
Sure.
Quickly.
Yeah, go on.
So, what is the first sentence that you see on the wiki page regarding spherical geometry? Do you know, maybe?
Oh, sorry, I'm on the wrong page. Spherical geometry is the geometry of the two-dimensional surface of a sphere.
The what? The two-dimensional surface of a sphere, right?
Yeah. Mhm.
Okay, what does Euclid say about a surface of a sphere?
What does Euclid, like the person, say, or are you asking more generally about what Euclidean geometry says?
Euclidean geometry. That's what I mean, of course. Yeah.
I mean, sure, it says a lot of things. I mean, there's a lot of things to say about the surface of a sphere. I don't get, like, what do you mean the thing it says?
It's literally one thing, and it's very adamant and precise. It says that a surface of a sphere cannot be developed, right?
Okay, so I will agree with this, but at the same time, the pedantry in me is saying, well, that's not the only thing it says. So it wasn't quite a well-formed question. But
my question is that a contradiction to you or not?
No. It is a non-developable surface. That's correct. This means that you cannot take
Like
a set of points on that
surface
on the
is
sphere.
an undevelopable surface, right? Non-developable or undevelopable.
Correct.
It doesn't matter. But then why do we have a geometry that is talking about a surface of a sphere?
Yeah, because the surface itself is, and I mean, we can still try to derive relationships between angles and sides and stuff like that on a sphere. The fact that we can't do that in a Euclidean sense is why spherical geometry is separate from Euclidean geometry. The spherical geometry is, in a sense, a geometry in which the sphere is developable. Because
have you
it's
heard about
designed
the
basically just for
it?
Okay,
Have you
real
heard
quick,
about
why
the
are we
thing
talking
that?
about?
Okay.
No, wait, I want to get this because this is the first time we've ever had a chance to do this. So when you say it's a two-dimensional surface, do you mean like a plane surface?
No, I just mean in the sense of the word dimension as the number of units needed to describe positions uniquely.
Right. So length times breadth is what everybody who's
Mhm.
probably listening in right now would think whenever they hear two dimensions, right?
2D.
Sure.
Okay,
Yeah.
2D.
Those come to mind.
Okay. So now, is that the surface that you imagine the sphere, the spherical geometry is done on? A two-dimensional surface, the two-dimensional surface that everybody's thinking right now, is that the surface of a sphere that you're thinking of?
I mean, I'm thinking of if you say the surface of a sphere, I'm imagining the surface of a sphere. And I'm imagining it as two-dimensional in the sense that it takes two coordinates to define positions on it.
Right. So
I don't know what you mean.
changing
Right.
from
The confusing part
length
to me is when
times
you say
breadth.
the two-dimensional surface as if there's just one.
Well, that's if you read the spherical geometry, it's the geometry of the two-dimensional surface of a sphere, right?
Well, yeah, because a
Well,
sphere
that's
has
the-
one two-dimensional surface.
Okay, right. So that two-dimensional surface that you're thinking of, is that the same two-dimensional surface that you would know about and have been taught about what a two-dimensional surface is? Like, let's say a circle, a triangle, a square. Those shapes are two-dimensional shapes, right?
Yep.
Right. Now, the surface of a sphere is two-dimensional. Like, does that work when you can say a circle is a two-dimensional shape and the surface of a sphere is also two-dimensional? Does that compute to you?
Yep.
Right. I don't know about anybody else, but anybody listening in, I can't say that
Me neither.
a circle is a two-dimensional shape and the surface of a sphere is two-dimensional. That does not compute in my head. I cannot do that. So can you please explain how you can have what I would call a sphere, three-dimensional shape, being represented as two-dimensional?
Sure. I mean, this might just be because I have a lot of math background that, I think things in terms of the formal definitions more than I do the colloquial one. But to me, dimension is just the number of coordinates you need to uniquely define a position. And so, like, if you have a circle, you can define it in X and Y, or you could choose R and theta. You could choose, a system in which you map points on a circle to like two numbers, essentially.
But
And you could do the
everybody's
same thing
thinking
to the
now
surface
X
of a
and
sphere.
Y.
What's that?
That's what a graph is. Like whenever you did a graph in school, X and Y, that's a plane, right? That's not curved like a surface of a sphere.
That's right. Yeah, I mean that's
So
an
how
example.
can you
There are
represent it
non-curved.
like that?
Yeah, I mean any surface that you can represent with two coordinates is two-dimensional by definition, essentially. And
But you can't represent the surface of a sphere in an XY thing because, again, he just said, sorry, what's up just said, it's a non-developable surface. That means it cannot be expressed on a two-dimensional plane without distortion, right?
That's why I brought
distortion
it up.
is irrelevant for the number of dimensions of an object.
No. So you are
No,
saying
no.
you can express it on a two-dimensional plane that everybody understands, right?
You can flatten a sphere, it's just you'll distort it.
Okay, so that when we say the two-dimensional sphere, you're doing the geometry of the two-dimensional surface of a sphere. You are thinking of the two-dimensional surface that everybody else is.
I mean, just because you can doesn't mean. I mean, I don't, natively think about the surface of the
What we'll
sphere
go
as
back
a
to then-
projection onto the plane.
Okay,
I mean,
we'll
you
go
can
back
if you
to
want
the
to, but
tangent. The tangent that I asked you about at the beginning. How do you fit a tangent to that two-dimensional surface of a sphere?
what do you mean fit a tangent to it?
Well, you know what a tangent is?
Sure.
Okay. Now, that tangent and that line that is associated with that tangent point of the circle, right? Now, you've represented that as a two-dimensional surface. How do you put a tangent to that surface that you're talking about, a two-dimensional surface?
I mean, the same way as you're drawing, if you put out your graph paper and you draw a circle and then a tangent line to it in a Euclidean two space, you have your curve and you draw a tangent line to it, draw some curve on the surface of the sphere, and then construct I guess it would be the geodesic or whatever the, similar equivalent to a straight line would be tangent to that on the sphere. I mean, it's a similar construction. It's just imagine that your graph paper is wrapped around the surface of a ball and thus distorted.
Two-dimensional.
That's not 2D.
Mm-hmm. He's right. It's not 2D.
The space in which you're
wrapping
working,
around the
well, sure,
ball.
yeah, because paper is clearly not actually 2D. But if you're following the
Then don't
abstraction, which is the
make that
mathematical version of it, then
as
it
an
is.
analogy. Then don't make that as an analogy because we are talking about 2D. Because you said that it's 2D. The surface of a sphere is 2D. Then all you got is 2D, okay? You're not wrapping it anything or anywhere.
And
Right, it's just a way to imagine
Please don't
it.
say ball either, because ball is the three-dimensional Euclidean shape, right? It's a sphere
right.
in Euclidean three space. So please stick to the two-dimensional surface of a sphere if you're talking about spherical geometry, which you are, right? Because you're not talking about Euclidean, are you?
That's correct.
Okay, now the question to you is, how do you put a tangent and associate it with the two-dimensional surface of a sphere?
That's still a very vague question.
Do you not know what a tangent
Because
is?
a circle, I know what a tangent is.
Okay,
And
now
the,
do you
the
know
example
what a
you gave earlier
two-dimensional
was
surface is?
the example you gave earlier was drawing a tangent to a circle.
Mm-hmm. That's a two-dimensional shape.
The shape is.
Yep.
You're drawing it tangent to the the edge or the boundary of that, I guess you could say.
Yep. So now
But there's not really a boundary as such to a sphere. It's just kind of all the same surface.
How do you associate a tangent to that then? That's the question.
Yeah, you would have to associate your tangent to some construction in that space. Like if I were going to draw a curve or a circle on the sphere, then I could draw tangents to that. And of course,
Just real quick.
Yeah. What's up? Or not the person, but whoever just asked.
Buster, I think, wanted to ask something, if I heard
No.
correctly, but no, it wasn't.
Did someone have a
No,
question?
Travis again? Oh fuck.
Yeah.
Gone solid green there. Travis.
If I can
Oh,
It's not
robot.
gonna work, dude.
remember, you said
Bad
something
robot.
about Bev's question.
Yeah.
Can you
Yeah,
guys not
not
hear me?
understand.
Oh, we can hear you.
Am I not coming
No.
through again?
You're still swimming.
You're coming through kind of okay. Like we heard you when you asked, are you coming through? But
That's
That's
short.
all we heard.
He did it with his
That's-
mic
yeah.
on mute, though. I don't know how he did that.
Yeah,
don't
I
know
saw
what's
that.
going
Sorry,
on.
Mike.
sometimes the packets get sent out
Yeah.
and they're so slow that even by the time you've gone on mute, it's still
Okay, so
traveling. Then the
are
sound
you
gets there later.
are you going to be able to say pretty soon that you cannot have a tangent in spherical geometry? It doesn't exist. It
I mean,
cannot exist because you've
in a
only
general
got a
sense,
two-dimensional surface to deal with.
I mean,
You can't put a tangent to it. You have no vertical. It doesn't exist in your geometry.
in a general sense, a tangent is a line that touches another figure at exactly one point. You can construct such things on the surface of a sphere. I could draw a circle on a sphere and then draw a great circle that touches it at only one
space,
location.
yes. In Euclidean 3 space, we all know what a sphere is, like a ball, and yes, you can have a tangent to that. But that's not what we're talking about. We're talking about
I know. I'm talking about just in the spherical space.
Yep. So can you have a tangent in that geometry?
Yes. Just as you can draw a line that touches a figure at one point in Euclidean geometry, you can do a very similar construction in spherical geometry.
Okay. With the sphere as being the canvas.
Yeah.
And the tangent would be a straight line?
Whatever not straight, I guess, in the colloquial sense, but a geodesic on the surface of the sphere, yes.
So not a tangent then, right?
Well, it's tangent in the formal definition of the term. You're clearly not going to get, Euclideanly straight lines on the surface of a sphere. So if that's what you were asking, then no, that's not possible, but that should be obvious.
The tangent is only touches the surface at one point.
Right. You can construct
the
two
whole tangent on the.
You can construct two lines on a sphere that only touch at one point, and thus, by definition, that's tangent.
On a two-dimensional surface, you can draw a line on a two-dimensional surface and have it only touch at one point or 2 points.
I guess to motivate the example, you have a great circle, which is just a line essentially in spherical geometry. You then draw another great circle such that, it only touches that great circle at one point. I guess a way of, I don't know, I suppose imagine a line of the prime meridian. Let's suppose we take that line of longitude as a great circle around, the globe or whatever. And then suppose, someone walks in a circle, just like a tiny little circle in their room, such that only one part of that circle touches the prime meridian.
Mm-hmm.
Then that prime meridian is tangent to that small circle at that point.
Wow. Is that because you've turned a circle into a straight line on a two-dimensional plane?
Well, no, it's just because that's how you construct a tangent. They intersect at exactly one point. Okay. It's not really turning things. It's
since that straight line returns back on itself, then it would touch that circle infinite times, right?
That is a good point. And I don't know if this is taken into account in terms of when a tangent is defined, because I don't think that I think when it returns, I think that point is still the same point, and as such, it wouldn't count as more than one.
Does it not sound like you're redefining the word tangent?
Well, no.
And
I mean, the
straight
definition is rigid. The question is whether or not
or
this.
straight, sorry.
No, the question about this is whether the line looping back is considered to intersect at a different point, or if that's just the same point.
Okay. That's the straight line, though. A circle straight line.
Right. Yeah. A great circle.
Is a straight line.
Is well. It's the equivalent of it. It is.
Yeah.
It
Would be
doesn't
the equivalent
turn.
of a horizontal?
I mean, I guess depending on your definition of vertical, if you consider vertical to be, I don't know, like north, like a meridian, like a line of longitude, then maybe in some sense you could consider the equator to be horizontal because it's it's perpendicular to that vertical.
Wow. So that circle that you've drawn that you've called a straight line that some people want to call level because they want to draw tangents to it. You've just expressed to us that you can't actually draw a tangent to it because it doesn't exist. And that straight line that you've just drawn, you would call horizontal anyway because it's a straight line. So that may be that you've just had the confusion that people have between level and horizontal all along, right? Some people imagine horizontal as being a straight line, actual straight in reality, and the other people imagine that straight line as actually being a circle in reality. Especially if you've got a confusion between spherical geometry and Euclidean geometry.
Yeah, it sounds like you're sort of flipping between them, right? Because when you're talking about what I think you're referring to when you say that folks will take, level as a great circle and then draw a tangent to it, now you're talking about, a tangent to the sphere in 3D, which is not what I was referring to. It sounds like you've changed back
about the two-dimensional surface of a sphere, weren't you?
Yeah.
Yeah.
I was. Yeah, I was talking
you did
strictly
say it was
in
a straight line, a circle.
Well, yeah, geodesic, close to the. I mean, I don't want to try to
call that level.
I mean, what's the notion of level here? Level is like a notion in the 3D world. It's not exactly something we define in spherical geometry
The surface of
on
liquid
its own
water.
per se. Yeah, the surface of liquid water is a three-dimensional thing because there's waves and such. It's no longer just strictly in spherical geometry, so it's kind of off the rails from what I was talking about.
Okay, well, we were talking about a straight line, and you said within your two-dimensional geometry, the concept of it, whereas you still had it as a circle, and then you had another circle oppose it. Well, two circles opposed sort of show that you've got an extra dimension in there, right? You can't have both of them having two dimensions if they're opposed to each other. They're
not really opposed per se. They're just, I mean, in the same way that in 2D, like Euclidean geometry, we can have two circles just touch at one point. It's sort of a similar thing, except in spherical geometry, one of those circles just wraps around the whole thing.
Yeah, but you realize that once you get two circles and you oppose them, right? You have up, down, a top and a bottom of the circle. You've got a left and a right, and you've also got the depth factor to the other circle that's opposing it. So you have three dimensions. You don't have two. You've got three.
Well, no. Well, for one, I mean, I'm still not sure what you mean by oppose because that's not really a geometric term here.
Is it not?
I mean, it doesn't sound very well defined unless you could give me like a formal definition.
Well, you can't have the. Well, okay then. The planes of the circles are perpendicular to each other.
I would say no. If you draw this in 3D with if you had a beach ball and did this, then in 3D, those planes would be perpendicular. But in just the spherical geometry, there's not really that notion.
I was just talking about the circles that you were. When you said you had a straight line that was a circle, I was just saying, let's get two of those straight lines and oppose them. Now, in order for me to give you that representation, I said oppose. you said that wasn't good enough. And I said, well, let's propose that these two circles are actual circles, two-dimensional things that we all can understand, and then put those planes, put the center points together, right? All the centers together, but make the two planes of the circles that we've just made perpendicular to each other. Just so you can get a grip on it. But that's just really, in your geometry, spherical geometry, it's just two straight lines, isn't it?
Yeah, two
It's not
geodesics.
actually, but
I
I'm
guess
saying that you do have a top and a bottom and a left and a right on both of those circles.
so. To make sure I
even in
understand
your
this right, you're talking
imagination-
about like if I took the prime meridian and then like 90 degrees east or west, right? Like two rings that are perpendicular to each other.
See, now you
When we
are
meet at the poles.
physicalizing it. You're
Well, right,
physicalizing it, aren't you? You're doing that.
I'm trying to
keep
make
it
sure that
within
my
geometry.
visualization matches yours.
Okay.
Is that what you were kind of getting at? Two great circles or two straight lines with
So
scare
just two
quotes
circles opposed.
that are
Yeah.
okay.
Right. So when you have that, that surface you still want to have as two-dimensional.
Well, yeah, you can
Right,
express those as two lines in spherical geometry.
Okay, so now if you wanted to physicalize whatever it is you're talking about within your spherical geometry, could we put water there as that surface that you want to have with when you do physicalize it, the two-dimensional surface? Would water be a good representation of that?
Sure, I suppose.
Okay, now a water level is a tool, right, that establishes a horizontal. So this is where we're going back to. The straight line that you have, a horizontal, is a straight line. But you've just made it into a two-dimensional surface and turned it into a circle, that straight line. I'm saying, when you have that straight line that's actually a circle, can you relate that to level and the horizontal that is a straight line?
So when you say horizontal here, we're back in 3D, right? As in like, the tool
Level,
water
yeah,
level being.
We're in reality. Yeah, we're always in reality, right?
Yeah, I would distinguish them. I would say that something following that great circle route would be level.
So curved.
And something, yeah.
Okay.
And then something following just the horizontal would be horizontal and straight.
Straight, but straight as in straight, not your circle straight.
Right.
Okay, so what you're having level as being circle straight, but it's not circle straight. It turns back into a curve.
What do you mean turns back into a curve? In what
You
sense?
said level was curved as opposed to the horizontal that was straight.
Yeah.
Yeah. So that level is what you call a great circle.
Sure.
But you call a great circle straight, not curved.
Yeah, in spherical geometry, it's straight as in. This is why it's easy to get confused, and this is why I don't like saying straight line in spherical
I don't want to
geometry.
confuse you. Believe me, I want to try and simplify it for everyone. Right.
Right.
Okay.
I would say that the great circle is only straight, quote unquote, in the sense that it's the shortest path between 2 points on it. It's not. I mean, it is only in that sense, like considered straight. So that's why I like using the word geodesic for this, because that's sort of more formally what it's getting at. But yeah, if you take that great circle and now we're plopping it on, in a physical world, then it forms a circle.
Not a straight circle.
Well, I mean, a circle in Euclidean space. Like that great circle is curved.
Yeah. I know circles are curved. I'm not so sure you've said the right thing there or not. I mean, I don't know if anybody
I might have.
is left lane Kosho's in
Yes.
here. I don't know who's the authority. Are you sort of the
I think you
authority
did
on
fine, Emerald.
geometry?
You know, Emerald, this is a bad analogy, but you know what you were saying though, because I'm the same with you, Emerald. I don't like to use straight line.
You don't
to
really know
confuse people.
geometry.
But Emerald, you know, one thing I know they call people actresses, actors, actresses. Imagine actress wasn't a word, and you were just referring to Whoopi Goldberg, and someone
Oh,
was
come on,
describing her. You could say that she's an actor, even though everyone knows an actor is defining a man. You know that in the context of Whoopi Goldberg, you don't mean she's a man, but she's the same thing as a man who is an actor. That's the same thing. It's like a geodesic is not a straight
That
line.
would be a
But
thespian.
it's defined. It's defined the exact same way a straight line is defined in Euclidean geometry. It's just it's not going to look the same way because it's a different thing. So that's why
So it is a
no
straight
one really
line
calls
now.
it. No, it's analogous. It has the exact same definition. It's the shortest distance between 2 points, just like a straight line is the shortest distance between 2 points.
Yeah.
The only difference is because the surface is something that's different than was talked about in Euclidean geometry.
Right.
It's not going to appear to be the same thing as a straight line is, even though they're defined the same way.
I guess maybe a different way to put it is a geodesic is a more general term that means a shortest path between 2 points. And in Euclidean geometry, that coincides.
I got an easier one. I got an easier one for him. It's like
Talking
this.
about the relationship between a straight line and a curved line and a circle.
Bev, a square is a rectangle, but rectangles aren't all necessarily squares.
Yeah, brilliant.
It kind of lines right up with the idea, though.
It's got nothing to do with a straight line being confused with a circle.
Yeah, I mean,
They're both rectangles.
Absolutely
One of
not.
them presents itself differently. That is the same thing.
What? A circle can be the same as a straight line?
No, the other guy saying that, no, it's actually not. It's likening to that, it being that they are both rectangles and one is expressing itself differently as a square.
Yeah, well, a circle cannot
The real
express
problem
itself
is
as a straight line.
the definition that Emerald just said for the geodesic is not true.
Yep.
What is the full definition?
Let me go get the full definition.
But because according to you and what you said for 3 times at least, is that it's a straight line. The shortest distance in between 2 points. That's not the definition of a geodesic. Can you
A
be more
geodesic is a
precise
locally
and
length
actually
minimizing
tell me?
curve. Length
Also,
minimizing,
it even
as in shortest
contains
distance.
the word curve.
Yeah, exactly.
Great.
Got curve in it. Yeah.
In
Yeah, the
geometry,
same way the
a
straight line-
geodesic is commonly a curve representing in some sense the shortest path between 2 points in a surface. This is straight from the wiki page for it.
On a what? Surface of a sphere, right?
Just in general.
No, on a surface.
Between any 2 points
it
on a
doesn't have to be a
surface.
sphere.
That's what I meant
Like
by geodesic is a very general term.
So you
In the-
can have a geodesic on a plane then, right?
Sure, yeah. In Euclidean
Brilliant.
geometry,
Okay, that's
a
good.
geodesic...
So a geodesic is just the shortest distance between 2 points.
Yeah, pretty much.
Right.
And in
Brilliant.
Euclidean
Let's go with
geometry,
that.
it coincides
That's
exactly
also-
with the notion of a straight line.
Well, that
in
is exactly what a
non-Euclidean
straight line
geometries,
is.
well, yeah, in non-Euclidean geometries, it doesn't necessarily coincide with a straight line.
Yeah, but if it is in Euclidean space, then it is a straight line, and there's no problem us calling a straight line a geodesic, right? There's no need for us to think that a geodesic has to be a circle when it's just the shortest distance between 2
It
points.
doesn't have to be a circle. It just
Okay.
happens to be on a sphere, a geodesic. A great circle is a great circle. So that's
Yeah.
what it does on a sphere.
That's
Just like
fine.
on a plane, it makes a straight line.
Yep.
Yeah. So, but these things are analogous. Is the point? These things are the same thing, just on different surfaces.
Yeah.
Right,
that's
yeah,
good.
so in the
That's why
different
he's using that word
geometries,
interchangeably.
in the different geometries, the notion of the shortest path between 2 points changes because you're adding this
But
extra
there's
constraint.
no need to change geometries, though. Is there?
There
I mean,
is.
like,
If you're
why
if
do
you're
you need
describing
to
the surface
change
of a
a
sphere, you're
geometry?
gonna have to change the
Well, yeah,
geometry.
there's no ultimate need to, but I mean,
Well,
if
that's
you
good
do,
then. Like, there's no need to talk about other geometries then. There's no need for us to imagine the surface of a sphere as two-dimensional, and there's no need for us to imagine that straight lines are actually circles if the shortest distance between 2 points is also a straight line. Because the trigonometry that we use is the shortest distance in a straight line, normally a horizontal distance, which is a straight line. And as we know, trigonometry works in reality and triangles have 180 degrees in reality. Then we can just carry on going along with the shortest distance between 2 points as being a straight line.
sure. I mean, but there are cases when you would like to have constraints on your distance problem. Like the shortest path, like if I were going to navigate somewhere and I have Google Maps open and I'm given the choice between whether I want to walk or drive, the shortest path will either be, a street or a sidewalk. And those might have different lengths. Like depending on what I'm constraining my path to, my shortest distance might be different. So if you're constraining your path to these,
though, they definitely, right?
right, yeah, they
Those
won't
are
be
actually
straight in a
straight
sense.
lines.
Yeah.
Right. So in a similar
he's
sense, if I'm
helping us.
restricting a path to the surface of a sphere, my shortest path might be different.
Why would you do that?
If, I don't know, say in a weird hypothetical world, you lived on a giant sphere and wanted to path across it in the shortest distance, then you would want to use
when you want to go from
spherical
A to B,
geometric.
are you imagining that you are walking in a non-reality reality? Or what do you what
I
did
mean,
you
I
just
was
mean by
hoping
what
that
you
the
said?
tongue-in-cheekness of that statement would bleed through. I
Yeah.
mean, if
Well,
the world's
that's what I mean,
roughly
yeah.
spherical, then shortest paths of travel in reality would correspond to spherical geometric shortest paths and not just Euclidean. Like the Euclidean shortest path between 2 points on a sphere would be digging a tunnel. And so that's not, always feasible. So we don't always care about just the Euclidean shortest path. But you're right. I mean, we absolutely don't need to. We could still, albeit more arduously, find, using Euclidean geometry alone, the shortest path. It just might make the numbers more complicated. We're not required to switch
You're
to
using geometry then, right? And since we can use geometry to work out like start off with the straight line, right? Could you use in reality geometry to prove a straight line? And in that proof, would it be a straight line, straight line, or would it be a circle straight line?
What do you mean
Like,
by
how would
prove
you
a straight line? How do you
Yeah.
prove a geometric object? What does that mean to prove a line?
Geometry.
So to prove a line means geometry?
No.
Can you do a little better?
Dude, wait a minute. The question was, can you prove a straight line? The question. I mean, you've probably never heard of it before.
My clarification / follow-up was, what do you mean prove a line? Like you can prove a theorem or you can prove, a fact, but what do you mean to prove a line?
How, within geometry, how would you choose to prove a straight line? Could you do that?
You just re-asked the same question.
I'm asking you because if you don't understand the question, then I'll have to confirm it, right? Do you understand the question or not? Can I?
For like the fourth time, no. I don't know what I don't know what you mean by proving a line.
Stop talking, and I will try and explain it to you. Right? Geometry is a book of proofs. Those proofs are built upon things that you can practically do, right? It's an exercise that you do to prove things, right? Now, proving a straight line should be one of the most simplest things. I mean, it's not even done within geometry, right?
I mean, you had me for a bit. Like we prove facts about these structures. Like we can say we can prove that the circumference of a circle is pi times its diameter. That's proving a like true false statement. You're given some question, is this fact true or false? And a proof gives you a definitive answer to that. I don't know, like when you say prove a line, though, like a line is not, in my mind, a question or a fact or anything that gets proven. It's an object.
A straight
It's like
line.
saying, how do you prove a hammer or prove any other object?
Well, would drawing a triangle with straight sides and then you working out and measuring those sides of the triangle, if those angles add up to 180 degrees, do you think that might be a proof that you've used 3 straight lines in order to make that triangle?
Possibly. So you're saying like if I don't
there
look at the
is-
line,
there's some ways, right? There's that surely isn't the only way. That was just a quick one I thought of.
well, right, yeah, and this makes
Right,
sense to me because this was phrased as a proof, relevant question, which is this triangle constructed of lines? That's a question to which there's an answer, and I can prove the answer to that.
I asked you if there was you thought there was a way to prove a straight line, and you
Yeah.
couldn't think of one. But then I showed you one, and you said yes, that could.
That's not proof. See, there's a difference here in what you're
those are
saying.
straight lines.
On one hand, there is prove that this triangle is constructed out of straight lines, and then there's what you've been saying over and over, which is prove a straight line, which is much uselesser of a statement.
So right, okay, so we can prove a straight line. Now, if we can have a straight line, can we then prove that we can extend that straight line in a straight line?
We don't have to prove that, it's an axiom.
Okay, right. So we all know what straight is at this point, right?
Yeah.
Okay. Now, is there any curvature to that straight line?
No.
Okay. In any direction?
Not even in infinity.
Correct.
Okay.
Yeah, a straight
Okay,
Euclidean
great,
line
great,
is non-curving ever.
Okay, right. Now,
Ever,
when
great,
you say
okay.
Euclidean, what do you mean by a straight Euclidean line? You've just tagged that in, right?
Yeah, a
We were
line
just talking
constructed
about straight.
according to the axioms of Euclidean geometry,
Okay,
which
now
are the ones you use, like extending a line out and etc.
Okay, we've just agreed that you can prove a straight line.
Yeah, I
now,
wouldn't call that proving a straight line. I call that constructing a straight line.
Okay, right. Okay. In Euclidean space.
Yes.
Right. That, i.e., Euclidean space being the reality we live in.
Sure.
Okay. So anywhere I construct that straight line in reality, it will be a Euclidean straight line. So there's no need for us to go on here anymore about Euclidean. There's just straight. There's no other definition of straight because we live in Euclidean 3 space, and a straight line in Euclidean 3 space is straight with no curvature, right?
Sure. I mean, yeah, if we want to ignore other geometries for this conversation, then yeah. But I mean, just hand waving away that this is the only definition of straight is false.
Exactly
You just
where the problem
tagging
comes in.
another one in. Go on. Before we can carry on, right? If you want to inject another straight, right, onto the reality that we live in, and you would like to explain it, please do. Go ahead. Now's your chance. I'm just going to.
The only other one I might foresee us using is a geodesic on a sphere, but only in the sense that I would want to say that some potentially curved path is the shortest constrained path on the surface of that sphere between 2 points. I will refrain as best as I can from calling that straight.
Okay, well, let's imagine a domed shape mountain, and we want to make a straight path, and we want to take a train or whatever through it. So we're going to go through the mountain, right?
Yeah.
Okay. In Euclidean space, right?
Mm-hmm.
Okay. So in reality, even if we have lumps and bumps, straight is still straight.
Yeah.
Okay. That's good. We're getting somewhere, right? Because we're establishing the framework that we're working from. So once we've got straight sorted, then can we say that like if you have an X and Y axis, like in reality, Cartesian coordinates, like everybody should know about that. X and Y are on the plane, and Z is the vertical, right?
Sure.
So
So like
if-
X and Y are directions on the ground. So like if I were standing, I'd say maybe forward and right.
Yeah, forwards, backwards, and like
Right.
straight
And then
through left and
Z is
right
from
if
my
you're
feet to my head. Okay.
Yeah. So if you're a computer game player,
Yep.
X would be, say, left to right, strafing,
Mhm.
and Y would be forwards and backwards.
Yep. And Z would be, I don't know, jumping or something like that.
Yeah. Right. So if you're going to make a tunnel through the mountain, you would stay on the X and Y and go straight through. With Z being like, say, zero altitude change or elevation change, and stay on the XY plane, going in a
Yep.
straight
And then
line.
you'd plow through the mountain. Got it.
That's good. So where would you imagine that your you said you might want to change straight?
So like I guess
where would that
let's say that this mountain is, I don't know, either made of granite or, you know, otherwise for some reason we don't want to dig through it. Instead, we want to, you know, build the train tracks atop the mountain. And we wanted to,
surface
you know,
of it.
Yeah, the surface of it, right, exactly. So if this is like, you know, a proper dome or half sphere shaped mountain, then we might want to ask, okay, how much track will I need? What's the length of I mean, we could just use, you know, the radius of the mountain times pi, and we get that.
I don't want to sound finicky and all of that, but
Yeah,
I
go
mean, I
ahead.
do like to stick to reality. A train cannot go at a grade of I don't know, like something ridiculous. They don't like going up hills.
Yeah.
Trains, so perhaps we might want to turn it into a road, right? And
Okay,
put
yeah,
car
a
on.
road with and all the cars have like suction cups on their tires, so they can grip no matter what the grade of the road is. And we get on the hill at one point and we get off at another point, and we want to find out, you know, what's the shortest path that stays on the hill between these 2 points. Now the answer is easy. If the points are exactly opposite, you have to just go like in a semicircular arc all the way to the top and then all the way around. And this, you would just take the radius of the mountain times pi. That's how much road you need. But if the 2 points aren't exactly opposite, like say you're, you know, getting on the hill coming from the north direction and you get off going like southwest, now it's not immediately obvious which of the many curved paths you could take. This would be a situation where I'd say maybe we can express the shape of this mountain in spherical geometry, calculate the geodesic path, which is the shortest path, and then take that information and then construct that and a road that follows that path.
That would be Euclidean.
Do you know what they actually do?
What?
Do you know what they actually do?
What?
When they want to come up with an answer to that kind of problem, they are representing whatever it's in reality with orthographical views. What is that? For the audience, just for the audience, I'm not asking you, you know, like if you didn't know, I'm sure that you know, but can you tell us?
I suppose you mean like side view, front view, top down,
Exactly.
like a blueprint style?
And those are what?
Two-dimensional.
Those are,
planar.
in other words, two-dimensional and Euclidean geometrical shapes and forms. Yeah.
Okay.
That's how they do it. Not with spherical geometry whatsoever.
I mean, I can see that making sense for like building the thing once you know what path you're going to take. Like with blueprints, you have the thing drawn out and then you use that as a reference when you're actually constructing the thing. I'm talking about how you get from the question of here's where I'm getting on, here's where I'm getting off, to how do you even figure out which path to take? How do you figure out where to construct the road? That's sort of the question that...
That way.
Yeah, not
Orthographical
mountains.
views.
Not roads over mountains. That's not spherical geometry.
Well, yeah, it's not that
Like,
something
you
is or
might be
isn't geometry.
confused.
It's whether the geometry is useful for that task. And I would say this is contrived anyway, right? Because it's this weird shaped hill and we're building a road on it. But this is just an example of if you wanted to find the shortest path
They
that
do
stays
do
on the
that,
surface of a sphere shaped object, then you can use. You're not required to, but you could use spherical geometry to find the geodesic.
That's not what they use, mate. That's
I didn't
what I'm
ask.
telling you.
I
They're
wasn't.
using
I wasn't
orthographical
asked what they
views.
used. I was asked because I had mentioned earlier that there's only one case I might consider using something other than straight, and that the example was brought up for that. This wasn't a question of because I mean I'm not a cartographer. I'm not a person who builds any sort of actual structures. So this wasn't really, I would hope, not just a test of what I know they use. This was a question for me.
It wasn't a
and what I would
practical
do.
question in that way. Yeah, you're right about that.
Yeah.
Yeah. Well, it was still, we were on about the straight line, and you were on about how you might make it into spherical geometry, but then you just explained to us that you'd calculate a geodesic. Would the geodesic is just the shortest distance between 2 points, like you told us.
Right.
And seeing as we are in Euclidean space and it's a mountain, then the shortest distance between those 2 points would be a straight line.
Yeah, I agree. So the shortest path, sort of like overall, in the entire problem space, is an actual straight line. What spherical geometry can be useful for is if you ask that question with the constraint that you're not allowed to, burrow into the surface. That's why, if the mountain were made of granite, or if it had some weird impenetrable rock in it,
Ooh, or
for some reason
unobtainium.
you're allowed to use the obvious, dig a tunnel through it method, then you can fall back to, okay, if we are restricted to the surface, there's this other set of equations here that computes the shortest path that stays on the surface.
But it I see, this is where I come in. I've done surveying, and that's what we do, right? We measure the elevations and plot the points, and that's they do that, and they don't use spherical geometry. They use Euclidean geometry.
By the way,
That's
let
fine.
me ask
Yeah,
you something.
you're
just
not
very
obligated
quickly.
to use spherical
If
geometry here, and Euclidean probably works really well. I don't disagree.
Brilliantly.
We established 10 minutes ago that we are living in Euclidean 3D space, then why would you use any kind of other geometry to actually construct something back to reality?
Yeah.
How could you do that?
Yeah, the reasoning is if you have extra constraints. Like if your path must be constrained to the surface of a sphere, then spherical geometry is now sort of an extra tool that you have the option of using. If you can just use any path in reality at all, then clearly the straight line path is the shortest. But with extra
cannot
constraints,
give me the right result for reality. It cannot, because it's non-Euclidean, right? In the first place.
Well, the surface is non-Euclidean, but you can in the same way that we can have spheres in 3D, we can take the results from spherical geometry and sort of translate them back into Euclidean geometry. We can take what's the geodesic on just the 2D surface. Now we embed that 2D surface in a 3D Euclidean world, and then translate and see what the answer gives us in 3D.
Non-developable.
How do you
told
do that?
earlier.
How do you
It's
do
not
that?
developable in 2D, right? We can't take a sphere and unwrap it onto a flat map. But we can take a sphere and just, put it in 3D and just keep it as a sphere without trying to unwrap it. The non-developability part is
then where are you using your
2D to 3D.
spherical geometry?
You're using it when you have characterized your surface as a sphere, like a two-dimensional sphere. And then you solve the problem with spherical geometry there.
Did you just say a two-dimensional sphere? Did you just say a two-dimensional sphere?
Yeah, the surface. Sorry if I didn't make that clear.
Yeah.
Well, I don't know. It sounds just as ridiculous. But that was a slip where you said.
Well, I know it.
Sphere.
Formally, it is called the two-sphere, in math circles. It does sound kind of silly. So yeah,
It's a
I might have
jargon, right?
It's a concept.
Yeah, yeah. The jargon is to call it a two-dimensional sphere, but I see that is not something I should continue saying.
Well,
In
no,
this
you
case,
can
jargon means
continue saying it.
what you call something within each other as mathematicians, by the way. In this case, that's what it means. It's usually a jokester kind of phrasing of something, because you want to make it, shorter so that everybody gets what it is, but you know that it doesn't really exist, right?
Right. Yeah. I mean, we can try our best to express, a real life hill as a sphere, but of course, there'll be bumps and things in reality that make it not exactly applicable to the concept. I agree.
So let's jump over the two-sphere. What about again with the going into from Euclidean, going into suddenly to spherical geometry and then jumping back? How do you do that?
Mm-hmm. So you figure out what's called an embedding, and that is it's just a fancy word that means how is your sphere like located in 3D. Like if I say, it'd be equivalent to like giving the point at 0, 0 latitude longitude a three-dimensional coordinate, and then providing like it's essentially a way to translate from the spherical coordinates to Euclidean coordinates. And so what you do is you start with your problem as Euclidean, translate to spherical coordinates, do whatever, problem solving, geodesic finding, whatever it is that you're doing in the spherical coordinates. And then once you get your answer, you just convert back into Euclidean coordinates.
Cool. Can I just
I get
keep
that
it
kind
simple?
of idea, but yeah.
I want to keep it simple with the straight line in Euclidean space and the straight line circle in spherical geometry, and relate that to a horizontal in reality and level in reality, right? Because there's the definite thing, right? Level, I say, is horizontal. It's the same thing, right? Can you convince me that spherical geometry can separate the two? Because that's the only problem I think that you've got geometrically.
I don't think it's so much that the geometry separates the two. It's just that there is in 3D a difference between taking a geodesic in spherical coordinates and then doing this translation to 3D, so it ends up looking like a circle. That is not a straight line. So a straight line will be different from it.
In reality.
Yeah, in reality.
I'm saying level is horizontal, and I say I can prove that level is horizontal. So if I think I can do that practically in reality and relate it to Euclidean geometry, how would you say, nuh-uh?
I mean, it depends on the proof. If there's a hole in the proof, then it's easy. If the proof is clad, then I can't refute it, right? I mean, that's, as proofs go, I'd have to hear it before I know how to refute it.
Okay, so how would you sort of say that? Because I take it you definitely say that you want to say that level is different than horizontal, right?
Right.
Looks like the U.S. military is being disassembled right now before our very eyes, if anybody's paying attention.
What's happening?
Not really, by the way.
Yeah. U.S. military? Oh, is that derailing? I think that's more important.
Well,
Being disassembled right now because of the jabbers. There are people who don't want to, go ahead and be a guinea pig. They're going to go ahead and wait because of all of the issues that are happening. So that's a lot of our military, and they're all getting booted, which is clearly unsafe, right? Because that would be like a great time for us to be invaded. All of our, a lot of top generals and shit just not going with the program. So here, put a bunch of greenhorns in, and then what are we gonna do, right? So it looks like somebody needs to fucking wake the fuck up. Is what it looks like. You know what I mean? Like, we need to quit on this bullshit medical tyranny shit. Stand up together, no matter what the fuck other things are going on right now, and then we can get back to arguing
we
about.
don't need to carry on with that. I don't think.
Yeah, I think you're a shill, dude.
Yeah, that's enough of that.
No, I mean I'm serious. Like, why would he say you
That's
don't need
enough
to-
of personal talk. You blatantly just interrupted the conversation. So.
I mean, yeah. I mean, thanks for the news.
Graham,
Um,
well, I was just gonna say real quick. Unfortunately, Grim, just since we're on YouTube and Twitch and all that, even Discord has they updated their terms of service as well in terms of talking about, the current situation. So it's
All right, well, I'm not gonna
unfortunate that
spend
we
my
can't
time
talk about
bowing
it
down to
because it's
YouTube and
important.
shit. I'm out of here.
Yeah,
Gio, I'm
find
sorry,
another
dude. No
platform.
offense to you. No offense to you. I love you, bro. But I'm not going to bow down to YouTube and all this nonsense. Like, I don't know what the fuck is
If
going
you
on. I thought
want
you
to
guys
create
were
it,
truthers.
you're right. If you want to create
the
a
truthers
platform and get
fuck
it
with the
shut down,
truthers.
you can do whatever you'd like. Yeah. If you want to
Remember what I was
build
saying
a
about
platform and have it
how
shut
flat
down, you
Earth
can do
won't
that.
be truthers, right? Remember how I said that though? It won't be full of actual truthers. I was right. Remember, I told you that years ago. It was that you guys would be the ones.
Grim, you're
conforming to
being
the government.
unreasonable. It's one subject and one subject only. Chill out, bro. Come on.
Yeah,
It's
you're
not
right.
like
All right.
you.
if you're heading out though, yeah, have a good night or day.
See you later.
Yeah.
Hey, Emerald.
Kind of get his point a little bit.
No, let Bev and the other guy carry on where they were, and then maybe ask some questions.
That's what I'm doing. I'm asking Emerald a question about what they were talking about. But yeah, Emerald.
Straight lines and curves.
That's right.
Yep.
I just I wouldn't. You said it before when you're expressing about the sphere, and that it's like a weird way to describe it in 2D. I mean, that actually is the distinction for the actual definition of what a sphere is. A sphere is actually meant to only be defining the surface, and like the ball or whatever you want to call it, whatever the actual sphere is encompassing is the actual object. But a sphere is meant to be describing the surface of a ball. At least that's how it's defined. So
Right.
I wouldn't necessarily.
It's not how it's defined. It's defined in solid geometry, book 11, Euclid. So, yeah, it's the whole thing. It's the three-dimensional shape because it comes in solid geometry, where it turns into 3 dimensions, right?
Yeah, the object is three-dimensional, but the surface itself is the two-dimensional property of it.
No,
Yeah,
that's
I mean,
when you've stuck in you've not come in along into the solid geometry of reality.
But
If you're still in the 2D, you're still in the plane geometry of the earlier books.
Well, right. I mean, what Coach I think is referring to is that in different math circles, like not just solid geometry, like in things like topology and analysis and stuff, sphere is more generally considered just the surface. And it's bogged down by a bunch of formalism that I don't want to be really annoying
It's
about.
within solid geometry, right? So if it's solid, it is not just the surface.
Yeah, navigation is not solid geometry.
I don't think we're not talking about navigation. We're talking about a straight line and a curve within
But that's the
spherical
two
geometry versus Euclidean geometry.
Not
That's what we're
Euclidean,
talking
though. That's
about
your
here.
problem. Get it out of your head,
Oh,
Bev.
here
It's
we
not
go. Team
freaking
on.
Euclidean.
Let's go, team.
It's not Euclidean,
that-
you idiot. We've told you
hit a
this
moment.
1,000 times.
Emerald, I
Chill out.
you've been chucked out. The old
Rip.
timers are kicking you out.
Yeah,
No,
but
that hang on, left lane. That got an immediate mute. Hey, Nasa Shield, that won't be tolerated. Just calm down for a second.
yeah, that was my point. Was that navigation is defined by a 2 coordinate grid system on the surface. Yeah.
Yep. A grid. Square. Grid.
What are you guys defining?
We're talking about straight lines. We're relating the horizontal and level to Euclidean space. I do. I say I can relate both of them because they're the same thing together with Euclidean proofs to prove that it's a straight line. I was just asking how that would relate to spherical geometry because I believe I've heard a lot of people say that horizontal and level are different. Well, level seems to be the straight line that you want to call a circle within spherical geometry, whereas horizontal is what you want to call a tangent, but a tangent to a two-dimensional surface. I mean, it all seems really contradictory to me. That's where
No,
we were
you
at.
said it just you said it just right there. You did good.
And you're okay with the contradiction?
Not I don't see a contradiction.
Oh, yeah, exactly. That's what I mean. You're okay with it.
What contradiction is that, Bev?
Well, the contradiction is that when I say horizontal and level are the same because they're straight lines, it's a straight line. Whereas you also agree that it's a straight line. It's just that you think level is a straight line, straight line, a conceptual straight line that curves, but doesn't curve because it stays in two dimensions.
Because we're not talking of Euclidean. We're talking spherical geometry.
Right. Like I would only call level. I would call level a straight line only in like, you know, a spherical geometry sense. But if we want to stay closer to reality and just talk Euclidean, then it's a curved line because it forms a circle. Right.
In Euclidean space.
Yeah, in Euclidean space, you end up with a circle and then a line tangent to that circle. Right. Okay. In spherical geometry, the circle becomes straight, and the tangent doesn't even exist because it's out. It's off the surface of the sphere.
You could get yourself some like a geometric proof for that.
Oh, that exists. You won't understand it though because you're stuck in
for which part?
In Euclidean, yeah, because it's obviously seeing as you would.
I guess I mean the geometric proof that the circle becomes straight is. Well, I guess it depends on what circle, right?
No, just the geometric proof that level, like you claim, is actually not the same as the horizontal. Since it's actual geometry that dealing with, and obviously because we're dealing the geometry of reality, then we can actually do that too, right? There is a reality aspect to this geometry. It's not just conceptual. Once you enter solid geometry, right, that's where things actually get provable.
Right, but I mean, what I'd say, I mean, the full answer, I guess, or a full proof, is not really restricted or like doable fully in just geometry, right? Because it clearly depends on what shape you think the Earth is. Like, if you think that the Earth is, you know, amenable to this Cartesian system with no curvature and it's not a sphere, then I'd say the proof's dead simple. If you think the Earth is a sphere, then things get more complicated because you end up with the drop factoring in and your level will change directions. So I think it's easy to say that, you know, the Euclidean geometry is the reality. What do I want to say here? Like when you switch between Euclidean and reality, are you taking the Earth to be flat? In which case, I think the proof's easy. Or are you saying that the Earth's a sphere? Like, what's your hypothetical here for your proof?
Just Euclidean geometry, right? The reality. Like I've told you, I say level is horizontal, and I can prove that.
But in reality, you know, if the Earth is a sphere in reality, then things like, you know, your XYZ coordinate system don't work the same way, right? Because as you move across the surface, you know, of the Earth in reality, if it's a sphere, your Z will be changing too. So if you're going to make assumptions like the Z is the same, then you're sort of implicitly assuming that the Earth is not a sphere. Right? The translation from just the geometry to reality has this sort of baked in assumption of what the shape of the Earth is. Unless you want to go like no assumptions there at all, in which case then
you're saying if you assume that all of the points are fixed and you make a straight line, then you assume that's a horizontal. Whereas you just said about you fix the Z right? You want to have a wandering Z, right? But that would
Well, I guess
also
what, yeah,
mean that your X and Y are wandering. So every
right.
time you moved, you would be at 0, 0, 0. So you would have no reference frame. You on your
Or
model, you have
not
no
quite, but like
reference frame to relate anything to, because everything is always relative to your position.
that wasn't quite what I was getting at. What I was saying,
That
like,
is the implication that you were making.
well, no, I'm not saying you move the origin of your coordinate system. I'm just saying that if the Earth isn't flat, then moving across the surface of the Earth does not hold your Z constant.
The Earth isn't flat. Like, we measure it using the tools for surveying to measure elevation changes. Those elevation changes make it not flat, provably.
Right. But
Right. So
we
the question isn't if it's flat, because it provably is not flat. That's not
or
what we're
right, yeah.
saying
Let
here,
me
right?
clarify.
That's
So something
not
you
the issue.
said a while ago, right, is in sort of in the same sentence you said, if we hold the Z constant, or like equivalently if we stay the same elevation. I think Globers would disagree that a Cartesian Z-axis is the same as elevation, because I think Globers would say elevation is like distance from the center of the Earth, and that is not always facing the same direction. It's not always in the Z direction.
Your Z always changes due to the vertical, but because the axis of the Z always follows you, then at that point you are always at the XY0. But the Z is elevation dependent, right? It depends on where you are on that Y axis, right?
Or
So
it's
that's your
not
only
quite this.
static one is the
It's not that you're
elevation.
changing the axes, it's that your position relative to the fixed origin is different. Like a Glober would say that the sea level, the level of the ocean, is physically curved, and as a result doesn't have the same Z value. So saying that same Z is equivalent to same elevation is inherently like making an assumption about the
Is
shape.
Z not your vertical?
Well, I mean, it depends. I mean, when you say you're vertical, do you mean that we are moving the coordinate system to always be where you
on
are?
the
or-
model that you said, because you said earlier about fixing the Z, right?
Yeah.
And that was assuming something. So if we're not fixing the Z, does that mean you're carrying it around with you?
No.
And if you are carrying it around with you as an extension of the radius that you're walking around, right? That's what we're saying. You've got a model, yeah? And you're
I'd say you're
taking
not
that
carrying.
Z with you.
I'd say you're not carrying anything around with you. I say you're fixing a coordinate system.
Yep.
But because the shape of the oceans and the things that we define level off of to a Glober are curved.
Yep.
You don't level does not have the same Z everywhere. So assuming that level has the same Z everywhere.
Wait a minute. If we say a 0 change on the Z axis, right?
Right.
You don't change on that. Is that level to you?
I think a Glober would say that it isn't.
Oh, right.
Right.
I would be hesitant, but
I think
I
up to
would say I would say that if the Z is vertical, then a 0 change in the vertical would require a 0 elevation change. It's only that elevation change that is measured difference that makes an elevation change, right? It needs to be a measured change in the vertical to have an elevation change. So I would say, in reality, if we have a 0 elevation change, then there is a 0 change in the Z axis. It stays exactly the same.
Yeah. The disagreement that a Glober would say is, well, there's this additional vertical drop due to curvature. So actually, same elevation, but a mile apart, does not equal 0 change in Z. It equals 8 inches change in Z.
Oh dear.
Right? Did you see where?
Yeah. I'm not too sure you're up to date with the reality geometry.
No, he's exactly correct, but I think that
Ooh,
And I was just explaining it in a way that's trying to
Yeah, I'm probably not doing a
come
great
across to
job.
you. But I posted a picture of plotted points. You don't have to agree with the picture where the points are plotted. But Emerald is saying, because the z-axis obviously is the blue axis in the middle, and decreasing or increasing only the z-axis or keeping constant only the z-axis is not necessarily gonna conform to the shape that this thing is portraying, obviously, which is a sphere. So the elevation change is only going to occur when at any given point, that point and then the origin point, the line that is the line that intersects both those 2 points, if you change position along that line, then you're changing your elevation on our model.
Oh, right.
So
I see.
the
So
z-axis,
you don't have a vertical. Where's the vertical then? Is that the z-axis, the one straight through the
that's the
middle?
line that was the line I was just describing.
Yeah, the one straight through the middle.
Yeah, no, the one that goes from the middle to whichever point you're at. The line that's created, by connecting those 2 points and extends it out to infinity.
Well, you see,
Moving
you've got-
along that line alone would be changing elevation.
You've got red, blue, and green. Those
Those are the
axes
X, Y, and
are
Z
all
lines.
perpendicular to each other, yeah?
Yeah, that's it. X, Y, and
Okay.
Z.
Right, so
you recognize?
they are fixed, right?
That's an fixed
So
frame. Yeah,
the Z is upwards
that's right.
and
In
downwards.
this picture, in this frame, yeah. Yeah, but
Farming,
when
you
that's
flipped
what
on
we're
your
saying.
camera.
We're
I don't know
saying
if you intended to.
if you were on the surface of this object
That
and
looks
you were
like
referencing,
Cartesian coordinate system. That's
that's because it
I
is.
didn't
If you were
imagine that you would
referencing,
have that.
yeah, if you're referencing your movement along an object that all these things are on, you wouldn't do it based on the XYZ coordinates because that would just be confusing. Instead, you use exactly what I said. You make a line from where the origin point is to where your point is, and if you move along that line, you're changing elevation. If you're moving along the surface, the X, Y, and Z are all going to change no matter where you move.
I
Whether
guess
it's
like
up, down, anywhere.
Wow.
Maybe if this makes sense, like if on a flat Earth, right, where there's no sort of overall curvature, the only thing that affects
there's no flat.
Oh, right. Well, what I mean by flat is like just terrain, no like overall curvature. Like it's not bending, right?
Right.
On
So
an
yeah,
Earth,
there's
like
no curve level, like in
Yeah,
reality. Yeah.
exactly, yeah.
Level
On
where
an
level
Earth,
is horizontal.
on an Earth like that,
Okay.
then the only thing that affects your Z is your elevation, right? But on a sphere Earth, there's also vertical drop, and so that's why Globers would not say that.
Sorry. What do you mean? Vertical drop?
Yeah, like for every amount you move out, you are relative to a fixed coordinate system dropping. If you establish Z right where you're at, and then move out, you will eventually drop relative
Well,
to
that's
that.
what I was on about. Do you not take your Z with you?
I think Kosho's saying you can, and that simplifies a lot of the math.
Well, okay, right. So any
No.
vertical change in elevation, even on your idea of what you're thinking you live on, right? It's still a vertical change. It causes a change in elevation.
I'm not clear on what you asked about. Just to be clear, before I wasn't saying anything about taking the coordinate system, moving it when you move. I'm talking about a fixed coordinate system. At least in this example, there's a fixed coordinate system so that when you move, you can reference your movement along that, that coordinate system. So it
The
makes sense.
XY plane gets
Nothing
fixed.
moves with you.
The XY plane gets fixed, and you move up and down along
No.
the
The XYZ is fixed for everybody in the world, and when everyone's moving along it according to everybody. If you're talking about a different coordinate system where it's unique to you, and then you can describe your unique movement,
I'm just talking
you can do
about
that.
what you're talking about, because you keep saying
Yeah. What I'm talking about is
different
a fixed system for the whole Earth.
as you're talking.
I'm talking about a fixed system for the whole Earth, and it's all I was
now
ever
you're
talking
about moving reference frames.
No, I'm
steady
correcting you, saying
reference
that
frames. You can fix it here
I'm
if you want
specifically
to.
saying
You
that
can
it's
fix
not
it
moving
over
with
here.
you.
You don't have to fix it. It changes. It moves.
That was my point, Bev. That was the reason I jumped in, was to correct, because somebody said, yes, that's what I was saying. I'm not
he
saying
was
that it moves
messing
with
up
you.
massively.
It does not,
Yes.
It does not, Bev, it does not move with you.
Did you hear
There's
that?
not two different systems I'm talking about. I'm
Emerald?
talking about one system where it's
Yeah.
fixed for the
He
whole
jumped
Earth.
in because you
Not
made a
changing with.
mistake. He needed to jump
No,
in.
I
to
was.
help
Somebody
you.
was. You asked if I said the Z moves with you. I'm saying no.
I wasn't
Nothing
talking to
moves
you,
with you.
Coach.
Yeah, you asked about something I said, and the answer was wrong. So I'm just making sure you understand. I'm not talking about it moving with you.
Yep.
It's fixed for everyone on the Earth.
Mm-hmm. He made a mistake, and I asked how well he did.
Right. I might have been
you had to
confusing when I
jump in.
say that when I say that your Z changes. I guess I should be more precise. Your like Z coordinate changes. You're not like changing where your Z axis is. So like if you were to take, suppose the Earth's a ball, fix the coordinate system at the center of the ball where Z is, I don't know, up toward the North Pole, and then you have X and Y as out toward the equator, then just moving what a baller would call level would change all three coordinates, not just X and Y and keeping Z the same. Because
right, well, let's talk about vertical then, right? In order for our positioning, because I'm saying, in reality, what we do is we establish a horizontal, and then any change in the vertical, measured change in the vertical, is what we call an elevation change. As in, mountains go upwards, and it's measured like that, as an increase in the vertical. So it due to such, right, we have rivers flowing down to the sea, right? Because that's normally the reference point. The mean sea level is, every country will have its own, but that will be what you call zero, the sea level.
Yeah.
Okay, so the vertical change, is that what you would call on, like, I don't know, you keep saying the Globers model. You seem to be representing it. Is that what the Globers model would have? Is a vertical change being a change in elevation?
I'd say yeah.
Okay.
The only sort of difference
we're the same.
being,
There's no
the only sort of difference being that rather than your 0 point being like this line of equal, or like a flat surface, right? It would be.
You did say it was a point.
I mean, I don't think I said it was a point. I mean,
0 point. You said.
Oh, well, there is a 0 point. Sorry,
Yeah.
the zero level.
We call it the datum.
What we, sure, yeah.
Yeah.
Where we're defining level to be is on a, if the Earth's a ball, then it's a sphere, and so you take your measurements.
Really?
So I mean, locally it looks the same. So like if you're just standing by the water, then you can.
I have a
chuck a
picture
ruler
in live
into it.
chat
And
if
then,
you need some help.
What's that?
I posted a picture in live chat to help.
Rob,
which one?
Live 2. Livestream 2, Rob.
Okay, sorry, I might have the wrong one.
Yeah.
Right. So
locally, I would say.
Yeah, well, that's where the difference came in. That's where we started this, right? Because we both have the same vertical, right? An elevation being a measured vertical change.
Yeah.
Right? The difference then becomes when I say level is horizontal, which would be perpendicular to that vertical, right? At every point. You also have the same, do you? Obviously, because it's a vertical, then perpendicular to vertical at every point would be horizontal.
Right. The complication then is that direction of your vertical changes as you move across the surface. And I think Rob
No, I'm not saying that. I'm just saying at every point, we're establishing similarities, right?
Yeah, I would say that yes, locally they're extremely similar. So if I was like, just at one point on Earth, I could totally just measure, vertical difference, and that tells me, elevation. So if I chuck a stick in the water, zero it so that I put a mark on the stick so that the water's at 0, then absolutely anything at that point I can mark its elevation as the number of feet above or below sea level. The difference is like if you're doing something like sighting to a place that's distant, or if you're trying to talk about the same elevation at different points.
And at every point of that vertical, we have a horizontal that is perpendicular.
Yeah.
Right now, do you have level that is also perpendicular to that vertical at every point, everywhere?
I suppose, yeah. You could construct a sphere per se that sort of is the, I guess, equivalent of the plane you would get from a horizontal. I'm not explaining this very well. But
I mean, again, it's another similarity that we do have.
Yeah, you can construct a horizontal at any given point. Yeah.
On the vertical, right? So a 0 change in the vertical would be a 0 elevation change, right?
At that
and then
point,
if we carried along that 0 elevation change and we kept dropping verticals and there was still a 0 elevation change, at every point along that bit, we would have perpendicular to the vertical a horizontal, right? And there would be a 0 elevation change. It would be perpendicular to horizontal and perpendicular to level all the way along it. Now, how far could we go along that line having a 0 elevation change, as in a 0 on the vertical, and perpendicular horizontals continuing? Because if we could show a shared straight line segment, obviously we could keep that straight line going along.
Right. I would say they would all work fine. The complication would be guaranteeing that you have sort of extended and have shared line segments. Because if you're, say, moving on a globe, your vertical at one point is not the same direction as your vertical at another point. So you couldn't just assume outright that the two horizontals you take at those different points are a shared line segment. That would be an assumption you could not make on the globe.
Well, the horizontal's a straight line, right?
It's, they're straight.
We don't have to make that assumption, do we?
Yeah, we're not assuming that they're straight. What we're assuming is that they are shared.
Horizontal is a straight line.
In reality, horizontal's a straight line.
Yeah, the horizontals are always straight. The question then is, like, let's see. Do you see the image that Rob put in the chat?
Yep.
Like on the globe hypothesis.
He's aware of all of these.
Effie Dogma. That's his thing. We don't want him to strike us or anything. So shout out Effie Dogma.
On the globe hypothesis part on the bottom, right? That sort of blue dotted line that touches all the water levels. If you were to take the guy in the middle and put him, say, on the far left, if he were to take his measurement, his black dotted line would line up, would be at this different angle. It would line up with the water because it would be his horizontal, his level. And that wouldn't be facing the same direction as the guy in the middle's horizontal and his level. Does that kind of make sense?
Well, you know, have you ever done any surveying or anything?
No.
Oh. Any ever used a level or anything at all?
I've gone around and used levels, just not for any sort of like professional project.
Okay. Now, so if that guy in the middle is horizontal and you go to the other side or either side, doesn't really matter, would you expect the horizontals to intersect?
I suppose, yeah, they would, because they wouldn't be parallel to each other, right?
Okay.
They wouldn't be a shared line segment. They would be instead.
On the model?
Yeah. You wouldn't have.
In reality?
No, in reality, they're not parallel.
Okay, so do you suppose there would be a proof, like a way you could do that? I mean, it looks pretty simple, right? You just measure down from that line, right?
Yeah, or even easier, like we don't have to show where the horizontals intersect or anything. We just have to know whether or not they are a shared line segment, right? Like in the top half.
Is horizontal a straight line, or is level horizontal? Like, you know.
Well, I mean, horizontal is a straight line, but it's like, is it the same straight line for everyone, right?
Well, yeah. Can I give you a little quick bit? That
sure.
All horizontals are parallel to the plane of the horizon. Right? Therefore, all horizontals are parallel to each other.
They're not.
Right. That would be that right there would be a good testable claim, and sort of an
It's
equivalent
a nice,
claim.
nice, neat little bit of logic.
Yeah. So
Right,
what
and if
this
that's
boils down to,
demonstrable,
Sorry,
if
go ahead,
that's
Rob.
demonstrable, like if we can demonstrate that, then for somebody to say it's wrong, they have to demonstrate it being wrong. RC Majesty.
That's the way. That's the
it's
way the
actually
logic
not.
goes. There's no need
It's
to
not
put down in
complete.
that right now because
we can,
it'll
and
obviously
it's
kick
very-
off if we threaten them too much. I was a bit sorry that I even
Not threatening
brought the logic
anybody.
into it.
Yeah,
I
you're.
didn't-
It's very easy to show
logical
that
argument.
because it's very easy to show that because the verticals are not parallel, and that we can
Oh.
also show.
How do you
You have
show
to
that the
prove that.
verticals are
Rob,
not
Rob,
parallel?
please.
Okay,
The
sorry,
logical
I'm
argument.
back up.
The logical argument put forth wasn't complete. There was a missing part there.
Oh,
That's why it's not. It's
Kosho, please.
What was the missing part?
yeah. You said that. You said
Here.
horizontals is parallel to the horizontal plane or the horizon plane, the plane of the horizon. All horizontals are parallel to the plane of the horizon. People agreed with that. That's fine. And then you said that the part you left out was that
are parallel to each other.
Yeah, the part that you left out, though, in order to come to that conclusion, was that there was a single plane to the horizon and that those were parallel. If that wasn't even addressed in your argument, so I mean, there's no way
Show
to
me
say
a
those
horizontal
parallel to
that
each other.
is not parallel to the plane of the horizon, and you'll
Yeah,
be fine.
but
That's all you've got to
yeah,
do.
but
Don't worry about
you're
it.
saying that as if there's a single plane to the horizon.
No, I said
You
all
got more than one?
horizontals are parallel to the plane of the horizon, which they
and
are.
then you conclude that they're all parallel to
you
each other,
said they
which
are. Yeah. Then yes.
yeah, which imply no, but what you just said implies that there's a single plane of the horizon, or that all the planes of the horizon are parallel to each other. And without that being addressed, you can't say that they're all those horizontals are parallel. Just because they're all parallel to their plane of the horizon.
I didn't want to get bogged down into simple logic and then actually proving it, where I don't know how you would disprove it. I mean, I think that would
we
be
got
the
to the
better
interesting
way for you
part.
to do it. I can't.
We got to the interesting part, which is the I guess question or hypothesis, however you want to phrase it, of these horizontal lines all being parallel, which I will posit is like an equivalent statement to the verticals being parallel, because it's if and only if the horizontals are parallel to each other, if and only if the verticals are. And I think what RC was talking about is evidence that the verticals are not parallel, which would imply that the horizontals aren't.
Wow.
Well,
So you would assume that there is evidence then, right? Of what was it you said?
Of the
verticals being
verticals
not parallel.
Right, yeah, verticals being not parallel. Off the top of my head, I remember one video. I think it's the one we talked about last week or so, but it is ostensibly disputed because someone said that the main surveyor was doing something wrong or something to that effect.
Doesn't know how to set his tools up. Yeah.
That's what it was. That was the contention.
Yeah.
Are we trying to just say horizontal's not horizontal? Because I feel like that's what he's trying to say.
He's going
that's not what I'm trying to say.
Eventually, he's going to end up there, right? Because it's the next
point
we go to. Wait a minute.
Pretty much,
this is where we go to, because you've just said that horizontals intersect with each other, right? Now, the question then becomes, how long is a horizontal straight line? Like, in your model, right? Like, don't think about reality, because you can't. How long in your model lengthwise is a horizontal line or plane? Can you just give us a rough estimation?
Yeah, I mean, it's not finite. I mean, you extend the line out forever, essentially. Like in geometry, right? A line is different from a line segment.
I said in your model, not reality.
In our model, it's the same.
A horizontal line.
Yep.
Right. So all perpendiculars to a plane will be parallel. So you have a horizontal plane, all perpendiculars to that will be parallel. And what's perpendicular to a horizontal? Vertical. Are you okay with that?
Yeah. Now, what's this? So you said that all perpendiculars to a plane. Which plane are you referring to here?
Parallel.
A horizontal plane or something else?
Horizontal plane, yeah, the one that I said. I asked you how big it could be.
Yep. So I could construct a whole bunch of perpendicular lines that intersect this plane. Sure.
To the horizontal plane.
To my horizontal plane. Yep.
Yep. And those, because perpendicular to horizontal is vertical.
Yep.
They would all be parallel. All the verticals would be parallel.
Sure. All these constructions. These are just constructions, though. What we actually end up doing is different people take their own independent measurements of what direction vertical is. And what I'm saying is that in reality, each person has a differently directed horizontal plane, and as a result, a differently directed vertical.
And that's why I said to you, how long? Because we're obviously horizontal and vertical are things in reality. They don't exist in geometry. Vertical and horizontal only exist in reality. Now, the tools we have for establishing a horizontal and a vertical are a plumb bob for a vertical, right?
Mm-hmm.
That's the tool. So when we say vertical, we're talking about a plumb bob, right?
Yep.
Okay. Not like a figment of your imagination, what you imagine it to be, but actual tools in reality.
Right.
And level is a tool for establishing a horizontal plane.
Mm-hmm.
Okay. So we do have the tools
Yep.
to establish these things. Now, the question to you was, that horizontal plane, how big can it be on your model?
And I answered no limit.
There's no limit to it. So the horizontal plane that is established by a tool called a level will always have perpendicular to wherever that plane is, a vertical.
Yeah, at the place you measure it. So you take your plumb bob, that's your vertical, and that's perpendicular precisely to your horizontal. I agree.
Okay. Yeah, and then when you go out with your measuring rods, like off into the distance, you have to hold that vertical in order to get a direct measurement for a change in the vertical, right? So that's also vertical, and it's perpendicular to the horizontal plane.
This is the part where I disagree. Because
right, well, okay.
if you're
that's
establishing,
why I was asking you how big the horizontal plane could be.
This has not to do with how big the horizontal plane is. This is the question is, if you're at this different location and you're establishing your vertical there, that vertical might not be the same as when you started.
But it's required to be, because that's how
No,
the
that's a
process
claim.
works.
Nope,
So
that's a claim.
horizontal is not horizontal, and
No,
down
no,
is down.
Bev, you're making a claim that you have no measurement for. You're beyond your geometric proofs at this point, because a proof provides it. No, hold up.
It, please.
Your proof provides.
Just
Bev,
established
I'm in the middle of a sentence.
plane.
Bev, I'm in the middle of a sentence.
Yeah, but you're interrupting
Hang
what
on.
we're saying.
Yeah, you're in the middle of their argument saying something different than what they're
And
arguing
I'm
against.
no, hold up.
Yeah, you've
I'm
just
not saying
butted
something
in,
different.
Sean. You've got triggered.
Stop.
Come on, admit it.
So listen,
You were
Bev.
sat there listening, and you got
oh my
triggered
gosh.
and went,
Ricky, are you just
I'm
gonna
gonna
allow
have to
this to
jump
go
in.
on?
Well, I did make a statement that you interrupted their conversation to say
I did
something
not
that they're not
interrupt
arguing
anything.
about.
I'm in the middle of a sentence. So
Right,
Bev,
but they were
you're
middle
using
of an
circular
interruption.
You're using circular
still
reasoning
doing.
right now. That is beyond the
RC
scope of your proof.
Yeah, when I interrupted and got scolded, I backed out.
RC, just shut up.
Well, not be quiet. Just maybe give them a second to finish what they were discussing, and then come with
I
your
can say
your
a
claim.
sentence in the middle of this. Bev,
Yeah, you can, but I think it would be better to let them finish what they were talking about, and then you can come in and
I didn't
and
change
talk
the subject.
about what
You're
you're saying.
all I
Something
said
totally
was-
different than what they're discussing.
No, it isn't. I said, Bev, you
No,
have not
stop.
established your proof
We
yet
haven't
because you don't have a
established that
basic
it's not
measurement there. You're
Stop.
just reasserting
You
what
already ran
horizontal
out.
is.
Come
You already
on,
ran
if we
out
all
in
if we
your
all butted in,
discussion.
it would never
Shut
happen.
up.
Well, he's obviously not going to stop, so just say your piece, and then y'all can choose to acknowledge it or not. Is that how you're going to handle it, RC? Because I asked you not
Yeah, I
to
am.
do it.
Come on, do your monologue.
Go ahead.
Yep, 15 seconds. Bev, you have not established your proof yet because you haven't provided the measurement for that. You've just reasserted that it's horizontal.
Nothing.
Thank you.
Good day.
All right, carry on.
Okay,
Bev.
so the auto level establishes the horizontal plane. Then everywhere you measure to that horizontal plane, you would have a perpendicular, right? That perpendicular to the horizontal plane will be a vertical. Right? There's no getting around it. That's the geometric facts. If I hold a plumb bob anywhere in that horizontal plane, the vertical will be perpendicular to the horizontal.
That's where I
Or
disagree.
is it your claim
No.
that it
No,
will
it won't.
not be perpendicular?
Right. It is what I am claiming, I suppose, is in this model, the globe model, I guess, you do not always establish the same vertical at different locations. So I can establish, say, at, let's say, 0, 0, xy, a horizontal plane that goes out however far I want it to go. And I establish my vertical at that point. I mean, unless you want to implicitly assume it, there's no guarantee that if I do the same procedure somewhere else, that my lines are related at all to the first lines, unless you want to assume that.
Well,
I think
like
we're
I say,
starting with up and
wait a
down
minute.
is on the z-axis, dude.
Yeah, well,
Where
wait a
would the
minute.
change come from?
If you set a tool up, auto level establishes a horizontal plane, you don't need to deal with plumb, right? You just set that up. That then establishes a horizontal plane.
Right. Yeah.
You're not going to
plumb bob part's
disagree with
optional.
that, are you?
Yeah, I'm not going to disagree with that. You can
Everywhere where you
establish
set
a
that tool
horizontal.
up, it will establish a horizontal plane, right?
Yes.
Now,
The question is, how are you relating these horizontals to each other? Because if you're just going
okay,
out in
well,
the
if you
field
let-
and not
let
assuming
me-
anything and just taking measurements, you don't immediately have any information about how or even if these horizontals are shared.
Right. Okay. So when you go out and do this procedure, right? Have you ever heard of a geometric principle called a shared straight line segment?
Yeah.
Right. Okay. Now, if you do that, because you're establishing a horizontal plane, and then you can take measurements, and then when you transition and you move your thing, you can go back and check the shared straight line segment that you've just established on the
That's-
other horizontal plane.
Yeah, right there is where I
That-
have the contention. How do
well,
you
that
know that you
is-
are establishing a shared line segment? How do you know that that is shared?
Because
Unless you're
you
assuming
know
it.
about the geometric procedure about a shared straight line segment. You
Yes,
would know.
you understand the
you would
geometry. The
know that
question is
there is a
translating this
proof.
into reality.
Yes,
How do you know that
there is
your
a
real
proof.
measurements are constructing a shared line segment? You just seem to be
Because
invoking it.
the geometric procedure of you measuring a shared straight line segment and then establishing that that is indeed a shared straight line segment or plane parallel, right? One or the other, i.e., no intersection of horizontals. Because if you do find an intersection of horizontals, normally the procedure would be to check the equipment because there's an error. Horizontals in reality do not intersect ever.
Right. That's
Because
a
then
claim.
one of them wouldn't be horizontal, right?
Exactly. Yeah, there would be a
So
measured
yeah.
deviance from it, and that's not horizontal. If there's a measured angle from horizontal, then it's not horizontal.
This is A logic, dude. Horizontal is horizontal. So if you have something that isn't horizontal, guess what? It's not horizontal. Like it doesn't get any simpler than that.
No,
Yeah,
but the problem is
the
that-
issue with this is that not all yes, if you take Earth to be, a plane or with topography, then you can say that that is a fact. There is one direction that is horizontal, and horizontal is horizontal is horizontal. On a globe
We never
model,
mentioned
you
Earth
cannot.
shape.
Yeah.
I
know.
never mentioned Earth shape. I just
know,
said horizontal.
But what I
It's
know, what I'm
horizontal.
getting.
Why was
I
the
know.
shape of the Earth?
Let me finish and you'll find out. Let me finish and you'll find out.
Go on.
Because that fact doesn't hold under all Earth shapes. In the globe model, for example, not all horizontals are the same direction. There is a local direction of horizontal at a given point.
Wait, though, if Earth was the shape of a velociraptor, up would still be in the coordinate system up, and down would be in the Earth is in the coordinate system. The Earth isn't the coordinate system. I think this is where you're messing up.
Yeah, the globe. I think the globe model would disagree. We would say that elevation, as a sort of coordinate per se, is indeed based off of the Earth. because it is how high or low something is relative to the water, which is on the Earth. So that what you just said, that the coordinate system is independent of the Earth, does not hold on the globe model. That's not an assumption you can make.
It actually doesn't hold in reality either, because you can assert that vertical is indeed parallel, or that horizontal never intersects, but you haven't measured it to be so. And that's the beef of all of this, right? You can do it on paper, Bev, if you'd like, right? But the question is
right
that how
angle. What do
reality
you mean
is?
it's never measured? It
No,
is
Bev,
always measured.
Bev,
Right
I'm saying
angles.
you need a measurement for your proof that these verticals are indeed parallel, and then you can start asserting what horizontals are.
They are always perpendicular, i.e. at right angles. Vertical, horizontal are at right angles. They are called perpendiculars, right? Now, perpendicular within geometry is the meeting of two straight lines at right angles to each other, which means a horizontal is a straight line. Then on that straight line, horizontal plane, you can construct a perpendicular to it, because vertical and horizontal are always perpendicular. That's a geometric rule. Fact.
No, that's circular reasoning when it comes to actual measurements.
Well, I mean, yeah, I'll give you that you can geometrically construct more than one perpendicular to that horizontal plane. The question is whether when you actually get a plumb bob out and do it, if that's exactly the same as your geometric construction. To say that they're the same is an assertion. It is a claim. It is not proven from the geometry.
You've never established that those are indeed what you're saying they are. And you've never established that. You've just said that it's true, and then you're just assuming it based, like, going forward. So you're wrong.
Yeah, brilliant. Nicely done. So what are you saying we have to prove?
I think what
You have
this
to show that your
down
measurement.
is down.
Yeah, go on.
No, you have to show that either your plumb lines are parallel, or that your horizontals are indeed the same segment.
So how about if we go with proving that vertical and horizontal are perpendicular, i.e. at right angles to themselves everywhere. And obviously vertical, you're not going to bother about that. It's definitely a straight line, right?
Yeah, the question is not the relationship between the horizontal and the vertical. It's
Horizontal a
between
straight line?
that these aren't the things we disagree with. The question is not about the perpendicularity of the horizontal and the vertical. The question is whether two different people's horizontals are the same or not, or equivalently, if two different people's verticals are the same
horizontal
or not.
line from one person to another, and then, well, that'd be it,
I
right?
get it. You can construct it geometrically. The question is, in reality, when two people take a plumb measurement, are those parallel or not? You can argue the geometry all you want, but the question is about what's going on in reality.
If we go along in a horizontal, in a straight line, then at each end of that straight line, if we construct a vertical,
yes,
then
you
we
can
would
construct
just
a vertical.
check. We could just check that they are at right angles to the horizontal that we've just gone. Like at each end of the horizontal that we've constructed, if we check that the verticals are perpendicular to the horizontal at each end, then would that be all right?
Yeah.
No, it wouldn't, because
you wouldn't.
No, it wouldn't, because you would then have to
Wouldn't be
show
good
that
enough
those
for you,
verticals
RC,
that
but
you
it would have been
measured
good enough
are
for you.
parallel.
Yeah, he was fine with it.
Guys,
yeah.
Why don't you guys just start with the
Wait.
axiom that every position has a unique
Doesn't make no
horizontal
sense
plane
here.
and a unique vertical.
Why would we start
Y'all
with
are
that?
stepping in so
Because
much.
that's the axiom that Emerald is using for our model.
Okay, so you're talking for him.
What it sounds like.
If they behave
That's what it
differently,
sounds
but
like
they don't
right now.
behave differently.
It sounds
What
like
it sounds like
trash.
is that you're saying if we check, if you do indeed check and verify that all of the plumb lines are perpendicular to that one horizontal, then you're good. But
yeah, well, a geometric proof. There is, it's one of the proofs within Euclid, right? That
yes,
all
I understand that this is consistent in the geometry. The
perpendiculars
question
to a
is whether this is
plane,
consistent
all
in reality.
perpendiculars to a plane are parallel.
Yes,
Right,
I agree.
Now, is the bone of contention going to be that I'm going to say a plane is a two-dimensional sort of construct, and you're going to say, hey, wait a minute, my surface of a sphere is also 2D. So that 2D plane that you're thinking of that's a horizontal, couldn't I have that as my surface of a sphere, two-dimensional plane?
No, that's not going to
Level.
be the contention.
Okay.
The
right,
contention
so that
is
you're not
you
going to
said
do that.
no. What
Right?
you've
Because
said is
a
that
plane is definitely a two-dimensional plane surface.
yes.
Yes. Good.
But the issue, right, is you've correctly stated that, just geometrically, you can construct all these different verticals and that they will all be perpendicular to this one horizontal. The question is, if what you're doing in reality, which is taking a plumb measurement to get your vertical, if that is the same thing as your geometric construction, you have to show that those two are the same thing.
We
Or in other words, that
we can measure the horizontal,
wait,
and we
well,
can
okay,
measure
so
the vertical.
So what do you mean the horizontal? Are you
With the horizontal that we are going to construct to
Yeah.
show that it is a horizontal plane in order to construct our perpendiculars to. Right? You have to have a horizontal plane. That's the construct number one. You guys keep thinking vertical, right? But the number one thing to do is to construct the horizontal. Then from that horizontal, you can measure two verticals. It's dead
All right,
easy
Bev.
to drop a
How
plumb
do you,
bob.
how do you construct the
No,
horizontal?
stop, RC. Why are you in their conversation?
He's triggered.
RC, he's gone over how to construct the horizontal. My question is, and you said this earlier, Bev, and this is what I said yes to. You said if we check that all of our verticals are indeed perpendicular to the horizontal,
Yep.
then we're good. So how are you checking that? When you take, do you just drop a plumb bob? How are you checking that that is perpendicular to the horizontal plane that you established earlier?
Have you ever seen a square?
Yes.
Well, that's at right angles, right?
Yes.
Well, then you could use the vertical, the plumb bob, as one of them, and the horizontal is the other. So you just put your square.
I'm not asking in geometry. I'm asking in reality. You said check, right? We're trying to check that a measurement is perpendicular to something we've established. We're not talking about just in geometry.
Yeah, I'll go through that again, right?
Okay.
Do you know what a plumb bob is?
Yes.
That exists in reality.
Yep.
Right, now, we're going to hang that plumb bob. And now, you know what a square is? Like a tool, the
Okay.
square.
No, yeah. I was thinking just a geometric square. I understand now.
We're
Yeah.
talking about a
the
square,
tool square.
right? Now,
got it.
we're going to
Okay.
put one edge of that on the vertical
Mhm.
that we've just dropped.
Mhm.
We've already established the horizontal. We're going to use the other edge of the square as the horizontal, and we're going to check
Why?
the vertical with the horizontal with the square to show that it is at 90 degrees at right angles to it.
Yeah. The direction of your square, though, is your horizontal at this new location where you drop the plumb bob. You have not yet shown that this is the same horizontal as the one you established earlier.
Yeah, we do. We've established that was the first job, was to establish a horizontal.
Yeah, you got
like
a
straight
horizontal,
line.
and then now
Yes.
here your square gives you another one. How do you know they're the same?
Do you mean the square gives you another horizontal? What are you talking about?
You line.
He's putting the square on the original horizontal. The square goes on the original horizontal. Dude.
Okay.
You've never done anything practical, have you?
I have. It seems okay. I was confused then. Is the
He's
square
putting
set
the
up on the
square up
yeah.
against the vertical and the horizontal to see if the vertical and the horizontal make a 90. Then he's taking the square and moving it to the other vertical and horizontal where the other vertical meets that same horizontal and checking for a 90. If you have a 90 there and a 90 there, you know
all the way along as
that's
well as you're
horizontal
doing it.
because it's
All
90s.
the way, everywhere.
Yeah, you
it's
just keep every
always
inch you can
gonna
check.
be. Yeah. Do you
Like
get?
a grid.
Do you get that?
It would make a grid.
Yeah, I get that. So the thing that caught my attention was you said where it meets the original horizontal. How do you find out where that original horizontal you constructed meets your second point? Do you sight it? Do you use a laser? Do you have some physical object that spans the difference? How are you showing
Do you know
where
what
your
a
original
level
horizontal?
is? Do you know what a level is?
Yeah, I know they're short.
Right. Well, how big's the square?
also short compared to the difference between these 2 points. I'm saying how do you find where your original established horizontal meets the second location?
Right. Do you know a tool called a level?
Yep.
Right. Now, do you know what that tool does?
Yes.
What does it do?
It tells you the direction of level.
It establishes a horizontal plane of reference.
No, it doesn't.
Well, if you spin it,
Wow,
so you
if
do a
you
north
said
south then
that,
east
that was
west.
a nice one. It sounded like RC Meisty.
That's RC Mike.
Wow,
It was.
RC, you best keep him out of it.
No,
The
Bev,
tool.
because you're just wrong about each one of these. You're just using circular reasoning.
The tool called a level establishes a horizontal plane of reference.
Yes.
That
Now,
is
how
a
do you
fact.
find? Yes. How do you find where that horizontal plane of reference meets the second measurement location?
You establish that horizontal plane across a distance, and keep that horizontal plane all the way across.
How do you
Yeah,
establish
nobody's
it?
asking
Well, all you do
at
is
that second
establish it.
point.
Oh,
Yeah, you establish it. How are you? How
Everybody's triggered.
Yeah, yeah.
Wait,
But
you're
it's not
establishing
explaining it,
essentially
is
an
it?
orientation. You're establishing what orientation horizontal is at that point. How are you then extrapolating
that's
that
new.
out?
Yeah, yeah.
I
How
never
are you
heard
then
that. Horizontal can be oriented. Oh.
Yeah.
Well, sure. I mean, you can consider. I mean, the horizontal plane is perpendicular to exactly one direction, or well,
Isn't
two if you
horizontal the orientation though? Right?
is.
Isn't horizontal an orientation? How can
It
it
is
be changing?
one of the horizontals, right? It is one of the orientations. We've got
How can it be
horizontal
changing?
and
Because the
vertical.
verticals aren't parallel.
Oh,
Yeah, but I think
I mean, that's a bold claim.
Gary's question is the same question. Well, the plane that you
There you
created
go.
at the one position. How do you know where on that plane that you created from that one position? How do you know where the vertical from the second position intersects with that plane? Like
I don't
what are you
understand.
using to
Perpendicular.
Y'all
determine
can let
where
them have
the
a
intersection
conversation.
takes place?
I mean, it's a bit, yeah, it's a bit obvious that
Weird.
This is a
perpendicular.
two-person conversation. I didn't realize that.
Yeah,
There-
no,
okay,
I'm
the
just saying.
horizontal plane is not at one point. It would be you got at least 2 points for this horizontal line. So you're saying how do you know?
That's what I've been trying to tell Emerald.
Yeah, so there's 2 points.
Emerald,
There's
no,
the horizontal
that's
has
what I'm
2
trying to.
points, and then the verticals are 2 points
Yeah.
on there.
Yeah, but that's what I'm saying. That axiom is not true. It's not the axiom that Emerald is using. I don't think it's an axiom that should be used at all. The horizontal
So
plane
is Emerald dumb?
the horizontal plane that was created from that position
Mhm.
is the horizontal at that position. So you can call it a plane now, but it'd be wrong to call it a horizontal, somewhere else.
But it
So
can't be
are
a
you stepping
point.
up for Emerald?
Well, Kosher never said it was a point, did he?
We
No,
had
no,
the
I'm
plane.
not
I
talking
thought
to
we
you.
both agreed on the plane.
It can only be
I thought-
horizontal with reference to a coordinate system, and at each plumb you define a new coordinate system. You guys assume they are somehow aligned when this is not something you
Right.
can
There
assert.
are implicit assumptions in this whole
There you
geometric line of reasoning that are just
Go back,
being
go back,
swept under
Beth.
the rug.
We ain't done yet.
Right.
I'm eating this steak. I'm loving it. It'd be you, Emerald. Go ahead, Beth. See if you-
So I change coordinate systems every time I move. I don't move in the coordinate system.
When you use a plumb, you're then defining a vertical, right? And that vertical change for any point on the surface. And that is what you're using to define a coordinate system at that point.
I thought I would say that the coordinate system's already there.
At that point, the auto level can establish a horizontal, but it's only horizontal with respect to the point, right?
I feel
Because
like there's
if you
already
change to a different place, you define a new coordinate system.
Yeah.
No,
So if I don't move it,
Not
yes,
in
you
reality.
do.
Yeah, that-
yes,
that's
you
the
do.
big-
That's
that's the big
exactly what you
problem
do.
right there.
That's exactly what you do.
I would
You're
say
using
that
the
there's a
plumb bob to
coordinate
define
system.
your vertical.
Hang on. So we had the coordinate system up and down.
The
and
problem
left and
is
right.
that
Hold
Beth
on, bro.
asserts that all verticals are parallel.
Yeah. So hold on. So in the coordinate system.
No, what do you mean carry on? That's it.
Or so, hold on. In the coordinate system, there's verticals, right? And then you just when you put your plumb, all that's doing is giving you one of those. It's not like establishing it. It's just showing you where that vertical is. You're not making a new coordinate system.
You're just showing
No, you
vertical
do.
in the current
You
one.
set up your auto level. Using Plum, you establish a coordinate system at that point.
What?
And that's how you're able to
This
establish
is
a
where the
horizontal
divide
there.
is.
Do
Because
not.
yes, you do. Because
No,
it's
you
respect
do not
to the coordinate
establish a
system
new
defined at that point.
coordinate system every time
Yes,
you
you
drop a
do.
plumb bob. That's ridiculous.
Yes, you do. That is exactly how it works. This is why people have been talking to you about locality for ages.
Ev, didn't you yourself say that the purpose of a level is to identify a horizontal
To
or to
establish
construct
a
a
horizontal
horizontal
plane
plane?
of reference.
Exactly.
Yes.
That's what Gary's saying. He's saying that when you're using these tools and you're constructing this horizontal or establishing this horizontal plane of reference, this is to use that as your coordinate system. You're referencing things to that horizontal plane now.
Yeah, yeah.
So I mean,
So how do we
that's what
create
you're saying.
level foundations? Like, let's say you want to create a big, large building, and of course, obviously, you want it to be level, right? Because that's what we do. That's what we do is build level things, level and plumb. So, are you saying that I have no way to establish a horizontal that's going to be level across the whole place?
Yeah, through
Well, if
one
you're doing
coordinate
structure,
system, right?
then you need to work on the forces acting on that structure. So you use something like a plumb or a water level that conforms to the forces acting on it, so that you make sure you find verticals based on the forces acting on the
Wow,
thing.
that's where we came in. We saying now again that vertical, horizontal, and level are actually different now, right? When you use a water level, because I'd say that they are the same. A horizontal and level are the same thing, but you just said a water level for some reason. Any reason you separated the water level from the auto level?
I didn't. I wasn't separating them. I'm just telling you,
they're
always
both
are going to
tools.
use.
They're
Bev, I
both
was in the
tools
middle of
for
a sentence. Thank
establishing
you
a
very much.
horizontal
I said
plane
that
of
you are
reference,
always
then,
going
right?
to use the
You don't use a water level to establish a
Why is
horizontal
everyone
plane of
talking over
reference.
me?
Why?
Said you're
Because
always
you're letting
going
it
to
pass RC Meisty,
Oh
that's
my
why.
gosh.
Gary,
You don't
RC
use a water level
Meisty
to
is
do that
telling
at
you off.
all.
Gary, can you please stop interrupting RC Meisty?
Well, he's wrong.
I said,
Ooh,
if you would,
RC,
I
you're
said,
wrong,
if you
RC.
would like to
Gary
establish.
says.
Oh my gosh.
Gary
Said
says
you're
you're
always
wrong.
going to use the forces.
Yeah,
acting
you're
on
also
something
wrong,
like
Beth.
what? Oh my
Ooh,
gosh.
we're both wrong. So I don't know
Oh,
what
you're
a
wrong
water
about many
level's
things,
going to
Beth.
do now
Oh
if
my
we're
gosh.
both wrong, RC.
All right, just have fun, guys.
Gary's coming.
Bye.
So if you
Sorry,
build
Beb.
a building, and you make plumb on one side, right?
So we're not
You're
going to
set up a
we're
new
not going to address the
coordinate
point that was
system?
originally brought up.
Wow.
We're going to talk about construction.
Well, somebody was
well, I'm
just
just saying,
talking. Just shut up.
how do you have a coordinate system for
Go
one
ahead.
side
Why
of
are
the
you talking
building?
about construction when we were talking about something
He's
else?
super triggered, right?
Not really.
Yeah, because it's like, how would you coordinate between
I mean, why do you
somebody
guys
on
need to
one
gish
side
gallop?
and the
He's still
person on the
talking.
other?
Somebody
Yeah,
shut him down.
I am.
He's triggered. It's all right. He's
Yeah.
only triggered because he's seen the proof that level is horizontal. He gets super triggered. You can tell.
Yeah,
He
that
feels
moving
like
the
a
coordinate
little
system thing
baby.
is ridiculous.
It's funny, Bev, that you got on Gary for interrupting RC, and then you interrupted RC to the point that RC was done. But
Yeah,
regardless,
it's awful, isn't it? It's terrible
Already
seeing
missed that.
RC leave again.
Yep.
No, I'm
Wow.
just sitting here on mute until you shut the hell up and I can get a sentence out. What I said was you're always going to use something where you can see the forces acting on the thing, because structural engineering requires that you use the forces acting on something. So if you're going to use a plumb or whatever else to establish, hey, where the hell are the forces that I'm starting with at? Here they are.
Yeah, level and plumb.
Yeah, based on the forces acting
Yeah,
on something.
they're the exact tools that we use. One
Yes,
of them
and all of
establishes a
those,
vertical, the other one establishes a horizontal. They're both
and each one
perpendicular
of
to
them
each other.
uses the force of gravity as the baseline.
No, nobody.
Call it what you
Nobody
want.
needs You don't need gravity to make a horizontal.
Still doesn't stop it being vertical and horizontal, and them both
Then how
being
the hell does that
perpendicular
plumb
to
bob
each
go
other.
down?
It's vertical.
Oh
It
my gosh.
establishes
Yeah,
a
up and
vertical.
down, dude.
That's one of the frames of reference we have. You've just said
Up
it.
and down.
Yeah.
The force is acting on things.
Absolutely. We call it vertical in reality, right?
Thanks, Bev, for actually acknowledging that.
And guess what? Perpendicular to vertical is horizontal. Now, both the vertical and horizontal are straight lines. A horizontal straight line all the way along it is horizontal.
You
But
haven't
every
established
bit
that.
along that horizontal line
No, because the
is
vectors of
called
those
a
forces are not
horizontal.
parallel.
All of it.
The vectors of those forces are not parallel and can be measured as such.
In fact, the very thing that there is such a thing as a horizontal line would sort of seem that you could make a perpendicular to it, and that would be vertical. You know,
That was the point that I was trying to bring up when Emerald was going at you with this. Is it's important. You guys are using two totally different axioms, and in the what we're all talking about is a horizontal plane that's created and a vertical line that's created are unique to that point. Once you move that
all
point,
right angles
that
are
vertical
equal.
line, that you created before, you know, that's the line now, but it's not the vertical line. And the horizontal plane you created before, sure, it's a plane, but it's not your horizontal plane. So you can't just move points from that point and then say that that same horizontal plane is the same horizontal plane you were using before.
Well, they
You
are
have to make
straight
it
lines,
unique
right?
to every point.
Vertical
plane
is
is
a
a
straight
point.
line. Horizontal is a straight line. They're both definitely straight lines. And the vertical line you can call vertical all the way along it. And the horizontal being perpendicular to it. I don't know if you've ever done geometry. In order to construct the line perpendicularly, you would need to make a function of making arcs and all of that. But it makes the line, it's like it definitely got a length to it. So that means you can make a shared straight line segment and construct that straight line and make it go on as a straight line.
Yeah, that's right. As
And
a
it
straight
would
line,
be
that's exactly
horizontal
correct.
all the way
No,
along
that's
it.
what I'm saying. It will be a straight line still, but at every point along that surface has a unique horizontal plane and a unique vertical line.
You're saying
every
a
single point.
horizontal line isn't horizontal all the way along it?
It's not a horizontal from that reference point. No.
Where is it horizontal? Go on. In reference to the vertical.
At that single point. At that single point.
Which
The
single
horizontal
point?
line is the point. Oh my god.
Which
that one
single point? On the vertical.
Where it was established.
On the vertical.
Where it was established.
On the vertical.
I'm telling you where.
Okay,
No,
we gotta
it's only
hang on. Hello, we gotta let each other talk.
Yeah.
It's only horizontal
it's
on
a
the
vertical. It's vertical, a vertical line, and a horizontal plane, or only that vertical is only a vertical line and a horizontal plane in reference to the point where it was established.
Right. So
once
it's only horizontal. The point where it's vertical.
Once you move that point, that's still a plane, and that plane still exists, and the line still exists, but it's no longer a horizontal plane in reference to that point.
Right. This is one of the things that we did earlier, right? I asked, how large can you make a horizontal, right? He said infinite. Now we've just regressed to the point on the vertical. Like right the hand just
zero
said,
dimension.
The only point it's horizontal, which is a nothing point, right? A point is that of which has no parts. It doesn't exist. So the only point it's horizontal is where the vertical is. It's on the vertical.
Yeah, see, this is without all the rhetoric, it'd be a lot
just said
quicker.
yes.
Bev.
Can we get a confirmation again, please, for everyone?
When I was ready to address you, I didn't address you until you were done talking.
You did. Can you answer it, please?
Just because you heard me say one word doesn't mean it's time for you to cut back in, dude.
Right.
So wait a second. Yeah. Whenever Emerald, when you asked Emerald that question,
is that
he was
another
exactly
yes
correct.
again?
Bev, stop, dude. When you asked him that question, he was exactly right. But the way you interpreted what he said based on your question, yeah, that plane extends out to infinity in every direction. That plane extends out to infinity in every direction. But that horizontal where on that surface of that sphere, where that's going to be a horizontal plane, it's only going to be at that point. So that question that you're asking, you can answer it any way depending on what you're actually looking for. If you're looking for how big is the plane, it's infinite. If you're looking for where's horizontal, only at that
plane. I made it very clear. How large is the horizontal plane? And you say, just at the point where it's vertical. Well, the horizontal plane isn't vertical anywhere. So you're saying, I'm guessing, that the horizontal plane has just disappeared. Which takes me back to the fact that I said earlier, the very existence of horizontal line or plane seems to prove it.
I feel like you would set the horizontal first, then compare the Earth to it, right?
Absolutely.
And this is happening in reverse now. It's like, oh, the horizontal, we just conform it to the Earth. Like that's. How do you know what shape it is if you're conforming your straight to possibly an irregular shape?
Well, the consequence of what he's saying, the horizontal disappear into a point, means bendizontal. Like we predicted it ages ago. He's just scared to say it. They want that horizontal to be that two-dimensional surface of a sphere. It's a straight line that they want to bend round a thing. They want to turn it into a circle.
What would be your baseline then? Like, what would you compare it to? How would you know straight from curve, from arc, from whatever if you wasn't able to create a horizontal?
Yeah, that's why there are
It's much easier. It's much easier
There is no
than you
baseline.
guys think. That's much easier.
Then you think the Earth is a ball.
This picture I posted has an orange line and a blue line, and from each of those positions, that's the horizontal from that point. Those horizontals, though, don't match up to each other. You can reference that second point in reference, that second vertical in reference to the first plane you made, and you can say, where it is along that plane, or maybe what angle it is from that plane. You can reference the plane, but it's not vertical from that second position. I mean, it's not horizontal.
Measurements would be screwed up.
Emerald was doing way better than you were, Kosho. You've come in and absolutely messed it up with your pictures and stuff.
And neither one of those are horizontal. They're both on a
It's fantastic input, Bev.
How do you put two lines and neither? You said both these lines are horizontal and neither are.
You asked me a question.
I enjoyed
again.
listening to Emerald too.
They're pointing upwards, Kosho, your two lines.
Well, it's just crazy how you can ask a surveyor if he could make a horizontal over post for you, and they say, yeah, no problem. But what Kosho's showing is totally pissing in that face.
Then ask him if those verticals are parallel.
What I just now said was you make a horizontal from one of those locations. You can reference it from the second location.
Ooh.
This is what surveyors do.
I got
no, they don't.
I got a question. How you get a tangent out of that? Out of that picture? I know that's off topic. Sorry.
Yeah, you ever ask a surveyor if plumb lines are parallel? Guess you never thought about that one.
Whoa, hang on. Oh, yep. So I did a job for 15 years, and at least half of those I was on third shift with the surveyors. And they would have to plumb their instrument to the tripod, then they would plumb it to the top of the instrument, and they relied on those parallels for miles and miles and miles to make their measurements. So yes, they relied on their plumbs being parallel.
No, they didn't.
Throughout. Oh, that's like you went off. Oh, sorry.
That's a nuh-uh.
You said yourself that you asked the surveyor if he can make a horizontal line between 4 points. He said, yeah, sure. And then you said that it would get lower and lower or higher and higher as it went on, meaning that the water would fall towards you if you made a water level to it. You said you asked him, and he said this.
Well, that was
you might be making that up, or are you talking about a conversation?
He said this last night.
It was Sean G that said that.
No, it wasn't. He asked.
Yes,
he was asking
it
Sean G.
wouldn't be Buster, I can tell you
Buster had
that.
a conversation with Sean G, and it was Sean G that he was talking about, where he was talking about making the 4 lines over the 600-meter distance, and then going back and having a water level. That was Sean G that he had that conversation with.
I specifically said the other night that he said he was a surveyor. I didn't say he was a surveyor. I said the guy said he
Regardless,
was.
yeah. That's fine, but when you said that though, you didn't say Sean G. You said a surveyor, so that's why.
Well,
That's why.
he
That's
wasn't
why I
there,
said
so
that.
I didn't want to say
That's it.
he wasn't there,
That's
so I
fine.
didn't want to say his name.
You're not wrong for saying that, but I'm not wrong for saying that you said that because that's what you said. So
Hey, wait a minute. Can I just get it? Can I just get it to back? Because you've just said that the surveyor said the line would go up and up and up, or down and down and down.
Yeah,
and
he
the
misrepresented
water
that too.
would level would
he said,
change.
he said, it would get higher and higher as it went on. Meaning, if you put water and put a water level there, the water would
No,
fall
that's
out towards
you're
where he started.
misrepresenting.
Yeah, that's
You're
not
misrepresenting.
All right, go ahead then, and say what it was, and say something different than that, because that's what you said. You said if you made a water level, it would fall out towards you.
Wait,
let
me phrase it the way I said it, the way it was. The conversation went. I asked him if he could make me a horizontal over four or 5 posts over. I forget the distance. Let's say it was 500 meters. It didn't matter. He was fine with it. If he could make me 4 or 5 posts, the horizontal line the same all the way across. He said yes. And I said, okay, those are physical marks on posts, horizontal. He said yes. I said, I'm going to go behind and put the water level and connecting tubes, all the same water level at each mark. What will happen? He said they will gradually fall away from the first one.
Uh-oh. Now, what's that mean?
Yeah, you tell me.
Yeah.
And I asked him, now he goes to the other end where the water levels dropped away, and I need horizontal marks from where the water level, the last one, going back.
Yeah. And?
You tell me.
Yeah.
What do you
All
think he
lines are
said?
parallel.
What do you think he said?
What did you say, RC, since you're piping up?
Why would I tell Buster's story for him? Go ahead, Buster.
No, y'all want to make all these predictions on what things do. You tell me if he resets up at the other end where the water level drops away and makes marks back. You're the smart guy.
Oh, go ahead, Buster. Tell your story.
Well, he proceeded to draw. He proceeded to draw what would happen. Realized he screwed up, and started on something a whole different topic of what we'd agreed on, terms we'd agreed on.
Which means
he started drawing lines back where the water level was going higher than the new horizontal marks. So you tell me.
This is Sean G, right?
Yeah.
Yeah,
I didn't want to say his name because he wasn't there, and I didn't feel like it was fair to bring his name up when he wasn't there.
Wait, hold on. So, go back to this. Go back to this.
We did record it, so these drawings are available.
Yeah, but didn't I show you guys my little thing, like how it doesn't go up, whatever? I showed you guys my thing.
Wait! You just came in.
Well, not exactly.
Right?
I've kind of been here. I just kind of came in voice-wise, but I've been here though.
2 hours, 3 hours. You been here?
Yeah.
Yeah.
I don't really know what your point is, Buster. Could you elaborate?
It drops both ways, Mikey.
We had the dropping.
It drops both ways. And?
Well,
he said he could make horizontal marks on 4 posts. I put the water level up. I asked him what would happen when I fill the tube up.
This is a surveyor, right?
He said he was a surveyor. You can ask him if he's a surveyor or not.
And?
He claimed he was. He said the water level would drop away gradually from the first mark at each one. The horizontal marks that he made, the water level would drop away gradually at each one.
Okay.
And I said, now go to the other end where the water level's dropped away from your mark, make a new mark at the dropping point, and go back. And he started drawing lines where the water level was going higher than his new horizontal marks.
Okay.
Yeah. Which
I
is
don't
the
know what
same
point
as
you're
what
trying to
Armour
get with
did
this,
as well
Buster.
too.
Look, I'll just send my GIF again. Let me see.
Yeah, we wouldn't.
Yeah,
we
Buster,
would
I'm not
expect
sure what
you
point
to
you're trying to
not
get at.
understand it, right? Because it's hard with your model. That's why we've been going at this for
No, Bev,
4 hours.
this isn't hard. It's just trying to get you to recognize the fact that plumb lines aren't parallel. Therefore, you have no argument about
Keep
this.
claiming that. What
why
evidence
we-
do you have to go with that claim that you keep making?
Because I've seen the measurements that they're not parallel.
Ooh, measurements.
Well,
Some
explain,
numbers.
elaborate. Please
Yeah.
elaborate.
I've done
I
it about,
elaborated.
I don't
You
know,
elaborate.
3
Some
times in the
numbers.
past week.
You've done what? What have you done in the last 3 times in the last week?
Explain and show the measurements that plumb lines are not parallel, Bev. I
Show the
just said it.
measurements. What measurements?
Bev, are you deaf or having a stroke? Which
Well,
one?
I've just told you earlier, we can do 90 degrees perpendicular. Those are the measurements that we can show that horizontal and vertical are perpendicular. All perpendiculars to a plane will be parallel. Geometric.
And how did you
fact.
establish it's a plane, Bev? And how did you establish it's a plane?
Horizontal
Can we
plane.
get this?
Bev,
Can we get
listen to
those
this.
measurements which you done last week?
So, Bev, let me show you your logic here. Let's check
No.
horizontals.
Last
Horizontals
3.
are. Hey,
We
can I finish my
establish a
sentence, please?
horizontal plane, yes.
Bev, how'd you do that?
By getting a tool called a level.
Yes. How
Establishes
does it do that?
a horizontal plane of reference. We use that tool
Yes.
to establish
And how does that
a
tool
horizontal
establish
plane
it?
of reference.
And how does that tool establish it, Bev?
By making sure it is exactly horizontal.
How does it do that, Bev?
Which one? Which tool?
The level.
A level, right? An auto level establishes a horizontal through prisms.
How does it do that?
Through prisms and
Oh, really?
calibration to make
And how does the
sure
prism
it
do
is
that?
exactly horizontal.
And how does the prism make sure that it's exactly horizontal?
Because it's a tool called a level,
Oh my
and that
gosh, Bev.
level has to be horizontal. It
Yes.
is calibrated
How?
horizontal. I
He was
asked the
asking
guys at
how
the
it
calibration center.
Well, how,
Stop being
why
a
does,
dick.
Yeah, why does RC get to ask all the questions and we ask
Oh,
him
because
he's
Bev
already explained
because
it?
Bev just keeps talking himself in circles.
Yeah, but
Well,
you
no,
haven't
RC,
explained
How?
your
is it a
claim.
contention? RC, is it a contention that in surveying you can't create a horizontal plane? Is that the contention?
It's like
No, it's that
asking why the rock
no,
falls. It doesn't
no, hold up.
matter. It falls.
Hold up.
It doesn't matter how the horizontal is established.
Oh
It's
my
established.
gosh.
Now you just saying why and why
No.
and why is ridiculous.
No, the point is that these
No.
horizontals.
The point is, when he had a conversation earlier, he ran away from that one. Now let's talk about something else.
I didn't run
pipe
away
back
from
up.
anything. Everybody's just talking over me like they are now. So at some
Okay,
point, I'm just
let's
like,
talk
RC
about.
doesn't argue.
I can hang on. Give me 1 second. RC, this is how I see it. You're complaining, right? But when asked when you complain that
Which, yeah, can you shut your mouth now? Now the fact that like you actually can
Oh.
mod, then now you pipe up. When everybody's talking
Look at
over
this
me,
guy.
now you pipe.
Thank you.
Yeah, he's done. That's not tolerated. But I'll finish what I was saying for the room, the audience, which is all I care about. When RC was asked to talk about or prove his claim of plumb lines not being parallel, he kind of just said he's already done it, 3 or 4 times. He's not going to do it, and then proceeded to ask Bev to do all kind of things. So kind of strange.
You can establish the horizontal.
Deflecting away from his measurements.
There you go.
Just saying why and how over and over and over, like, is that at a certain point, like, right? Like, we don't know how the air and the water interact. It does. Okay, you want to keep asking how. You can. You're not going to get anywhere.
Can I point out also the video that he's put in the chat, right? Spotlight on the guy from Maine, because whenever you get into this conversation and they say plumb lines aren't parallel, well, this is the guy from Maine, Jeff. Spotlight on him. Please watch that video. Have a look and just watch over it. Try and work out what he's doing. Surveying is a very simple geometric process, right? Just have a look at it for yourself. Watch what he does. Like, see whether you think what he does would be proof enough for you to establish that plumb lines are not parallel. Bearing in mind, he never gets a plumb line out.
he never plums his instrument or shows that he did.
Yeah. So it's up to you how much you want to trust.
No, I don't need.
There's geometric
You're not gonna
facts
convince me.
of vertical and horizontal being able to be established, and there are procedures that go through with surveying that prove this, that vertical horizontals are parallel is the basis of surveying and elevation changes. Like we said earlier, a change in the vertical is a change in elevation. Well, that's reference to something. It's got to be reference to the horizontal. Horizontal's a straight line. If it wasn't a straight line, they wouldn't be able to do this job. Horizontals are parallel. It's a very easy, simple logic statement that you can make. That's also provable, rock solid logic. You struggle to find anyone to argue with the logic behind it.
Isn't that the reason why theodolites have a very small range of where they're usable? It's not because the scope is bad or because the sight on it can only see things that are close, but because of the exact thing that you just said, that the methods that are used are using horizontals as if they can be seen as being parallel and all this. Like you can use a horizontal somewhere and use that same horizontal somewhere that is in this close range without having to assume that there's two different horizontals.
Are you talking
Isn't it like
about
2 miles or something like that?
theodolite, did you say?
Yeah, a theodolite or
theodolite just measures angles, right?
Right, yeah, but you always claim that it's, or not you, but people always claim that they're only because I think B-Baller bought one and he used it over a long distance, as I've seen plenty of people do.
No, you see, no, you've got wrong. He didn't buy a
theodolite. And so so people were
so you didn't buy a theodolite. Like you've got confused already. It's a completely different tool that he's bought.
An auto level, then, right?
There you go. There you go.
Okay, yeah, same idea though. That they have a range in which they're usable.
Yes.
Yeah.
Yes.
Range in which you can use them. It's a very short range, like 2 miles or something like that.
No.
And after that,
it's less than that. Whoa.
Whatever the range is, something less than 2 miles.
100 meters.
That's what I'm saying. Is you can obviously see things that are further than 2 miles.
Mm-hmm.
The scope works on things that are further than 2 miles. That range, I think, is defined that way because of the way it's used.
But the tool.
Why do you do that, man?
He's still talking.
Why not finish? Wait till someone's finished talking, dude.
Right.
No, Bev wasn't done. Go ahead, Bev.
Yeah, Bev wasn't done interrupting me. Right, I was in the middle of saying something.
Right, the tool, the auto level, requires as part of its use the measuring rod in order for you to look and see. If you can't see the measuring rod, then the auto level is of no use.
Okay. So why can't you see it further than the range that it says? Couldn't you just look at it?
Why can't you see the measuring rod?
Right, yeah. If you can see the measuring
Because
rod
you
at 3 miles,
can't
why couldn't you use
you
it?
can't see the measuring rod at 3 miles, though, can you?
Or
That's,
what
that's
if you
why.
see it?
Why not?
What if you see it, but you can't tell 1 foot from 1.5 foot? And what good is the measuring rod if all you can see is this thing? You need to be able to see specifically where on the measuring rod your crosshairs are hitting, not just are you hitting the measuring rod.
Mm-hmm. You need to see it and read the measuring rod. You have to. Otherwise, there's no purpose in seeing the tool. Now, it only works over a certain range because when you look above that certain range, I don't know if you've got a camera or anything, P1000, P900, you can see the distortion in the air. Looking through the air causes distortion, and that stops you from being able to see. So if you look too far, you cannot read what it says. And that image that you see within the scope of the thing 2 inches away from your eye is wobbling about all over the place. You can't read it. So that's why you have to stay close. So you have to be able to read the measuring rod. That's one of the problems you've got with your imagination of how these tools work.
Oh, what if you just use a better lens that had better zoom?
Brilliant. Better zoom.
Yeah.
Yeah, you go
Right.
go and get one made. Like, let's start a club.
No, see, I mean, there's 32 times zoom, 28 times zoom, 24 times zoom.
Yeah.
Why
Right.
not just split it up?
32 is the
and-
best
and
zoom you can get. That's the one we've got.
Just do 50 meters at a time and make it,
Yeah.
why are you struggling at the edge of
Ultra
this thick
accurate.
range? Why not
They-
just,
they
bring
do,
it back and do it 3 times?
They do precision levels, right? And in order to do first order measurement, you have to do the shortest distance. Right? You go further, you go up through the second class measurements, it gets worse because your accuracy isn't as good. The shorter the distance, the more accurate you can get. And that's on the horizontal.
Yeah, I would think if you even if it says it's accurate to 50 meters, I would say at 25 it's even more accurate. Like the smaller you make these segments, the tighter you can make this line overall.
Yeah, you got to whap a micrometer on it, right? And you narrow in on the scope to like a centimeter. So you can go micro millimeter 0.02, I think, with some of the top precision levels.
That's flat.
Yeah, that's horizontal, right? You can definitely show a shared straight line segment with that. Keep going and on and on and on and on. And that would be a horizontal, like a straight horizontal, not a curved horizontal. You couldn't imagine a curved horizontal being made with the precision level.
Kosho dipped off.
Because I talk too much.
No, you don't talk too much. I was going to bring up that I did look at some better, better equipment back in the 50s or 60s, something like that. And yet, why did they go back using that type of stuff? Now we're just stuck with the, 32 zoom. I think they realize something. You can't use a tool like that. Tool abuse.
Well, I think we've gone full circle. We've done all of them. We had the auto level working for a bit, and then turns out that the auto level can't establish a horizontal one. I think I heard that at some point. I don't know who's been telling everybody all of these things, right? I don't know who's been telling. I mean, who has been telling people what these tools can do? I mean, I've tried to show it people. I mean, next weekend, my lad didn't come down this weekend, Gio. So next weekend, pray for some good weather. We'll get out and we'll get the cameras out. We'll have 3 cameras on the go. We'll get a live stream going. Everyone can see what what exactly you see through an auto level, how far away you get, what you can see through the distance, you know, how far you can get, what you can see. And then we can do the 500-meter test. George, well, in fact, that guy there in the main surveyor, his plumb line's not being parallel, and how accurate he says he can get his measurements. We can test all of that and show you, hopefully.
Didn't you do this once at the beach already?
Yeah. Yeah, when we went under the horizon.
Yeah, when you were in the sea.
Yeah. Over our heads. Yeah, but I mean, this one, I mean, that one was about a K, I think we worked out all the way to the beach. But this, if we go over the guy from Maine and his video, the plumb lines not being parallel is really bad methods. But he says he can be 1 arc second over 1,500 feet, I think. So we can measure that. It's like 500 meters ish. And 1 arc second over that distance is about 3 millimeters. So we can get the auto. I know his tools, he doesn't have a 32 times scope. So you'll just have to imagine that the 32 times scope that we've got is a bit better than what he can see. And you'll be able to see what 3 millimeters is over that distance. And he says he can measure an angle to that with his tools. You'll be able to have a look and see what it looks like. See whether it's possible or not. Like, that's you guys will be able to do that. You'll be able to just have a look on the Discord screen. There'll be a camera and it'll have the view that you actually see through an auto level. We'll give you that view and tell us whether you could measure an angle to that 3 millimeters. I'll get a little piece of card or something and stick it on the measuring rod.
Bam. Conversation with Emerald was pretty good. I was liking it.
Always good to have the geometry talk. Can't call it an argument, can you?
Nah, I mean, I said that's why I said conversation, not argument.
You know, I've got. Does anyone know Limey Play? He wants to.
Nah.
he wants to have a. I don't know, debate or a chat about geometry with us.
Let me play.
Judging by the way it happens here, that there's minders that come in to help whenever, you know, something isn't going quite right in the argument or something, or somebody's made a mistake. They get the savers to come in. I don't know whether that had happened with Limey. I don't know.
All right then.
We can hardly hear you, Silent Zero, if you're trying to talk.
Nice.
What do you want about me?
Oh, I thought I saw your mic lighting up, but I can only hear a tiny bit of what you were saying.
It was? Let me check.
Someone in that group.
It shouldn't be because it was. Are you
Unless
saying
it was
muted?
Montreal.
Yeah, so let me see. Oh, it should not. I don't know what the hell. That's weird.
Damn. Somebody write you a 4-page letter in in the Discord there, Beth.
Yeah.
Had to put some Aaliyah on that one.
Yeah, I think it's basically saying that it's just an assumption that plumb lines must be not parallel.
No, I'm trying to back you up there.
Ooh.
Yeah, it looks like a lot of text, but maybe have a careful read. Won't take more than 2 minutes.
Yeah, I know. That's what I'm saying. It's like it's an assumption. One way. Normally on the sides of the side.
I mean, the author says that the student of today's, even back in this days, 1897, the student knows it to be false with this whole plumb bob stuff. And he says it's not due to direct observation. So he means this knowledge the student got about the Earth is inductive. So it's not scientific.
Well, I don't know. I think it'd be a bone of contention that scientific is an inductive, right? The geometry is deductive. Right? As in, it cannot be measured. Therefore, it's not geometric, right? And therefore not deductive. The only deductive stuff you can make is things that I've said. Vertical is perpendicular to horizontal. Horizontal is a straight line.
Yeah, of course. And that's what I tried to say.
Yeah.
You can't base your acquisition of knowledge on contradictions, and the observation has to be in the first place. Like always, you have to observe something and then come up with something, which relates to it and explains it and so on. But you can't make something up and then project on reality,
Yeah, you can only deal with reality. That's why I say everything I say is based in reality. It is, it can be proved. I wouldn't bother saying it if I hadn't proved it to myself.
And that's why things that are true have a perfect correspondence in the thing itself with its presentation in reality, like it comes to our senses.
Yeah.
That's a painfully good argument for the validity of the Earth's stillness, man.
Yeah, we've been saying it just recently. The logic that has been given to me as a gift through geometry extends far beyond the geometry, right? The logic is just there. That's how we find our proofs, and it's substantiated by reality all the time. As in, we can prove what we say, like you said. Stationary has to be, right? Plumb bobs only work at stationary, right? Hydrostatics is the staticness of the water that makes it horizontal. Staticness of the plumb bob that makes it vertical. If there's any motion to any of that, the horizontal and the vertical don't exist. Well, they don't exist. You can't establish them with the tools. There's no motion either. It's all pretty simple, and the geometry and the logic goes to help you. And people get triggered by reality, unfortunately. Sorry, guys.
It's not your fault. They did it to themselves.
Nah, you good, Beth. You know that. No apologies there.
They didn't do it to themselves, though, right? Everybody does it to everybody all the time. Reinforcement of a model. teaching kids things that untruths, but you don't know that they're untruths because you're just unaware. Ignorance is bliss, I'm guessing, most of the time. And then once you get triggered by somebody telling you a truth, well, there's a couple of ways to go. You either accept it or you get triggered. You either research it or you get triggered and you fight against it. It can't be true.
Or as they say, they don't want it to be true. It's right there before you.
Yeah, I think most people have spent so long, especially in these little arenas, saying that flat earthers are stupid. And now they're having to realise it's not actually a flat earth claim. It's just a claim from reality. It's just that they've given reality a really nasty label. Anybody questions the model that gets this nasty label. So it must be a bit of a trigger when you realise that reality's got nothing to back up your model. Look at that. I don't know what that Pete. I don't click links. Ever since I heard Mactoon IP address doxing somebody, right? From I don't click links.
It's one of the strategies they've used over time because
Yeah,
they want.
there's nothing there.
They figure like they want to expose you because you shouldn't be allowed
Just
to
long
say these things.
PDF.
Yeah.
I'll do it from my phone. I don't give a shit.
Dude, it's it's the University of New Brunswick. Fine.
Well, if
And
it's
the university about plumb bobs.
If it's HTTPS, you're okay. But if it's not HTTPS,
I mean,
It
why would
is.
you even use? Go ahead, Rix.
I just said it is. That's all.
Yeah,
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 that's
yeah.
generally the rule of thumb. I mean, sometimes
Why
it can
would
be.
you? Why would you even use the word parallel at all? Silly. Silly little games. Make those train tracks straight, but don't make them parallel.
I don't understand the point of the circular argument over the last 4 hours.
It's a waste. It's to waste your time with everybody time that's listening.
Don't understand the circular argument from which point.
Either point, the fact that you want to make it happen and the fact that they want to defend whatever they think they're defending.
I'm just.
Yeah, because
it's coming from reality.
Yeah, but in order for anything to have value, you have to define it before you hypotheticalize it, you know? So you have to know what it is beforehand. And so are we talking about optical or physical? So then it doesn't matter either way. You'd have to verify in person, like they said, in order to establish the proofs that you're trying to prove.
Exactly, right?
I think that's the whole point of the actual question.
Yeah,
So did I just summarize 4 hours?
Yeah, the proofs are yours to go and find out, right? Do you think what we've talked about tonight gives you enough validity to find that proof for yourself or not?
Well, their point of view comes from a position of philosophy, and they're going to ascribe any of the explanations that fit with that philosophy. So it doesn't matter.
No, I'm saying you. Do you not think you could find a proof that vertical and horizontal are perpendicular?
What's the point? Who cares?
Well, if you could prove it to yourself, then you would have a proof that, you know, it's not a globe, right?
Well, I'm not a glober,
I know.
and I don't need this argument to decide that.
But what's the argument though?
Nobody does. If you know, like if you don't personally need the proof, then
But who does though?
fine.
That's what I'm saying. Like who's
Anyone that
gaining from
wants a
that?
proof.
But what's the argument though?
What's what argument?
There's no argument. Nobody's arguing.
Perpendicular and horizontal. No, well, I mean the whole because he said about perpendicular and horizontal. I'm asking about that. What was that about?
Yeah, vertical and horizontal are perpendicular.
Yeah.
Right, and horizontal is a straight line.
Mm-hmm.
Yeah.
Yep.
Okay.
That's it. That's all you need to know, right? In order to disprove
it's
the
not.
globe model. It is.
No, it's not.
Yes, it
I
is.
just explained why.
Go on, explain why then.
And I'm not going to do it in 4 hours. You can hypotheticalize a two-dimensional claim, but you can't make a three-dimensional claim without verifying it. And either way, you'd have to have an understanding of the shape before you could make these claims anyway. You'd have to have the framework already. You'd have to know the shape already before you could come up with this stuff. Now, there was one point that was actually useful when you said about the triangles and the 180 degrees where you can establish a line. That was a good point that somebody could agree with. Everything else is just circular reasoning.
What, the horizontal and vertical are straight lines. Right? I mean, that isn't circular reasoning. That's just a fact, right? And the fact that
In a two-dimensional sense, yeah.
No, in a three-dimensional fact. Because Euclidean geometry establishes those baselines in 2D. But then in book 11, it takes it to solid geometry, which is 3D. And then from there, you get all of the principles that are used within surveying, i.e. reality. All of the principles of geometry that they use for building houses and roads and towns and cities, canals, all of that comes from the basis of the 2D geometry, but into the 3D, into the reality. That's where you get all of those principles from, right? The plane and perpendicular to a plane. All of those occur in the 3D solid geometry.
It's an interpretation, yeah. Because when you're establishing this line that you're talking about, you're taking a two-dimensional snapshot of a perspective, and then you're applying it to a three-dimensional reference.
Well, no, when you get a tool like a water level or an auto level, and it establishes a horizontal plane of reference, that horizontal plane is actually a horizontal plane.
So, what are you trying to say? You're saying we wouldn't be able to do that on a ball Earth? Is that what you're saying? Is that what the end goal of this argument is? That we can't do it on a ball?
No, this is from reality, right?
Yeah,
you
but
can imagine whatever you want, but the tools levels establish horizontals, right? Now, there is no geometric way to make that horizontal wrap around a ball. It's a straight line.
All right, but I'm just saying that I think we could still do like surveying on a ball Earth. It would still work.
Yeah, I know. There's loads of people that do, but you have no experience in surveying, and you have no experience. I don't know. Your geometry might be okay, but reality geometry, Euclidean geometry, you probably won't have studied that.
You'd have to establish like little flat surfaces on the sphere. It wouldn't be the sphere.
Yeah, horizontal wouldn't be horizontal. You wouldn't be able to establish a horizontal. On the globe model, there's no such thing as a horizontal line or plane. They don't exist. On the globe model. You can think they do.
They just don't mean what they exist, but they just don't mean what you think they mean.
No, they are a plane in reality perpendicular to the vertical. That's why I said at the beginning, horizontal and vertical are perpendicular. Now that's all you need to trigger a
At a
glober,
point. That's correct.
right?
At any one point, you are correct.
The straight lines, though, you can't have two straight lines
That's correct. They're
perpendicular
straight lines.
at a point. Those straight lines
Yes, you can.
exist as straight lines.
No, you can have a perpendicular, a horizontal and a vertical perpendicular at a point.
No, a horizontal is a line, right? And a line needs 2 points minimum, right? Not 1 point. You need 2 points to establish
Yeah, but you
a
can define it as
line.
perpendicular. You can define it perpendicular to the vertical.
We've
It's
already
actually a
been through
plane.
this like twice. I mean, it was a circular
It's actually
argument
it's
earlier
actually
on,
a
right?
plane.
Now
It's actually a
you've done away
it's
with the
actually
horizontal, which is what I said.
it's actually a plane, but that's another issue.
A horizontal plane. How big's a horizontal
Yeah,
plane?
plane. Yeah, horizontal tangent to the sphere.
How big is a horizontal plane, NASA?
Well, plane goes on to infinity. We know
A
that.
horizontal plane. I'll say it again in case you didn't hear. How
Yeah, but the
big
problem is that
a horizontal
you know the answer to that
plane?
question. You know, come on, you know the answer to that question. Don't.
You already messed up the other night, so are you going to
Infinite.
answer the
What
question?
other night?
Infinite, isn't
What
it?
other night?
It's infinite, isn't it?
What? Yeah. Okay. So
A horizontal plane is infinite. So therefore, all perpendiculars to that plane will be deemed vertical. And as we know,
incorrect.
geometric proof, all
Incorrect.
perpendiculars to a plane
No, your
will
geometric
be
proof is
parallel.
bullshit. No, your geometric proof is bullshit because it is only tangent
Your
to the plane
geometric
at one
proof
point.
is bullshit.
Yeah, because it's not geometric.
Wow.
You
Get him
want
again,
geometric
Bev.
proof?
Hey,
Look at
chill.
this one.
How can I get
Look
that
at this
on?
one. Look at this one. How about this one? Your geometric proof. Do you,
430.
watch it.
Let
You
me
probably
get
won't
that.
understand it.
Get that on
It
the
proves that
board.
a surface of a sphere is measured in square units. Therefore, guess what? It's two-dimensional. Now, this is real geometry as opposed to
I mean, it's a short video. It's not like those 30-minute videos you guys be sending, you know, or those.
No, this one. I don't know how long this one is. How long is it?
Yeah, it's like 9 minutes or 10 minutes, more or less. So I mean,
That's all you
it
need.
proves what? Sorry.
It derives the formula of a sphere.
Yeah.
The surface area of a sphere.
Yep.
That's 2 pi r squared.
What?
It derives. Did I have to say it again? It derives the surface area of a sphere. 2 pi r squared.
No, I think it's 4.
No,
isn't it?
Yeah, 4 pi r
Surface
squared.
of a sphere. Oh.
Oh, damn. Got it wrong.
You got it wrong again.
Oh,
I even give you
sorry.
2 or 3 chances to correct yourself there as well.
Okay, I did. I misread. 4 pi r squared.
Holy shit.
2 pi r times 2 r equals 2
It's
pi,
just
4 pi r.
Just
squared.
like the circle of the radius, but 4 of them.
Well, no, the diameter of a circle is measured in r.
No, the area of the circle is pi r
the area of a
squared.
circle. That's correct.
Right, and so
The
the
surface
area, the
area-
surface area of a sphere is 4 pi r
Pi
squared. Just
r
4
squared.
circles.
4
And
pi.
as
No,
we-
not 4
as
circles.
we
4
all yes.
pi circles.
What?
4 pi r squared, not 4
Yeah,
r
but
squared.
pi r squared is the formula for the area of a circle. Pi r squared. If you put a 4 in front of it, it means there's 4 of those circles.
No, not really, but okay.
Yes,
Means it's
pi
equal to it.
r squared is the area
Okay, if you
of
want
a
to look at it that way.
circle.
But in the meantime, they
So
derive
it's
it.
just
You know-
4 circles. So a circle, as we know, is a 2-dimensional shape.
Yep.
So
and
if
so
we have
is the
4
surface
of
area
them,
of a sphere.
if we have 4 of them, what are you sort of surprised that it's 2D?
Yeah,
because
but
the
the
circles are
problem is-
2D, and we
the
just
problem
have
is that-
4 of them.
Yeah, but see, the thing about if you actually look at
amazing,
it,
isn't it?
Listen to me for a second, Bev. Will you just listen for a second? 4
Come on.
pi r squared is the surface area of a sphere.
Yes.
So
it's
thank
just
you for
4
admitting that the surface area of a sphere is
circles.
two-dimensional.
4
It's equal to
circles.
4 circles.
Yes. And a
But it,
circle, as we all know, is a
yeah, but these are. This is.
two-dimensional
Hold on a
shape.
second. Listen to me once again. Listen to me again.
No,
This
no,
is
wait,
the
wait, wait.
surface
That
area
wasn't done.
of a sphere.
Yep.
Sphere.
Yep.
Which
I
can
thought it was
be,
three-dimensional.
which can
Nope.
well the like that's what I'm getting to, right? The
No,
formula
the sphere
the
is the surface. It's
for
two-dimensional.
the surface
Look at
area of
look
a
at the
sphere.
derivation.
Just keep
Look
talking.
at the
Don't worry about it.
Look at the derivation.
Yes. 4
Look at the derivation.
pi r squared. Now, a pi r squared, you take the radius of the sphere, right? And you do pi r squared, which is the area of a circle.
Yeah, but
like
4
one circle.
pi
So
r
you
squared.
take the r value of the sphere and you find out what the area of one circle would be with that r value. You then times that by 4 because you want get 4
Look at the derivation.
circles.
Thank you for admitting that the surface area of a sphere is two-dimensional. Welcome.
I'm just trying to help everybody understand.
No, you're not. You're trying to obscure the fact that you
formula
look at
for
the
surface
derivation.
area
Look
of a
at
sphere is 4
derivation.
circles.
Okay, so it's 4 flat circles. Thank you. So the surface area of a sphere is two-dimensional. Thank you.
What did you just say?
It's equal to
Say that again.
as Bev so closely points out, it is
2D.
equal to
No.
the area of 4
Yeah.
circles. So the
2D
surface
is a
area of a
flat
sphere.
circle, right? That's what it means.
So is the sphere then. Thank you.
Flat circle.
If you
Yeah.
just
So
admitted that the
2D
circle is that you just
2D
admitted that the surface of a sphere is two-dimensional. Thank you very much, Bev.
you said it's flat, right? A flat circle.
It's two-dimensional.
Okay,
So
so
is
the
the surface area of a sphere is
flat.
two-dimensional. Thank you.
All right, yeah. So 2D is flat.
No, the surface area of a sphere is two-dimensional. Thank you very much.
Oh my gosh, why you can't let him finish? Go ahead,
Because
Bev.
he's talking bollocks. He has to actually
stop,
look.
Stop.
He's talking bollocks. Please
Let him
look at the
talk.
derivation.
I don't understand. What
I
you
don't
scared of?
understand what you're getting at here, right? Look at the derivation. Yes, it's 4 circles. Big whoop. It's 4 circles. Circles are two-dimensional shape. You've just admitted it was
Oh, you
flat.
muted me now.
You've just admitted it was flat, right? 2D is flat.
2D is two-dimensional. You admitted that. Thank you very much.
Yep. Flat.
So the surface of a sphere is two-dimensional. Thank you.
Yeah, because I mean,
So
if
you
it's
base the spherical calculations off of a flat circle.
No, if you actually look at the derivation, I'm going to post it again. It's actually not based on that, but nice try.
Post it again, yeah. 4 pi r squared. Everybody knows pi r squared is the area of a
Yeah,
circle.
in the meantime, the sphere is 4 pi r squared.
Yeah, it's
Interesting.
4 circles. Like, why
It's
can't
equal
you
to 4
see
circles,
that?
Yeah,
Why
that's
can't you-
that's the point.
Thank you for admitting. Thank you, Bev, for admitting that the surface area of a sphere is equal to 4 circles,
No,
which is
it's not.
two-dimensional.
That's not what
Therefore,
he's
the
saying.
surface of a
It's
sphere is also two-dimensional.
Are you listening?
Yeah, it's on him. He doesn't understand what he just said. He now admits
So,
that the surface of a sphere
is it one?
is two-dimensional.
Is it one circle or 4 circles?
Look at the derivation.
A circle's
No,
a
no,
two-dimensional shape. We all know that, right?
Yeah, so is the surface of a sphere. Thank you for admitting that. Since you now admit that the surface area of a sphere is equal to 4 circles, which is two-dimensional, therefore
equal to.
Equals. That means that it's the same as. That's what the equal sign means. One side's equal to the other.
The area is equal to.
Yeah,
4
thank you.
circles.
And that means that the area is r squared. Therefore, it is two-dimensional.
Yeah, a square.
Yeah, r squared.
Yeah,
That means
a square's a
two-dimensional.
two-dimensional shape too.
So is the surface of a sphere. So is the surface
Like
of
4
a cube.
circles. That's two-dimensional?
Yeah. Well, you admit that it. How about the surface area of a cube? That's equal to 6 squares, right?
Yeah.
That's 3D.
Yeah. So this one, they do a similar derivation. If you actually will look, I know you haven't
You do
watched
one
this
square
yet
and then you times
because
it
it
by
takes
6.
9 minutes.
Much
It
like you
takes
do
9
with a
minutes to watch,
sphere.
and you haven't had 9 minutes to watch it yet.
You not find it really weird that it's just 4 circles?
What we mean that seems that's totally fine. 4 circles.
Yeah.
You like 4
Two-dimensional
circles?
shape. I love it. Yeah.
Yes, that's the surface of the sphere.
Mm-hmm.
Yeah, and it's
circles.
derived. It's derived. If you actually watch the video, Bev, and shut your pie hole for
No,
Yeah,
don't sound cute.
I understand it's just 4 circles, and a circle is definitely a 2-dimensional shape.
Yeah,
and if
but-
you want,
Thank you for
equate,
admitting that the surface of a
if
sphere is equal
you
to
want
is a
to
two-dimensional
equate
object.
the
Thank you very
surface
much.
of a sphere to that circle and say that that's the same, it's 2D. This is what the surface of a sphere is, 2D, the same as the circle, but 4 of circles, right? You want to do that? That's fine.
Well, I mean, but
I'm
that's
fine with
but
that.
it. But
Thank you for admitting that the surface of a sphere is two-dimensional.
Yeah,
Thank you very much, Bev.
I get the picture of the 2-dimensional surface of a sphere, and whenever I
Okay,
look at
fine.
a circle,
Then what's your problem? How come? Thank
completely
you.
understand it.
Thank you.
Yeah.
Mark this down. Mark this date time down. Bev admits that a sphere is the surface of a sphere is two-dimensional. Thank you.
I'm not gonna run with that.
You're not.
No,
my
not
bad, you
with a
haven't-
sphere.
Bev just admitted it, and I thought you guys, he's your flirt daddy, so.
No.
Oh,
I say if I grab a billiard ball, at what point it's going to be 2D of the billiard ball? Just me looking at it.
Like talking about, come on,
Me-
we're talking
me-
about the surface.
Yeah. The
No.
surface area, right, is equal to 4 circles, equal to the radius of
Yeah,
that.
the surface of a sphere. Yeah.
No, the sphere, you find the radius value of that sphere, right? Then you draw a circle of that radius value. Then you can say that circle has an area of this. And then what I'll do is I'll get that circle and just go 4 of them is equal to the surface area of that ball.
Yeah.
Thank you for admitting that the surface of a sphere is two-dimensional.
No, that's
Well, if it-
not what we're saying.
But it
Yes,
has-
exactly what you're saying.
No, it's not.
If a circle is two-dimensional and the surface of a sphere is equal to 4 of them, then it's equal to 4 times the area of a two-dimensional object, so which means it is also a two-dimensional object. Thank you very much, Bev.
What? Sorry, the cue ball doesn't turn into a 2-dimensional object.
No,
The
but the
surface
surface
is a two-dimensional object. You just
Yeah,
admitted it.
I didn't say the surface.
Yes, you
was a
did. If
two-dimensional
it's equal to
object
4
at all.
circles, then it is
No.
equal to, because the surface is the
You're
area
getting
of
you
a
wrapped
circle
yourself up here.
two-dimensional.
Come on, NASA.
No,
you can
you're
do
wrapping
better than
yourself
this.
up, Bev. You have
I'm
just
not
admitted.
getting wrapped up
Yes,
at
you
all.
have. You've totally
The
wrapped yourself up.
ball-
You have now
the
admitted
ball
that the
being
surface
in
of a
reality
sphere.
is a
I'm
three-dimensional
not talking about
object.
the ball. I'm talking about.
Yeah.
Somebody muting him.
Yes, the ball is 3D, but we're talking about the surface. Surface is defined, in 2D. I mean, you said it
No,
yourself.
the
It's 4
ball-
circles.
No, I'll say it again, right? In reality, if you see a ball, you see the surface of it. Now, that surface is 3-dimensional. It's the only thing you
Nope,
see
2
of
dimensions.
the object, right? So you can tell the ball in reality is a 3-dimensional Euclidean shape because you are
Yeah, but
looking at the surface. Right now, if you want to do a calculation to find out what the area of that ball is, then you can, and you will end up with using the formula 4 pi r squared. Now, because that's the formula for the surface area of that sphere, it does not make that sphere into a 2-dimensional object at all. That does not ever
It does
happen.
too. You just measured it.
Always
You just measured it
stays
using.
as a 3-dimensional object.
I mean,
How
whether
come
it's
you mute me and not Bev? Who's muting me and why?
yeah, actually, yeah, who's doing that? Actually, that's kind of weird.
Right, go on then, Nasty. Now's your chance to rebut. Right, I've done. I don't need to say any more. I don't think.
Thank you, Bev, for admitting that the surface of a sphere is two-dimensional. If it's equal to 4 circles and circles are 2 dimensionals, the area of a surface is 2-dimensional, then the surface of a sphere is also 2-dimensional. Thank you for admitting that.
Man.
Okay. Yeah. Oh, here's the thing, right? Bev, right? Here's the thing. So you're arguing that it's 3D, right? And I think we all get that it's a 3D ball, right? But I mean, can you actually name anything in reality that is truly 2-dimensional? I mean, these are just at the end of the day. I mean,
there is nothing that's 2-dimensional in reality. So if you get a ball in reality, it's 3D.
Okay, yeah. So with that being said, right? When we're measuring the area of a circle, right? That's also not in reality, technically speaking. It's technically math, right? So I mean, at the end of the day, the surface of a sphere, in the maths is 2D. I mean, like there really isn't, a circle in reality. If you want to get technical, if you really want to get technical, all right.
Yeah.
It's like,
I can draw one. I mean, it's simple.
But at that, okay, but Bev would say that's technically 3D because technically the paper is technically 3D and the the graphite or whatever.
In taken for the area, you were taking a circle, right? If you're going to have 4 of those circles, right, which is what the formula gives you, 4 pi r squared, 4 circles, then those circles are classed as 2-dimensional shapes.
Thank you. That means the surface of a sphere is 2-dimensional, Bev. Thank you again. You continually prove this. Thank you very much.
It means one of them is a circle, the other one is a sphere. They're not
you said
the
that the
same.
surface. They are the same because you just measured them in 4. Yes, you've just measured them using 4 circles. You admit that a circle is the area of a circle is 2-dimensional. Therefore, since the area of a sphere is equal to 4 2-dimensional objects, it is now equal to. It's now a 2-dimensional object. Thank you very much, Bev.
Look, all right. If you take 4 circles and you were to wrap them around a sphere, all right. In this example, it would, assuming you were able to take every part of it and actually match it up and line it up, that those circles would wrap around the sphere perfectly. All right. Assuming once again there's no gaps and you were able to do a thing where they just kind of you could I don't know. This is stupid.
We see,
What
but
we're talking about is a concept,
the derivation,
not a reality.
The derivation does not require circles. That's all. If you look at the derivation, you'll see that it doesn't use circles actually.
Right. Well, once you work it out that you've got a circle, you can't wrap a 2-dimensional surface onto a 3-dimensional surface of a sphere because the surface of a sphere is a non-developable surface. That means it cannot be expressed on 2-dimensional plane. So that tells you that the formula that you use is purely conceptual because it being 2D doesn't go on.
Muting me? Who's muting me and why? Why am I being muted all the time? I'm taking my.
To stop you from saying shit while I'm talking. Right? I didn't mute you, but why did you come off mute to say why were you muted? Because you interrupted us as I was talking when you were saying that you've been muted.
I'm taking my turn nicely, actually. You're talking consistently, not listening, not telling. I'm telling you that, okay, so the area is equal to 4 pi r, but it does not involve circles, unfortunately for you. If you would actually watch the little video there, it's only 9 minutes. It shows you the derivation of the formula. But now you admit that the surface of a sphere is equal to 4 pi r squared, which is 2 dimensions. Thank you very much.
Well, you keep doing this little bow as though it means something.
It does mean something. It means that the surface of a sphere is 2-dimensional. It means
You're on your own. Nobody's sticking up for you. Not even the guy that's trying to help you.
No, it's not.
Why am I being muted in the middle of a sentence when I'm not interrupting anybody? And who's doing that? Who else is the mod in here?
Yeah, who's doing that? 'Cause I mean, yeah, you guys are actually kind of being like rude, muting him like mid-sentence. That's kind of
Oh,
It's
SC
kind of-
Montreal is a mod. Need I say more?
Oh, well.
So you're talking about a
He's
concept,
muted
right?
again for talking about the mods.
What is that a rule?
He's talking about a concept and not reality, right? Is that what he's pointed out to us?
Yeah, he's talking about 2D, and he's already said that 2D doesn't exist in reality, and yet he wants to have that as the surface of his sphere, just so he can end up living on it, right? Because he wants to lives on a 2D, which he's already said is flat. Really, at heart, what he's trying to get at here is he wants to be a flat earther. He wants to live on a two-dimensional surface. I don't blame him. I mean, going up and down hills must be awfully hard work. But yeah, he wants the surface of his sphere to be 2D, and he wants to live on that surface.
You see, the surface of a sphere is two-dimensional. You've admitted it. So now, what's your next big?
Just explain to us what 2D is.
You don't even know what two-dimensional is?
Yeah, it's a plane, isn't it?
A plane is a two-dimensional object, but it's not the only two-dimensional
plane
thing.
isn't a two-dimensional object. There's no such thing as a two-dimensional object.
Fine, two-dimensional. What do you want to call it?
exist.
Two-dimensional. What do you want to call it? Two-dimensional manifold, or whatever the official term is.
Okay.
Object works quite well for me. Thank you.
Okay, so that is a plane surface.
No, a
would be
plane is
classed as
two-dimensional.
Is a flat surface a 2D surface?
A plane is a two-dimensional object. It is not the only two-dimensional.
Okay, like a square and a triangle and a circle.
A plane is a two-dimensional
polygon.
object.
Polygons are 2D.
Yeah, those are all two-dimensional. I agree with you. However, they're not the only.
2D.
The surface of a sphere is 2D, and you just admitted it because it's equal to 4 pi r squared.
Circles.
The surface
Okay.
area of a sphere.
Yeah, we go round and round.
Surface area of a cube
just
is
want
equal to 6.
You want to live on a 2D surface, right?
You just admitted it, Bev. So, thank you very much.
Yeah, I've admitted that you want to live on a.
No,
2D
you've admitted.
surface.
You've admitted that the surface of a sphere is a two-dimensional object. Thank you.
There's no such thing as a two-dimensional object.
What do you want to call it? Two-dimensional manifold?
There is no such thing. Stop lying, please. I know your record track
Okay, what do you want to call
going
it?
on loop, but please try not to misrepresent what I say.
Fine. What do you want? A two-dimensional manifold,
plane,
or whatever you want to call it?
It's just a 2D is a plane surface. Everybody knows
Not
what it is.
A plane is a two-dimensional bev. Let's call them bevs.
Everybody knows what
it's not
a 2D
the only
is,
two-dimensional
right?
bev.
Just you
Bev.
particularly want to have a sphere as that too.
Well, but he's not. I mean, he's right though in the sense that he doesn't have to be flat for it to be 2D though. I mean,
It does.
Well,
I'm gonna go get his picture.
Okay, so
and he's gonna
length
call his
times
own
breadth.
picture out.
In
it does not.
Euclidean geometry,
Yes.
a plane surface, superficies, length times breadth.
Yes, and
You
the
know
fact that-
what plane geometry is.
Yes, but the fact that you said the fact that you said Euclidean geometry, I mean, sort of infers that there's other geometries, and you're always saying that they don't exactly exist, but you know.
Well, I'm just saying Euclidean geometry because I know
So why don't
the
you say
axioms,
geometry
the
then?
definitions and the propositions, the postulates. I know all of that for Euclidean
Well,
geometry.
now that
I was hoping
now
that
that you
if
admit-
you were going to state another geometry, you might be able to give us something.
Yeah, we've been
That's
saying.
why I state Euclidean, because the proofs are all within Euclidean geometry. That's why I state it. Do you want to say that you're using an other geometry?
Actually, no. This one we're using just.
Yeah, I can
But
screenshot
proving-
that now. Thank you, bro.
Well, anyway, yeah, two-dimensional doesn't necessarily have to be flat. Yeah, and Euclidean, I guess, is flat, but it doesn't have to be flat. Like 2 dimensions, at least in one of the definitions I have is saying it's a.
You speak about this.
What?
Peyton, that's a shill. On recording right now. You know this is trash, right?
Yeah, I've admitted it. My error was shown on that chart. Thank you.
All right, just making sure.
I have not brought it up since then. Do you need to? I mean, how much more do you need? And I've said this on recordings before. This is how science works. People find mistakes and show you things. and
That's
everyone knows.
geometry. It's not science.
Yeah.
Actually, this one was an error in reading the charts, and someone pointed out that there are 4 fixes instead of 3.
Yeah, geometry is not a triangle. A triangle
Okay.
doesn't have 4
Anyway,
sides.
but getting back to the surface of a sphere, since you have admitted that it's a 2-dimensional object, I think I have.
Please
won
stop
this one
it.
today.
You've just stated it again. You're on repeat loop.
No, so are you.
There
but
is
you
no
are
such thing as a 2-dimensional object. Me, have never agreed to anything being a 2-dimensional object. They do not exist. Please
So,
don't
but you say
misrepresent me.
You say that a circle is 2-dimensional, though. So that
yes,
exists,
a
right?
circle is a 2-dimensional shape. Yeah.
And so is the surface of a sphere. Thank you.
Beth, let me ask him a question. So if you take that circle of the paper and you put your finger through it, does it make it 3D? Just because I can put my finger through it?
No, you're just ripping the paper.
No, wait. I want him to answer.
Oh.
Yeah, that was a good answer. I'll take that one.
Yeah.
Okay, so I mean, okay, real fast.
I know none of you guys have seen it yet. I'm going to post it once again. You guys should actually really watch this video. It's only like 9 minutes, and you actually might
Just
need to learn
watch the
something.
video. Answer the question. We made 4 circles. We just say, if I put my
No, that's
finger
not
through
how
it.
it works, though. That's not how it works,
Oh.
though. Sorry. It's equal to that, but that's not how it works. You look how they derive the formula.
4 circles.
If you look at how they derive the formula, it has nothing to do with 4 circles. It's equal to 4 circles.
Okay.
All right.
The important part is the r squared part. That's the important part, which means that it is a 2-dimensional manifold.
Okay, so that's what I'm saying. Listen. So if it's a 2-dimensional, you can't get 2D, 3D sphere itself. So it makes it 2D, right?
No, the sphere is the surface. It's not the ball. There's another problem you guys have, but
Okay.
you got to be mathematically correct.
Listen to what I'm saying. If the surface is 2D, if I put my finger through it, would it make it 3D or still 2D?
Well, the surface is still 2D.
But I put my finger through it. Is nothing on the other side?
I don't care.
You don't like it?
You put your finger through it. So what?
Can we? Okay, listen.
Wait.
He's
Oh
trying
my
to
God.
stop. He's trying to stop.
Yeah.
Hey NASA.
Listen, guys.
NASA's going off.
In a drawing, in a piece of paper, you cannot have a 3D object. You may have representations, visualizations, but you cannot have a 3D object.
If
you
saying
can
that
use
It's
you can
all
trick
3D
the eye
in reality.
in reality only. You can trick the eye by using different shades of
Silent
shadows.
Silent.
to
Watch
trick
my
the
video,
eye, but
please. Watch my video.
Right now,
penis.
you posted a
It
video.
derives
What
from
video?
Penis. Would there be a difference in would there be a difference on a flat plane and a sphere plane as far as distance and elevation is concerned?
Data.
What would you have different on a surface that would be sloping or dropping? What would be the difference between a plane surface and a curved surface? What would be the difference?
Bro.
If you can have a 2-dimensional surface with width and length.
Yeah.
When you have width and length, width and length, where does the curve apply and on the surface of the Earth? Where would the drop apply?
No, we're not talking about the surface of the Earth. Actually, we're talking about the sphere.
Really?
We're
We're talking about a surface.
talking about a fictional surface, right? A
Well
two-dimensional surface,
Which
that
is
doesn't
measured in
exist.
R squared units, which means
Only,
it's two-dimensional.
only a
And Bev
concept.
has already admitted that it's two-dimensional. I don't know
No,
why the
we're
rest
not.
of you guys
We're
don't
not.
fall in line.
No, I'm not following you. I'm not following him. I'm asking you a question.
Well, have you watched the derivation of
No,
the
no,
formula
no.
yet?
Watching it is still 2D object in your. You're just tricking to your eye, right? Think that it's a 3D thing. It's not.
You haven't watched the formula then? No.
Oh
Okay.
my
Or
god.
I don't care about
so
the
have
formula.
you watched it and not
What's so
understand
funny
it?
about that formula?
Can you run me? Can you run me through the formula? I haven't seen the video, but can you run
Hey.
me through it? Can you just go
no,
step
you
by step
watch
with
the
me
No, no,
there?
video.
no.
That one's
You
better.
go watch the
Come on,
video.
This,
Let me
I
ask.
no, no, I don't.
Redman guy,
I
this
don't.
Redman guy thinks it's all trash, right? So who gives a fuck what this guy thinks?
No, no, no.
Everything's trash
You
for
go
this guy,
ahead and
right?
watch the video, bro. You just came in. Come on.
No, I'm not interested in watching no video if you can't explain it.
I can explain it, but the video does a better job. Watch it.
Explain it real quick, bro.
See?
Just explain it real quick.
Have you watched the video?
See?
If you can't explain
That's why I
it,
told you.
there's no point. There's no point in me watching it.
Oh, there's no point in you watching the video. Right, gotcha. Because you
If
don't wanna
you
learn.
can't quickly explain it, there's no point, no. Because if you're telling me that your surface of your Earth is a two-dimensional surface, that means it's a planar surface.
No.
Because there's only width and length, right?
Well,
So if there's only width and length,
no.
there's no curvature, right?
Help
No.
him out
So
with
which
the
point-
views on
at
his
which point-
video. Come on.
No.
At
You
which
guys
point-
need to
pay
watch
width
this.
and length-
That's
attention.
too- Hold
No,
on,
to-
you guys
at
need
this
to
point,
watch
does
the
width and
video,
length
guys.
turn into
It's so
curve?
stupid. Just watch it.
Yeah, but that's
Watch
why I asked
the
him
video
to. That's
so
why
that
I
you
asked
can
him.
realize
That's why I
how
asked
stupid
him to
Penis is.
explain.
Sorry.
I already know who I'm dealing with when it comes to penis. So when I deal with this guy, I already know what to expect. That's why I just
Yeah,
quickly asked him.
Penis.
to-
Yeah, because
If
you,
this video,
you haven't watched the video, have
take
you?
it as
Yeah,
a
you want to know what he does? He
a
inscribes.
learning instrument, no
All right,
wonder why
let's,
you're
let's
so
not
messed up.
turn it personal.
He
Okay,
inscribes.
hey,
he
NASA,
inscribes.
please.
Well, I
Data,
don't.
you started
I don't
it.
take it personal.
Please not do this.
Data started this, not me. How come he doesn't get muted?
Well, let's
Oh
don't
my
take
gosh.
it.
You're not
I just
muted
want a
either.
simple
He is.
question.
Bev is asking to not go into personal. Yeah.
So what this
I
does is
refrain-
he
I refrain
listen to me,
myself to
really
insult
carefully.
you.
He inscribes a polygon, rotates the polygon, and then takes the number of sides to infinity. That's what he does.
Yeah,
Polygon.
that's
Yeah, lovely.
It's very simple, very elegant.
yeah.
Definitely
All right.
wasn't the question I was gonna ask.
I always love the
you're so
infinity
confused.
arguments. They're brilliant.
Well, no, if
I
you
love it.
understand math is a language. I understand you don't speak, it, which is why I don't speak math to you
reality
guys,
is
because you guys are
Penasa.
math impaired. You guys are math
Yeah,
impaired.
timing.
Hey. You already missed the whole flight chart thing. You
Well, I
already
missed the
messed
flight
that up.
chart thing. Yeah, okay, I made a mistake. So,
Yeah.
as opposed, I see.
So
The thing is, I admit when I make
that
mistakes.
shows.
You guys
That
can't.
shows.
Yeah, it shows that I'm
That
a human.
shows.
I'm sorry.
Did you clip it
You don't
out,
fly no
NASA, so you
planes.
can remember it?
I've never used it again.
Did
But
Geo
it shows that I'm
Geo
human. I
might
make
have got
mistakes, and
saved
that's
that.
it.
He
Also
should have done.
it also
It was
shows sort of like peer
podcast.
review when people
Would have been a
notice
classic
mistakes in your
moment.
work and point it out. In the meantime, you guys can't
I
admit
love it too.
anything. You guys can't admit when you're
Oh,
wrong.
I
and
can
you're
admit.
wrong again.
I can admit when I'm wrong.
Yeah,
Did
but
you
you're
clip it
wrong now
out,
and you're not
NASA?
admitting
Did
it.
you get us a timestamp for when it was?
So he's gonna
No,
do
no,
maths
forget
on
it.
an infinity number, Penasa?
Yeah, that's called calculus. You should try it.
Straight lines.
He's
Start
gonna
off with straight
calculate
lines
to
and make
the
an
infinity. Yeah?
infinite number of them.
Calculus.
He's gonna calculate to the infinity.
Yeah.
I
Yeah,
love that shit.
calculus. It's called.
You
That's
guys gotta love that.
Yeah, calculus. Did you ever study that?
That's how you make
Yeah.
a circle, isn't it? Infinite straight lines.
Well, you take the number of polygons and take the number of surfaces to infinity. That's correct.
Yeah.
Yeah, I told you. So in the meantime, watch the video. They do a better job there.
Yeah.
Better than you.
Well, yeah, better than me. Yeah.
Okay.
Plus, he's
So
got pretty nice animations. You guys like visual
back to what
learners
we're
like
saying.
you.
Back to what I was saying. So if you put your finger through that circle,
Doesn't matter.
is it 3D
Doesn't
or
matter.
2D?
It's never a 3D until you have it in your head.
No, we're
Then
just talking
it's
about the measurements. The measurements are 2D. I mean, it takes up 3D space, but come on. I mean, like, we just move like, come on, like.
I mean, you can go up to the other room if you want to.
Measurement, isn't there? That's R. So how do you measure R for your sphere? How's that happen? How's that occur?
Well, you use the formula, babe. That's what he's been trying to say. You multiply it by infinity.
Yeah, but I say, how do you
Voila.
find R though, right? How do you do that? Anyone?
I
Any
mean, don't
idea?
ask me. I
Well,
don't...
well, it depends. I mean, if we have an actual physical
No,
ball
we're asking
in our
Peyton. That's
hand.
the show.
Okay,
Yeah.
never mind.
We're asking him, not you. Him.
Yeah, but
Natsu would go with what
that's
he
right.
says.
If you have a physical sphere, yeah.
Yeah, you need to get a physical sphere first. That's a good start. Yes. Where do we go from there? We're after
That's
R.
a good start. Exactly. So,
Anyone?
where do we get it? Oh, you guys are talking about the place we're standing on. Then we're gonna
No. We just
pretend
start
that
off
it's a
with.
sphere.
We just work out how to get a sphere, right? How do we get the R measurement for any sphere for this calculation that we're doing, NASA? You know, like to get your 2-dimensional surface value. How do we get the R again?
Well, look, babe. You grab like a ball of a clay, and then you shape it into a cone. Then you make it to infinity lines.
Yeah, make
Then
fun of
you
it.
measure those lines.
I know
Then
your math is
No,
hard, I
wait.
understand.
You
That's
didn't answer the question there, Pate.
Oh, you know how to measure the radius of a sphere.
Come on, then.
No, go ahead.
We've stopped everyone from talking. Here's you got the floor.
You
Paige.
guys know how to measure a radius of a sphere.
Go on.
Damn.
Let us know.
You know how to measure a radius of a sphere, Bev. If you're
No,
that
the
math impaired,
question is,
perhaps you
how
should go
would
back.
you?
Tell me how you do that. I'd like to know how you do that. Can you just
Oh,
tell
you
me
know
how
how
to
to do
do
that. No, I can't. If you
No,
don't know
no,
how to
I
measure
want
the radius
you
of a
to
sphere.
tell me. Just
If you don't know,
please.
if you don't know how to measure radius of a sphere, please go back to 3rd grade, I think, when they teach it.
I love it. These insults.
It's not an insult.
I think you first gotta turn it into a 2D object. Isn't it, Beb?
I guess it's just width and length,
That's
right?
how I would do it.
Width,
I'm waiting on
width and
his
length
method.
is your sphere, right?
No, I'm waiting on his method.
Oh, okay.
Yeah, you haven't watched the video, so
I'll be fine.
I don't know why I come here argumentative.
Oh, okay.
Yeah, we've got.
That's
how you derive.
I come here, I ask for the math. I ask for the math. He doesn't give me the math.
I gave you the math. You haven't watched it yet. Have you watched the video yet? No.
Yeah,
you
I
haven't.
asked you for a simple breakdown before I watched your
told you a
video. You
simple
couldn't
breakdown.
even do that.
I told you the
couldn't
simple
even do
breakdown.
that.
Yes, I did.
Yeah,
It is a
you
simple
couldn't.
Don't save
gave
him.
you the simple
Data.
breakdown.
Don't save him. Come on, Paige. How do we get the R value so we can
if you
use
don't
your
know
little
how to
formula that you've given us the video for? How do
If
we
you don't know how to
the
get an R
R?
value, if you don't know how to get an R value of a sphere, then you should.
Wait a second. You're saying that you know how to get an
R.
R value? You know how to get an R value, right, Venus? So if you were to teach kids in school, how would you teach them to get the R value? Since you're telling me that I have to go back to school to learn, what would I learn in school? What would I
don't
know.
know. What would you learn?
Well, I'm
Come on,
asking
Data,
you. You're
just
the one.
give him
You're the one
chance
who's
to-
saying.
Just give him chance to tell us. Come
You
on,
should
Paige.
know. You should know.
You
You
can
don't
tell
know
us, correct?
If you don't, you should know.
Come on.
If you don't know,
we
Two
you
master's
tell me.
degree.
Please tell us.
2 master's degree. He should be able to tell us in the next 1 minute. He should be able to tell us in 1 minute
If you don't
or
know,
less
so
how to
but
measure R.
we have now
1
confirmed
minute.
that
Go. You're being timed.
the data
Go. You're being
and
timed. 1 minute.
and
Go. You're being timed. Go. 1 minute. Go.
Data and Bev don't
No,
know how
not
to
yet.
measure the radius of a sphere. Is that
1 minute.
Is that true? Is that true,
50
FED?
seconds.
How
You
do
do not know how to
NASA
measure
do
the radius
it?
of a sphere?
How did NASA teach you to
don't
work
know how to
out
measure
the
the radius of a
R
sphere?
value
I have
for
an
this
honest question,
equation,
Beb.
please?
You don't know how
I
to
have an
measure the
honest
radius of a
question.
sphere.
Hey, NASA, why instead of arguing, don't just
30
don't give,
seconds.
You
what
don't know how
they're
to
asking?
measure the radius of a sphere, FED?
Yeah,
Really?
but why do you go around and around instead of just giving the answer?
Because if he
don't
doesn't
understand.
know, then you should go back to
Well,
3rd
yeah,
grade.
he
I'm not here
doesn't
to
know.
teach
That's
him.
why he is asking you.
Oh, I
Yes.
know. I know. He doesn't. Apparently, FED doesn't.
Yeah, that's why he's asking you.
10
Well,
seconds.
he should know then. I mean,
You
if I
keep
don't.
bragging that you know. We keep telling you we don't know.
Well,
Please
then I shouldn't be here
inform
arguing
us.
with you, because if you don't
Hey,
even know.
Penis, guess what? You couldn't even tell us in a minute.
That wasn't a minute. That was like
Couldn't
40.
even-
That was like at best 40 seconds. That was not a minute.
You're gonna be
Well, I
on
wasn't
pain
really.
as a
I wasn't
shield,
using the
buddy.
clock there. Pretty close.
How about this? How about this? I have an
It's a
idea.
really-
How about the hang on? How about this? FED and Bev. I've heard Paige say 4 times now. Watch the video. instead of brutally asking him to explain it to you, which he obviously doesn't want to do, why not just watch the video?
Yeah, and
John,
why,
I already
actually,
why
watched
now
have
that
you
you're here,
assumed that we haven't?
please tell us. Please tell us what the video is. Could you break down Penis's video for us and concisely tell us exactly what's
First,
going on?
his name is paid, so you don't have to be a dick. Or you can just watch the video that will explain it instead of him having to explain it and you tell him not.
Won't answer the question thereafter. The question is, how did you come up with the R value, the radius value?
Well, I've heard him say 4 times now, if you want to know, watch the video. Bev has said you guys don't know, and that's just what Bev said. So why not just watch the video, then come back and tell Paid how he's wrong?
That video will not tell us how Paid NASA Shill came up with the R value.
Well, if he's saying that the video explains it, then maybe that's how he came up with it, and he's trying to show you how he came up with it.
First of all, that video is not talking about a sphere. It's talking about a shape that is made of infinity of I don't know the name of the shape in English.
The title literally says
polygons.
"Understanding the surface
Whoa,
area
did you watch?
of a
I
sphere
watched the
formula."
video. Did you watch it?
Okay. No, I haven't. I'm just
All right,
jumping
then
into
you
that.
should go watch
I
it.
hear. No,
You're
I'm
fighting
not
already
claiming.
with us.
Wait.
Should go and
Silent.
watch it
Silent.
right now.
Have I came in and said,
Yeah,
"Are you
you
Don't waste
for
any
it?"
more time telling us what we
Don't
should
waste
do
any more time,
if you've
that's right.
never done it. Go,
Okay.
please
Okay.
now.
How about you guys say to Paid, explain it to us 7 more times, and him
What
say,
they've been
watch the video 7 more
Holy
times, because it really sounds like shitty conversation.
We've
You
been
know what? It
asking
was
video.
pretty fun. It was pretty fun listening to him squirm, and now you're squirming. So keep going, bud.
What am I squirming about, FED? Or are you just trying to push my buttons?
Well, why are
Because if
you
that's what
such
you're
a
doing,
princess
I am
mode
more
shit?
than
Why are you
willing
a
to go
princess?
get
Listen,
triggered and go
it's
off
more
on your
than
stupid ass
reasonable.
right now.
It's
All right?
more
Is
than
that what you want to
reasonable
fucking do?
ask him.
Otherwise, don't
It's
even fucking have a
it's more than reasonable to ask him for a quick breakdown before I watch the video. What can I expect? It's very reasonable to ask him for the formulations. It's reasonable to ask in 1 minute or less, can you tell us how you got R? These are very reasonable questions. Now, the reason, Sean, you should go watch the video and come back and stop acting like a princess.
Stop being personal, please. I muted Sean because of what he said, but can't be personal towards him. Not expect him to explode like that.
He comes in with the same, he comes in with the same angle.
You don't know
every
explanation
time.
needed. Just take it at heat.
So wait, I get muted because he's
You were muted so I could mod, and as soon as I take you off mute, you complain about me modding.
Yep.
Strange.
That's Sean G right there. That's what I'm talking about. That's what
Yeah,
he
but
does.
you gotta
That's his
stop
motive.
talking about.
That's his,
Stop talking about.
Yeah,
Stop talking about
that's his
him.
MO.
Stop talking about Sean.
Can I just add, because I think I'm going to have to go to bed soon. This R value, right, needs exploring because it's pretty bad when somebody that's actually paid by NASA to be here, right, can't explain where he personally himself has been taught by NASA to work out this R value. It appears that NASA haven't even informed him how to get the R value in the first place. They might have taught him how to watch a video on YouTube about something with a formula on it, but it hasn't taught him where to get this R from. And I bet he's not on his own because nobody else seemed to pipe up and say, hey, I know.
I mean, I kind of did. I kind of did actually, but
It's resistance, Bev. The R is
know.
for resistance. Just like C is for cookie, like for the Cookie Monster, the R is for resistance.
You and the resistance, buddy. You and the resistance. You should change your name to Iconoclast Resistance. That's what you should change your name.
I'm resistant to that.
The R is for
Resistance.
Flatter.
Well, what's the R stand for? And what's gravity? What's mass? Right? Find the R value. What is mass itself? It's resistance. I mean, it has to be. What does a glober think it is? I mean, me as a, I mean, as a flat earther, I think it's resistance. That's all I could figure it to be.
Well, the R value is the measurement between the center of a sphere and the edge. Is that what you call it?
Oh, yeah, but when you're talking about the Earth and we haven't been to the center, yeah, it can't be that.
Well, I mean, you can look at the horizon and
now
measure
if we
that way.
get there, Silent, if we go, if they like say, here's the video where we went to the center and we've calculated from that out, then yeah, I'm with them. Then I'd say okay. But until then, no, I couldn't just believe it.
Well, do you have a video of air, and yet you breathe it, huh?
Do I have what?
Just mock. I'm just messing with you, D-Mock.
Oh, I just didn't hear you. Sorry.
No, I'm giving the same freaking answer that they give every time you ask stuff like this.
Did you ask if I had a margin of error?
Have you been in China? Ooh.
Oh, have I been in China?
Yeah, you know, you ask, have you been in the center of the earth? Then how do you know is there? Well, have you been in China? Then how do you know is there?
Well, no, but I mean, not being funny or no clown stuff. I mean, literally, someone has to have been to that location somehow to give a calculation from that pinpoint area. I mean, something has to have been there, right? I mean, literally, like for real.
No, I think they measure the circumference, and then they derive the R value from that, right?
With shadows.
No, the way I see it, you can just deduce the sun path, and from the sun path, deduce
Oh
the
no, the sun
circumference.
path is based on a perspective. That's what it does.
No, I'm actually
it's not-
talking about the physical subsolar point of the sun as it moves across Earth. So its
No,
zenith
see-
position on Earth. So that sun path, right, can be apparently like you can get a circumference from it, even though it's a supposition of a 360-degree circle. Let me rephrase that.
Would
It's
it
a
matter?
presupposition of a 360
Would it
degree
matter if
circle.
you're on a mountaintop or in a deep valley?
It would matter if you're higher above. I think it would matter as far as how you perceive the sunset. Yeah, but as far as the angle of how it rises, no.
Okay.
It's pretty good data. Although I would say you get a circumference regardless. The question is whether the circumference is a circumference of a sphere or just the circumference of the path that the sun took that day.
How would you get the
Can I
circumference?
ask? Can I ask?
So what you would do, what you do is what I've already led to as far as timing timing the velocity of the sun between two positions at their sunrise between two locations 1,000 miles apart, or whatever point of latitude that you're on, timing the sunrise between two locations to get I guess apparent velocity and then apparent return. So each latitude would have a sunrise and a sunset position, right?
Whoa! You already have latitude. Hold on.
Yeah, go with
You
that.
already have
Sounds
latitudes
great.
at this point.
No.
Holy shit! I thought we were figuring out first the circumference. You have latitudes already.
Here's the best part about the latitude is if you look at any sundial, it is a right angle triangle.
These people.
You haven't
all
looked past.
sundials. All sundials are right angle triangles, right?
But listen to this
So if
though.
you look,
All wells are circular in nature, like they were rounded. So if you saw any shadow across the wall of a well, you're automatically going to see a rounded shadow, no matter what. So that doesn't have anything to do with the source of light or anything. You're going to see a round. If there's a square light bulb outside 10 foot away, you're going to see a rounded angle going into that well, regardless. Now,
You're right about that, Bob.
the light source. Hold on. The well can also be off balance. Now you're going to get a messed up measurement also. Also, number 3, the sunlight itself or the light source, the point from the source of light, like a light bulb or a flashlight goes out from the source and gets wider, you know what I mean? And makes that idea of a wider path like a sphere itself, right? On the outside edge of itself. Like, so the outside edge of a light would be like a circle, you know what I mean? From the center out, you know? So
all I know is
Right
if you're
about the
looking at if you're looking at the possibilities of R, they can be deduced from the position of the sun and its movement.
well, the light
Where
itself.
that's where all
The light.
well, that's where all the derived calculations are coming from, is the sun's movement, and then the apparent position of the sun's planets around it, or whatever you want to call them, stars
Well,
around it. So everything
you're
comes.
still losing-
Everything
you're-
comes.
You're leaving out what the sun
Everything-
is, buddy. It's a circle point of
Yeah.
light. It's a ball of light. So that way it puts
Sure,
off light.
I don't know what it is. I know that it puts off light and that it has the parent circuit.
Right, and you know the
And
way it
from that
puts off the
apparent-
light, right? From the center point outward. So it makes a ball-looking thing, like a circle around itself, like an aura or a rainbow or a corona.
Dave's making a good
If
point,
that's the
though.
case, then why can't we just use
You
the
understand
moon?
what I'm saying? The shape of the light itself is going to
Yeah,
give
of course.
you
But
a
I'm saying
reading
the
or an
point
angle.
Data's making.
So it doesn't. Hold on a second. So
So
it
why
doesn't
you're
have to do with
interrupting
the
him?
So it doesn't have to do with the distance away or anything like that. It has to do with the actual shape.
10 minutes.
I'm interrupting him. I'm trying to finish my fucking statement that he was interrupting. But regardless, yeah, Data is he's making a good point that the light itself and the nature of it and what it is and where it came from doesn't matter when what's being discussed is the path that the some position on the ground is taking that is in reference to that light.
Totally matters.
So for instance, like the subsolar point, which is just a spot on the ground that's right below that, but right below that point. So there's only one point where that happens, and as long as it's unique and
What's your guesstimation, Coach?
it's always changing. Let's use that.
I don't believe anything's right above you or you're right below anything on subsolar anything. I think
Well,
you
actually,
may
that goes
not
back to what
say
you
a lot of
said.
words, and you stand there and you look at the sun and you say what you think
you
it
said
is.
about the well?
They a bunch of shit.
Yeah, no, but what you said about the well is the perfect example of how you know that it's at your zenith. Because if you had a well that you could see, the bottom of the well, the light from the sun from it, and it was like a narrow shaft. The only way that would be possible is if the light was directly aligned with
what degree is that well tilted? How do you know the well's not tilted itself? The well itself, just the brick well or the dirt well, the hole in the ground. How do you know it's not tilted? It's not straight up and down. How do you know that?
Because when they drill wells, typically they
No,
go
'cause you
straight
just
down.
face-
No. I can tell you exactly how they do it. In Denmark, they're not slanted. They precision do it. It's not just it could be
Where
sideways.
would you
Could
go
be
to a
straight.
well in somebody's backyard and measure this light? I'd love to see that right now live.
Of course. But right now, I know for sure it's dark where he is, so I doubt that's going to happen.
Well, I know all these stories are funny, but I'm saying, where can you go at the well on the hill somewhere right now live where you've never been before? Just go to a well and then precisionally do the dog shit you're talking about and say it doesn't matter whether the well is
Okay.
off center or not.
You saying you want us to go do it right now live and it's dark outside isn't a bullshit story either?
No, whenever you can, buddy. Whenever you go find a
said
well
now.
in somebody's backyard and
You
you're
said
like,
right
hey, you
now.
got a well? Cool. I'm going to go there and do it.
Oh, I can show you. I can tell you exactly how to do so. It's actually very simple. Get a stick,
It's real
get a
simple to
pump
look
up,
at
and
shadow
lower it down
and
to the bottom. There you go.
From a rounded source. Okay, cool. You're going to teach me a lot.
You don't need
Your
to
toilet
do
paper.
this test to mock
So
because
if I use a
wells.
toilet paper roll, couldn't I get the same answer from my house?
To mock when you have a well, you have to fucking drop a bucket on a rope down there, basically like a plumb bob. It's going straight down. It's
I know
obvious
what a
that
well is.
wells are vertical. I know, so you don't have to test whether it's slanted or vertical. They're
Listen,
always
a
vertical.
rope and a bucket aren't going to tell you your well's vertical, stupid. What
Yes,
are
it
you
is.
talking about?
Yes,
That
it
was
is.
dumb. That
Yes,
was
it is.
dumb.
Because when you lower that bucket, if
Listen,
it's
that was the
slanted,
dumbest shit I've ever heard.
okay,
I can tilt my 2 liter
yeah,
right
you
now.
can
I can
stop
tilt
now.
my 2
Okay,
liter
you
and put a
can
little
stop
lid in it,
now.
a bucket, drop
You
it down
can
inside of
stop
it. That's the way you
now.
explain.
When you can easily test if it's crooked or slanted, whatever you want to call it, by dropping the bucket down. When you drop the bucket down, if it is slanted, the bucket will end up against the wall when it gets to the bottom. If it's straight down, it will stay in the middle. Pretty simple.
I don't think so, buddy.
Okay, you don't think so, but that's exactly how it works. Sorry.
I don't think so.
Okay, well, then it doesn't need to be discussed with you because you don't understand reality of how it would work.
How big is your well?
What happened?
It doesn't matter. As long as it's bigger than the bucket, the bucket's going to go down there.
Oh.
What happened?
He's arguing that you can't tell if a well is slanted
Well,
or straight.
because they said it doesn't matter if the well's tilted or not. They could care less. They're going to just
Who
get
said
their
that?
reading willy
Who
nilly.
said
They
that?
don't care.
Who said
Right?
that?
They never
No,
said that
no,
they
no, no,
made
no.
sure the well
You're
was
lying. You're
straight
lying now.
to
You're just
start
lying.
with.
You're lying.
Another thing they failed to do when
You're
they
full of
also
shit right now,
ignored
Denmark.
was the shape or the
He's
way the
lying.
sun hits
That's
an
not what
object.
happened.
Right? So when you have a flat or rounded object, the way a light's going to hit that, right? Just compare it. You got a rounded object and let the sun hit it, or put a shadow on it, or if you got a flat object and put a shadow against it, and then
Wait,
which type of shadow? The shadow itself from the light source. So you have a candle, you have a rounded light source, you can have a big, you know what I mean? You can do different things.
Can you shoot light down a well?
Yes.
Different. The light itself goes out in a ray from the center point, focal point, and spreads. How in the fuck is that going to give you and help you with distance when it's going to do nothing but spread from the focal point out and give you a bigger shadow?
You don't even understand how it works, let alone to sit there and say
No,
it doesn't
you
work
don't
that
understand
way.
that it's
Okay,
dog shit
yeah.
and it doesn't do anything, but
Yeah.
you let you make stuff up.
Okay, so I just
Listen,
explained to you
you
how
get the
you can
tape
tell.
measure.
Hey,
Listen,
Rukia, he's got to
D-Monk is
stop talking
correct,
at some
though.
point.
D-Monk is correct. You
Okay, so
guys don't
you're
understand
saying,
that. Your
okay,
misunderstanding
silent.
of
Okay,
this
well,
may
silent.
lead
So
you
you can't
guys
tell.
to make stuff up. That's the problem.
How far can you shoot the light down a
How
well?
exactly is it that I'm getting muted and Denmark was one running on, and then when I started, silent, you started. Why am I getting muted?
Dude, come on, man. I listened to you
I
complain
wasn't
like that at
talking
least
to
2 or
the
3
FED.
times.
Wasn't talking
I know,
to
but
FED.
dude, you
You
seriously
don't
complain
you
like
don't
that
even have
all
to
the
say
time.
anything. You don't have
Dude,
to.
you're obviously muted for a reason. Just please stop complaining about it when you do come back. Just
Okay,
move on.
well
If they're
then
talking.
let me finish my what he said and what I said versus the well, which was what I
I
was
know,
trying
but
to do
quit
before he
talking
went.
about being muted.
Then you don't need to talk
Please.
either. Stop talking so I
No,
can
just
not
quit.
talk about it.
Or
Okay,
just,
thank
yeah, but
you.
just please stop.
So when you're sitting there talking about a well and whether or not it's straight or tilted, and I explained to you how you can verify if it's straight or not, you said that it can't be done that way. So don't sit here and make it seem like we said it doesn't matter. It does matter, and you
Have
can
you
tell if
done
it
it?
is or
Have
not.
you done it though?
Yes, yes. There's many times I've been on many jobs where we've graded, surveyed to drill a well, and when you drill a well, first you're starting from a point and you're drilling straight down. You're not drilling at an angle. You may do it to find a well, but when you're building that well and you're building the structure of it, the walls and everything, it is constantly checked as you're building up, and it's checked at the very end of it to be straight. And one way to verify that is to drop the bucket down there. If it's tilted, if the whole shaft is tilted, then it will end up near the wall. If it's not, it will drop to the middle. It's very simple. You can't say that doesn't. It's not how it works, or it can't be done, because that's exactly how it works, and it is done.
I want to see you tie your knot from the bucket.
So back to the circumference.
I mean, that works. But anyway, one more question. So, since this is all like the most accurate way and the best way that anyone in the world can ever just see what the radius value of the Earth is from a bucket and a shadow, is there any way that I could trick you with a shadow or a source of light in a well or a different, you know what I mean? Could I trick you with a well and a source of light and make you think that's a different distance?
Of course. All you have to do is put the sun in a closer place and you have the same
How would you do
effect.
that? But why would the sun's not going to be in a
Well,
different
you
place?
gotta
It's gonna be in
assume
the
it,
same place.
right? That's where the problem comes.
So wait,
Well,
so
actually,
when are you able to move
The
the sun?
difference between diverging rays and parallel rays of light. You can't have a presupposition with diverging and converging light and then assume they're parallel for your mathematics. So when you
Why do
talk
you
about Aristophanes, you have to assume parallel light for it to work, and that is not reality. So why are we talking about Aristophanes?
We're
I have
not
a quick
talking about
question.
Aristophanes.
Why is presupposition so wrong to you guys?
Jesus Christ. What Science Zero said is not.
Wait. We're not talking about what are we talking about then? Who has done this?
He said using
Many
the
people.
sun, the subsolar
So
point.
Many people.
we're talking about
Hold on, Coach.
R.
I wanna.
Originally,
Okay.
we're talking about R, and I said, you can derive an apparent circumference size from the path of the sun, is what I said.
Exactly.
Okay, so when I
Yeah,
said that, I was saying this is how you can derive, but it's on a flat circle. Again, it's a circumference on a flat circle. You have to suppose a ball. So you can do it either as a 2D flat circle or a 3D ball.
But if you did it the way that you just said, but just following the sun's
Here's the
path
problem,
over the course of
Kocho.
a given day. I know. I'm just
Kocho.
answering Silent Zero's question. Love
Can I
of
just
God.
ask both of you? Does it matter what
Answering
time of
Silent
year
Zero's
you
question. Answering Silent Zero's question about the being closer or further. It wouldn't matter if you were doing the method that Data just said. Using that method, the distance of the sun doesn't matter because you're not using the actual position of the sun. You're using the subsolar point, which is not.
You don't think the wait. But you don't think the way the light it will change, it influence that?
I know for a fact it would not.
Based on the distance.
Here's what influences it. Our perception on a 360-degree circle versus an elliptical path of the sun. This is where the error comes into play. We want to sit as a human being and look at our field of view and quantify it using a protractor or that particular tool designed to mimic our perspective. And in reality, that 360-degree circle is an interpretation of our field of view, which is another supposition. In this case, it's one that works for our perspective. That's why we have straight lines and angles derived out of this field of view. So you have to understand that looking at the world you're in and having the tools that you have are limited. And if your tools that you have are limited based on a supposition, then you have to create a new set of tools based on other supposition, which is the Earth is a ball or the Earth is not a ball. So if they can't prove it using other tools, they claim to create other tools that can prove it. In this sense, they create spherical geometry. So for thousands of years, Euclidean geometry, right up until 1300s, was unabated by anyone else with any logical axioms or postulates that could supersede any of this logical reasoning and thinking, because everything that they displayed with Euclidean geometry was true and self-evident. So what they did is they really hated parallel. They really hated the parallel postulate, the fifth postulate, right? So they had to come up with new geometry, which is basically telling you straight lines can converge. Parallel lines will converge, right? So geometry in that nature was invented in the, 1800s? So this whole time we're navigating on Earth using Euclidean tools. Perfectly fine. We're creating celestial charts. We're creating everything with astrolabes, which is all straight lines and angles, which is plain trigonometry when it comes down to bare bones of all these instruments. Then all of a sudden 1800 comes and we come up with hyperbolic geometry, spherical geometry, and now the Earth's a ball because we can show it in math. I don't think so. We can still use all the base tools that we created, plane trigonometry, because that's what we live in. We live in a plane Earth, right? So you guys come talk about circumference and all that bullshit.
I totally agree. You
I
are
hear
right
what you're
on
saying.
the money.
Yeah, that was right on, man. All of that was awesome. And yeah, I was going to mention too before we were talking about the sun and sundials, because that's where this started, the idea of the angles of the sun and how they've inverted that into the heliocentric model by assuming a 93 million mile sun and then making the Earth into a sphere. But in reality, what we see, like in terms of a sundial, is it creates right angle triangles between the center of the sundial and the plane, which is under, at the base of it. And that creates the foundational structure and system of light and the geometry. And they've just inverted that and made a complete assumption and then created the entire heliocentric globe Earth model out of inverting that component by adding other presuppositions that were never true in the first place.
Pretty much what they did. That's pretty much it.
It's definitely what it looks like when you look at it is man obviously still did not find even so he created a tool that was able to navigate, and it's based on their perspective. This is what I think the protractor, all this stuff is evident of, is our perspective, right? And they put it in this form of geometry that we can use to actually navigate, because it's based on ratios of the human eye or the human body, or basic constant ratios that are in our world that are put before us to communicate to us, so we can use them to navigate the earth that we live on, right? For instance, the thumb to eye ratio, probably people have heard me say this. You actually have a thumb to eye ratio, and most people it's 20 times. So for instance, if you know the height of an object and you hold your thumb up to it, and your thumb, the width of your thumb covers the height of that object, you can take the height of that object and times it by 20, and you'll get the distance to it. So this is a constant ratio within our human eye that, you know, it's a tool that I'm blown away by how easy it is to use, but we're not taught to use it, because
That's awesome. Do you know as well that how the human eye is the Fibonacci sequence as well? Like the distance between the whites and the pupils and the edges of the eye are all the Fibonacci sequence as well.
I did not know that.
Fibonacci is that thing that is like a spiral. That's the shape? Is that what you're talking about?
The golden ratio, which is the Fibonacci sequence. It's a spiral. It's like this universal pattern in nature. The human ear looked at from the side is also the Fibonacci sequence, the way that it comes out and creates the kind of spiral look to it. And then it's also in like all kinds of plants and animals. But yeah, that ratio is actually found within the human body in a bunch of different ways. Like, for example, the distance from your wrist to your knuckle, and then your knuckle to your, like the next one on your finger, or the bone, you know, the joint, and then from that one to the little one, and then that one to the tip of your finger, that whole thing is the Fibonacci sequence.
So there's seems like there's a design there.
I think that we would be better off to know more, because for instance, even when I ask PhD people or educated people, where did the mile come from? Do you guys know where the mile came from?
Roman, supposedly it's 1,000 paces.
Yeah, so there's a couple of ways, but in that particular case, it was relative to whatever, you know, group of men were measuring at the time, because obviously you had taller and shorter men. For the most part, 1,000 paces was basically 5,280 feet.
Yeah, it's not a bad way to do it. Like when I played golf, when I was like in high school and stuff, I played golf quite a bit back then, and like I used to pace off the yardage, and I could get it quite accurate. So yeah, good pacing, especially if you're really paying attention to it, can actually be quite an accurate way to measure distances on the Earth. If you combine that with stellar navigation, you can create a full map of the Earth. It just takes a lot of steps.
Well, the funny thing is with the human step is that 1,000 paces has an average width. So it's a ratio again within 1,000 paces. And depending on your height, you're going to have this ratio. And the ratio in this case for an average Roman soldier was 5.285, whatever, which is 5,000, which is 5.28 feet is the average width of his step, right? So that's the big steps, right? But that's where it comes from anyway. And I found it quite interesting that not a lot of people, I mean, because now we're into meters and kilometers, right? So I think they're hiding some information with the miles, like the human body ratio to Earth,
the cubit,
human body ratio to Earth ratio, right? So, or if that makes sense, or eye ratio, whatever. There's a ratio there in what do you call it? In I'm looking for a word
Exactly. And this makes me think of like the sunlight, what you were talking about earlier, the way the sun is hitting, with sundials and the angles of sunlight. I mean, conceivably, that's coming from some distance above us, the sunlight. Like we see the circle of the sun, and it clearly is spreading out. Crepuscular rays, everything indicates that. So, and same with like any light bulb. You turn on a lamp, that's exactly what it does. It shines its light down, in that same way. So it makes sense that there's like, it's coming at that angle. But what is that ratio? And I would say it's actually connected to the Fibonacci and the golden ratio as well. But that actual ratio is what they've inverted to make the assumptions for the globe model. But that actual ratio is a real thing and is actually the way that the light travels from the sun to the plane of the earth.
Well, there's this 108 number that shows up a lot. Do you know anything about the 108 number? And I mean by a lot, it shows up in the math a lot for this for the distances and ratios to the celestial bodies and stuff like that. The 108, I can't remember where it comes from. I have to go back and look that up again.
Well, they hijack a perspective, right? And use it as a measurement for the dropping of the sun and all that stuff.
Well, it's just taking your perspective and turning it into.
It's all coming from. I was just gonna say real quick, it all comes from the source, kind of outwards. So, like the way the Fibonacci sequence works, you start with 0, and then 0 plus 0 is 0, 0 plus 1 is 0, and you just keep adding the next number to the last number. So
wait, 0 plus 1 is 0?
Well, no, I mean 0 plus 1 is 1. 1 plus 2 is 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. So you just keep adding the last two numbers. That's the Fibonacci sequence. So it's just literally adding the last two numbers, and it just continues like that fractal expansion as you keep adding the last numbers. And that's what creates that spiral that comes out from the center. And then as you keep adding the one number to the last, it gets broader and broader as it expands, kind of like a flower, like a spiral in a flower.
I think it's also in music. I'm not sure about that because I'm not a musician, but I think the Fibonacci is also in the music.
Yeah, it is. Yeah, the Fibonacci sequences are in the tonal levels of sound. Yeah.
So you guys ever seen? Have you guys ever read the book New World Order by Ralph Epperson? He's got a page here on his book. It says, kind of funny. It says, the old world is coming to an end. It will be replaced with a new way of doing things. The new world will be called the New World Order. The new structuring will be will redistribute property from the have nations and will give it to the have not nations. The New World Order will include changes in the family. Homosexual marriages will be legalized. Parents will not be allowed to raise their children, and the state will. All women will be employed by the state and not allowed to be homemakers.
Real quick, is this something you're reading, or I'm just wondering because it seems like it was totally different from the topic we were talking about before, in terms of light. And are you reading something, or I'm just wondering?
Yeah, I just wanted to see if you guys seen this book or heard of the book, The New World Order by Ralph Epperson.
Oh, okay.
So I was just reading an excerpt from the book. If you guys, I'm sorry, I thought I didn't know we were still on to the light thing. I think the circumference thing was dropped, wasn't it? We were talking about R, and that kind of disappeared, right? So I figured, what the fuck, I'll talk about this book.
Well, if light is coming down at a particular spread direction to the Earth, that would have its own radius. And if that's hitting a plane, the radius of that light is going to hit the plane.
You mean it would have its own circumference? It would have its own circumference, and from that circumference, you could deduce the radius. right? Because it wouldn't. What do you mean by having having a radius? You would have to assume its path, number one, which you would use a protractor, which is assuming a perfect circle, which the sun doesn't do a perfect circle, right? So your sun path is not going to be covering an equidistant part of land to create a perfect circle, right? If it's a elliptical path, it's going to cover the surface of the Earth in an elliptical format. Therefore, the circumference wouldn't be a circle.
What is the big ass path of the sun's light? Like the actual, like, I mean, I'm not being funny or not trying to cut you off. You can still finish. But like, what is the actual?
Have you ever guys have watched the moon, and you have some clouds? Let's say, well, you have the clouds, but they're like really thin clouds. You know, you can see through them. And have you ever guys noticed like another circle of light coming from the moon? Have you ever guys watched that?
It's like a sundog with for the moon.
Like the cone of the if the what I'm trying to say, if the moon was really that far away, that cone should be huge, like covering half of the
right.
You know what I'm saying,
Well,
right?
I'll give you guys a little exercise. I'll give you guys a little exercise to try. It's quite interesting. If you take a close light to an object and the object is reflective, there'll actually be a point where it reflects in, like you guys ever seen those pictures with airplanes flying and the sun is above the airplane and the shadows being produced down, but there's a ring right around the shadow of the plane into the cloud? You guys ever seen that? Anyway, that's the effect you can duplicate, and it's only possible with either a massive, huge faraway light or a close light. But you can show
Is
that
that what
effect.
Sound Zero? Is that what you were talking about when there's like a circular ring around the moon, or were you talking about the way that the moon spreads its light out circular upon the Earth?
Yeah, exactly the second one that you said.
Moon dog.
The second one. You can see the circle. You can see that circle in the clouds if you pay attention. And that circle is not that big. You know what I'm saying? It's not that big. That means that only means that the moon is closer than the distance they're talking about. Otherwise, it should cover way more than that. Way more than that.
Right, half the sky.
Half the yeah. You probably will not be able to see the end of that circle.
Can I add something to that?
Are you trying to say the moon seems a little bit more personable to its surroundings?
Well, it's in the atmosphere.
Think about like this. Let's say you have a light, right? A light bulb, and then you have a sheet of paper, right? And you put it really close to the sheet of paper, and you're gonna see a circle of light. And then as you move it far away from it, that circle is gonna increase in size, right?
Of course.
So pretty much the same thing with the clouds. In the clouds, if you pay attention, sometimes you can see that light of the moon. But you gotta pay attention, and the clouds need to be really thin, like.
Yeah, we get what you're saying. Can I add to that? I agree with you in a lot of ways, and I've said that many times. But it still doesn't add up, even if the sun is close, how small of a ring it's making. So I'm kind of backing away from that. I'm not telling you to. I'm just saying it seems to be affected by other factors. I believe in the dome or some type of atmosphere, some type of container up there that might be affecting light. So that might have something to do with it. But it does seem personal. But it would have to be really, really close to the clouds to do what I'm seeing it do. Does that make sense?
I'm on your side, I guess. I agree with you. But what I'm trying to say is that that light indicates that the moon is not as far as they tell us.
Well, do you know what's interesting is if you actually wanted to apply the perspective point mathematics to it, here's a really interesting thing. So they used to use this mathematics in early astronomy where they calculated the stars like Mars and all this or planets like Mars, like 228 million miles away, right? This is before they got into the astronomical shit. So the perspective point is the 3,000 pieces, let's say. So 60 degree divided by 0.2 degrees gives you 3,000 pieces, which if you take a diameter of the size of an object and times it by 3,000, you'll get its perspective point, which means its vanishing point. And so what they did is they would use this calculation for planets. However, the moon, for instance, the shadow of the moon, they say, cast on Earth is 70 miles. Okay. So if we apply that same mathematics, which is 70 miles times 3,000, we end up with 228,000 miles or something like that. Very close to the number they already have, right, for the moon. But the problem is the moon is quite large. It hasn't disappeared into its perspective point. Interesting, right? So
Yeah, it
if we
seems
take
to me, I think I hear what you're saying, but yeah, it seems to me like these luminaries, as I refer to them as, are like circles of light that seem to emit light throughout the environment in a unique way that I think is electromagnetic. It seems very electric to me. The sun, when I've done sun gazing, it really seems like some sort of an infinite source of electrical output that seems to project itself through the environment in very unique ways, depending on how that's all being constellated at that time.
Yeah. To me, that's why I'm more into the electrical side of things on the world. The only problem I have is with the ether, right? Ether to me falls in the same category as gravity. That's the only problem I have with the static or electromagnetic model, or whatever it's called. Yeah.
they won't be able to unify everything, man, because they're looking at trying to look at objects that don't reflect light, and they want to call that dark energy or dark matter. So how are they going to unify that with electromagnetic? It's impossible, man. It's like
it's only helium.
If they go to it, it's going to be the most infinitesimally small calculation. It just sounds so retarded to me.
At that point,
And the
they
way
fall
they
into
try
measuring
what
magic,
if
right?
they try to find
what
it,
if this stuff solve? I know, but
through
what if this
helium.
stuff solve? Super cool.
Don't know. They try to find dark matter, whatever that even means, through helium, which is weird.
The absence of light, right? It's the tiniest unseen, unknown thing that cannot reflect light. That's dark matter. Something like that.
Well, the form of nothing that makes up something.
It's so tiny you can't see it, and there's nothing in it when you look at it.
Oh, well, they can
Nothing
make,
reflects back. Nothing
they
nothing
can
comes
make
back to
crystals.
you.
Yeah, well, they can make crystals with things that we cannot see. So, I mean,
Yeah, it's that flow time.
yeah, the crystal of electrons, whatever. We argue about that. Just
What do you mean nanoparticle technology, where they can make the tiniest things with electrical pulses? Yeah.
they made
they apparently can take make skin into thin air with this electrical charge they apparently have.
So you're gonna see your skin like heal, and they're gonna tell you that's the nanoparticles working.
I don't know, but they're just saying they made a strand out of it. Apparently, I mean, this is on CNN years ago, so you take CNN with a grain of salt. But apparently, they could make a strand of skin using the little pulses, the little shocks. I don't know what they called it. I can't remember what the process they called it, but the process of these
that's
little
the whole
tiny
thing,
shocks.
like nanotech in medicine. Yeah, that's a whole
like
thing,
a TINS unit.
But they're pulling it. They're pulling all the carbon information, or whatever's in the carbon at that time, out of the air, and they're using everything that's in the air. Like what's encapsulating the air? Because carbon is the default of what's waste or what's burnt. Like what's carbon exactly? Carbon is because we're all carbon based, right?
Mm-hmm. So they say.
Well, it's an element, but Well, speaking of the air as
is
well,
it a decayed
well, I was
element
gonna ask, well,
that
this
can be
plays
used
into
for
it as well
fertilizer?
because, well, the Earth definitely has its core elements to it, and we have a lot of those in ourselves as well. But in terms of, I wanted to ask Silent before as well, just to carry on what he was saying. Like, so if you don't, in terms of the ether, like if the sun and the stars are above us, and then we live on Earth and we're in this environment, what do you call it? Like, do you call it something like, do you call it the atmosphere, the ether? Like what is the entire medium that you live within? If it's not the ether, like if you use a different word or different understanding of it, like what is that to you? What is this whole environment?
Jelly.
Can you hear me?
Liquid gas.
Plasma.
That's why me, at least, I don't believe that the light is traveling through something to your eye, right? I think you are seeing illuminated things, and you're capable of detecting that light with your eyes. It's not like something is traveling to your eye. I don't agree with that, but that's just my opinion. I don't know if that's what you were asking me or not.
Do you imagine it like
I
this?
was more
Do you
asking
imagine
like
it? Do you imagine?
you were like, I was more asking like, we were talking about the ether, so I was more saying like, if you don't call the environment we live within the ether, what do you call it? That's more what I was asking.
The environment, you mean like the air, the oxygen, and all this stuff that I live in?
Yeah.
Well, I call it air. I don't know.
What is the
that what
air
you're asking?
in? He's asking what is the air in?
What is the air in? Does it have to be in something?
Well, I don't know if I was
we're
quite,
in.
I don't know if I was quite asking that. I was not quite asking what is, well, I was more just saying like, okay, what I was saying in a basic way, if the sun, moon, and stars are above us and we're on Earth and we're walking around and that's what we experience. We have air, we have whatever it all is, the light, like you said, bouncing off things. What I'm saying is that if you don't call that the ether, what do you call it? Because you were saying you're not sure about ether, and I hear what you're saying with that. But if it isn't ether or a medium that somehow is interfacing with to create the physical world, like what is it in your mind? Like, is there no substrate by which everything is existing with it?
Well, first, you should justify why you're believing that it has to be in a medium. Otherwise, I would say, well, why? I don't need a medium. I mean, there's air that I breathing. If you're saying that air needs something to be able to move, then at that point I can ask you, we enter into a regressive question that shouldn't that thing that the air is moving through, that thing has to move through something also? Like at one point we gotta stop, and if we're gonna stop at one point, why is not the air the one when we're talking about the medium I'm in right now, that thing?
Okay, yeah, I got you. Well, yeah, and there's different definitions of the word ether as well, perhaps, different ideas. I mean, there's like the luminiferous ether idea, which is one particular component of it. But I guess just to get to the core of it, so do you think that there is is there a core medium that exists and then everything in the physical world comes out of that, or not? Like, is there a core medium of some sort?
Not to me. I mean, not to me. Honestly, I don't have any evidence of it. It's just like, to me, like I say, the ether is just like gravity. People cannot apply the scientific method to it. We cannot observe it. We cannot do anything. People use different experiments, and then they call that the ether, just like people use some things and call that gravity. But nobody can manipulate ether or gravity. So to me, those two things fall in the same category.
Okay, because I guess like I mean one of the ways I see ether is that it's like this foundational electromagnetic and electrostatic and light and sound. Those are the core 4 modalities.
Don't
And
get
then
me wrong. I understand the
out
concept.
of that, out of the electrostatic, electromagnetic, light and sound, out of that comes earth, air, fire, and water. And then the earth, air, fire, and water is what creates the physical world, or what is at the core of the elements of the physical world. So, yeah.
I understand the concept totally. But like I said, if I'm gonna be honest with myself, and I'm gonna be asking from the globe side, to demonstrate, manipulate gravity, I honestly I have to do the same with ether, you know. And since nobody can do that, I'm just gonna be a skeptic. But I do understand the concept.
Hold
and I
on,
think
hold
it's
on.
more,
It depends.
more,
It depends what you
hold
think. What is ether
Let me
displayed
just
as?
finish.
Because if you
I
want to
think it's
show,
more
if you
possible.
want to show drag, hold on. But if you want to, you're talking about evidence of ether, right? Like, let's look at what ether, what it's implying, what the implications of ether means. It's just something that propagates through, right? This is the underlying intention of the ether.
Listen
Is
to what
anything
you're
that
saying.
propagates?
Okay,
Hold on. So it propagates through. So, for instance, we use radios. So radios
bro,
can pick up frequencies.
I need
How
you
is
to
that?
pay
Hold on.
attention to what you're saying, because I'm gonna turn it back to you and ask you that apply the same thing to gravity, and you will see how both things pretty much are the same, right? You say ether propagates everywhere. I can say the same of
No,
gravity. Gravity
no.
is everywhere.
We're hold on. No, what I'm saying is what? Okay, so you would say evidences of gravity is such. Evidences of ether is such. Okay, we can break it into that kind of conversation.
No.
But I'm just
I will
saying,
not say that.
when I look at the ether, what the implications of ether means to me. So now it's a personal thing, because maybe ether is different to you, maybe than it is to Geo, right? So ether to you
You're one step
is
further, though.
ether
I
to
will
you is
not
like
say.
gravity,
I will
right?
not say what's. I will not say what is evidence of ether. What's evidence of gravity? It's like me asking what is evidence of a unicorn. It's something that nobody has seen.
Well, let me
right?
let me finish then. Let me get my thoughts out. So, if you want to look at what our surroundings are, what we're subjected to, we can objectively say that we have a field around us, a field array, if you will, around us that carries light, sound, and energy. Right? That's
No.
something that we have.
Sound is carried through air.
Yeah. So we're in a medium that has all those properties. Is my point. So we can look at what gravity is. Now, gravity has been quantified into a force that coalesces things into the center of mass. But here in reality on Earth, it is a constant rate of fall that happens to be measured throughout different various places on Earth. There's a constant rate that's measured, right? In a small container, maybe a foot drop in total. This container's in a sealed vacuum that keeps dropping every 30 seconds, right? And it's this constant rate they keep measuring. Now there's different variables. Now we can talk about those types of realities and what those are being quantified into. I just want to say to the concept of ether, it's the field array that we're involved in. The sound, the stuff propagates in, the light and the invisible light, anything to do with light and visible light that propagates through, and of course the
Again, you can say that, but you haven't hold on. You can say that, but you haven't demonstrated to be the fact. This is where I have problem. You just say, well, this is ether where everything propagates to. You haven't demonstrated that, and you made the assertion already. It's the same as gravity.
Well, what does ether mean to you? What does ether mean to you then?
Yeah, there may be different definitions, because I mean, this word ether is actually a very ancient word, and it comes from. But in current time, it's been associated with particular, perhaps different theories or ideas. So people have used the word in different ways. So I think the first thing is one would have to define what they mean by that. However, I would say that every single thing we do is a manipulation and a testing of the ether. Like when you make a Ferrari that's able to handle, like it can on the roads, that's because you've been able to modify the ether in a way that can create those kind of physics, or radio signals, or all of these different components are actually have been testing and, if you want to call it tweaking, modifying, tuning into the actual environment, which is the physics of how we live. And it is connected to why things drop to the earth. So it is connected to quote unquote gravity, but I would just say it's the entire medium that we live within and how the physics function within it.
I mean, it seems like I don't know. I keep expressing my contingency to your point, and you guys keep asserting it without listening to what I'm saying. I don't know at this point. Because to me, ether. Let me
what's your
just express what I
contention?
mean by
What do
ether.
radio waves propagate through?
Do they need to propagate through something?
Yeah, see that? Yeah, I think so. Yeah, dude. I mean, that's what I'm asking.
Oh, okay,
I'm not
well,
even doing any
why
connection.
do you think that?
Yeah.
Why do you think
I'm
that?
just to be clear, I don't know. Data might have been saying something different, but for me, I'm just sharing my perspective. For me, there's no contention at all. I'm just fascinated with how other people think, and I'm interested to hear how you guys see it as well.
Yeah. Why do you think that they have to propagate through something?
Because there's obviously a way to transfer energy, for instance, from a point to point. Yes, you need an energy source to get the transfer of it. In other words, if I had one tower sending out a signal to another tower, I could actually use that energy coming from that other tower, right? It has to travel and propagate through something. It has to use something.
No, you can emanate.
Hold on. For me, I know, but hold on. To me, what's happening is it's just like any tuning fork, right? Like if we just look at the basic level, even of at a tuning fork can resonate at a frequency, and they can vary these tuning forks at various frequencies that have certain effects, right? So these, the way that we've developed the understanding of these effect is applying it to the medium that we're in, because without the medium we're in, we wouldn't be able to deduce these effects. So I'm just saying it's like a byproduct. Maybe it is circular reasoning when you actually look at it, but it's a byproduct of what you're using. So you're actually using it. So when you look at gravity, the problem with gravity is it has a connotation of coalescing things to the center of mass. The rate, you don't have an issue with the rate of fall in these controlled containments, to whatever they're doing over and over again.
With the rate of fall, the problem I have is when you say that there's something grabbing that shit and pulling it down to the ground.
Well, Silent Zero, is there such a thing as nothing?
There's
for
such
you?
a thing as nothing.
Yeah, is there
So what
such
I'm
a thing
saying-
as nothing?
What I'm saying is, look at it this way. They're like here's
Let him answer
they
the
always like to
question, Fed.
I know.
There's
Just before
such
you
a
do,
thing as nothing.
Is there such a thing as nothing? I understand your argument about radiation or eminence or coming from a place, but you have to decide if there's such a thing as nothing. Otherwise, you're coming from a place into something that's already there.
There's such thing as nothing.
Right.
Where?
There- it's
You're asking me
anywhere,
here in the
anywhere. Is
earth?
there such a thing as nothing? Can you have void? No,
I
you
don't know.
can't.
I don't know how to
You
answer
can't.
that.
Even if you pull a vacuum, you still have something, right?
I don't know. I don't
You
know
don't
about
know.
that.
See, this is the
You're
problem with your logic, is
No,
that
no.
you need to figure this out for yourself.
Bro, listen, you're making the assertion that that vacuum has something still. I don't know that.
Absolutely,
How you
I am.
quantify-
But that's
how
but
you
that's
have
for
an
me to
issue-
decide,
How
right?
you quantify how much things you have in that vacuum? How you quantify that?
Well, this is. I'm just asking this so that you can decide for yourself. Do you think that there's such a thing as nothing? Go for it. Just think about it.
you just probably have an issue with the word ether and gravity because of the connotations
There's such
behind
a
them.
thing
as nothing.
He's
I would
wondering an
say-
opinion. He's not asking you to assert anything. He's not asking you to claim anything. He's just asking for your opinion. That's all.
No, I don't even want his opinion. I want him to think about it.
Yeah, but I mean, because the reason why it's like a complicated
this the
question to me
sound
is
of your
because
brain?
what are we talking about here? Are we talking about a place? Is there such a thing as nothing in this place?
Yeah.
I can answer easily
Is
that.
there
But
such a
it's so-
quantity
the
of
question is so
nothing?
vague.
Are
Like
you have nothing?
it's
Are you
void
trying
of
to
context.
assert
Hold on,
without
hold
the
on. It's void of context. I don't know, like
Well, void of
nothing
anything.
where.
Can you have it?
What are
Can
you
you have
talking
nothing?
about?
Can I try a different way? Hold on. So
Are you trying to say without the ether there is nothing?
hold on. Can I just ask this? If man wasn't here on Earth, right, and we didn't have any of the stuff around us like that we created, there would still be would there still be sound, right? There'd still be sound frequency.
Yes, of course. Yes,
There'll
of
still
course.
be radio. There'll still be magnetic frequency, right, or magnetic
Mhm.
energy, right? There'll still
Of
be
course.
all the fundamental. Okay, so let's say that's a field array, because that's all existing within itself. It's its contained unit, right?
Mhm.
And the sound array, the radio, like magnetic, everything that we use today has been harnessed by man because of what was already put there for us, right?
Yeah, it's part
We're
of the
kind
nature. Yeah.
Yeah,
I
so
understand
for
that.
instance,
Yeah.
you know how modern science likes to kind of hijack things, and Einstein comes up with the bending of space time. Well,
Mhm.
look at the field that we're in as it's kind of like a fabric, if you will.
But
Like
you
the
haven't
bending
shown
of
it.
space time. They
What
say
field am I
it's
talking
not
about?
about. I know it's not about showing it. I understand that, but here's what I can see is that through different optical devices, I can look at different wavelengths of light.
No,
Through
because
different
at this point
radio.
you fall.
Hold on. Through different optical devices, I can look at
You
different
keep
wavelengths of
going,
light.
bro. You're bringing so
So
many
I'm not
points, and
done.
I need to
I'm
answer
not
to
done.
some contingencies that I have through the whole spew that you're bringing. Come on.
Well, I'm just trying
That's
to
good.
conclude my statements, right? So I'm not trying to bring up a whole bunch of points. I'm just trying to conclude what I'm trying to say, so you understand that the field array that we work in, there's actually an array of sound, an array of electromagnetic energy, an array of various fields.
Let me answer.
So are you just trying to call it the mother
Let me
energy?
answer here something.
The
Here's
source.
where you fall. Here's where you fall into the same trap as Newton did, right? Newton saw that we need to apply a force to things that are vertical to, horizontal to us, right?
No,
And
can I correct you
hold.
there?
All right,
I
hold
want to
on.
correct you. I want to correct you. Newton looked at the heavenly bodies and noticed a perpetual motion. And that perpetual motion is that force of gravity. Okay, that's why they needed a mystical, magical force. That's that perpetual motion. That's not reality. That's why they have to have things like conservation
All right.
momentum.
Well, let me
Because
finish.
it's all
right?
derived in
Let me
perpetual motion.
finish. So okay. The reason I thought that the laws of motion were applied was based on, logic in quotations, because, one time I argued with some of the guys here. They say it's because we need to apply a force to something that is on a horizontal plane, right? Therefore, if we see something accelerate, to make it accelerate, therefore, if we see something accelerating, there must be a force, right? And I disagree with that. We have things in nature which, to me, those things in nature triumph any story explanation that any human being tries to make about those things. So we see apples falling from the tree, the rivers moving. I don't see no forces applied to them. Okay, on a vertical axis, we see things moving up and down all the time, and I don't see any forces applied to them, right? So that's why I disagree with the laws of motion, me personally. On the horizontal, when we're talking a horizontal axis, yeah, we actually see that we need to apply a force to make something accelerate. But in nature, show us on a vertical axis, we don't need a force. But since these people,
you do need a force.
They gotta say, well, because
that's the
we see
problem.
this,
You do
we
need a
see
force.
this,
So
we
you're
gotta have
trying.
this. Must be
You have a
something
suspension of
there.
disbelief again. You have a suspension of disbelief again, dude. What do you mean
Wow.
a force? Any object that is going down vertical has been put there by another force. So what are you talking about? Nothing ever magically appears in a position where it can fall downward without some sort of energy put into it. It's always a first law of thermodynamics. It will be a first law of thermodynamics violation if objects just suddenly just dropped. Right. So the story of Galileo dropping two pebbles and two marbles and one marble being higher than the other, therefore retaining more kinetic energy, it's proportional by the distance he elevated the object to. So if you're going to increase the height of an object, you're going to increase the energy put into the object. So why wouldn't you would expect it to create more of a force? You're putting more energy into it.
Again,
So even
That's the first
even
law of
at this
motion
point,
violation.
at this point, you have fall into the explanation of human beings, bro. I'm sorry.
Yeah,
Nature
I
triumphs
understand.
any of your explanations.
I'm not trying to explain anything. I'm just trying to tell you it would be a first law of thermodynamics violation if there was a magic force put into something. In reality, you need two objects interacting with each other to have a pressure differential. The one with the greater differential will be pushed, or it will be pushing, and that's how it works in reality. We have to have that differential to have any motion, and that differential is the pressure force. The differential is that pressure force.
First law of motion violation, not first law of thermodynamics violation.
Yes, it is. It's the first law of thermodynamics violation because you can only transfer energy. You cannot create it or destroy it. You can only transfer it. So any object that is falling to the ground is transferring energy, but the object that put it there.
Yeah, well, the first law of motion says that an object in motion will stay in motion unless a force acts upon it. And in
that's
that
also
example you
bullshit.
gave,
And that's also
Again,
bullshit
that's
because
bullshit.
there's nothing. Again, that's bullshit because again, that is not that is a first law of thermodynamics violation.
I really hope everybody
can
gets
only-
the monologue as long as
You
you
can
get to.
only
No, you
only
have to be a flat
transfer-
earther, Kosho.
You can only transfer energy, dude. That's
This
it.
is like the new
You
24/7.
cannot create.
Demonstrated.
Who you're asking to
Demonstrate me picking something up and dropping it and going, hey, I picked it up. I put kinetic energy into it, potential energy, if you want to call it, and I dropped it. Well, if I go up higher, I require more energy. My arm went up even higher, I required more energy. I put more energy into it, and I dropped it. So I'm just transferring
You
energy.
see, the problem with this is that it assumes that there is such a thing as nothing. If something's in motion and it stays in motion, this is another one of those claims.
Your question of nothing is
Are
void
you
of
cutting me off,
context.
Silent Zero?
Yeah, I was.
Yeah.
Yeah, to explain you that your question is void of context. That's why nobody can answer that
Well,
shit.
Okay. So the same context that I'm implying is the same context
What
that
is
they're
the
implying.
context?
So if they're saying that motion stays in motion, right? That assumes that there's no friction and there's nothing to stop it and all this other stuff. That is not like that is a situation that is not possible.
Yeah, I understand, but at this point, how do you know that? Because we can not experience this. How do you know that?
So if you can't demonstrate it, then it's not practical.
will-
It's more of a
will-
mathematical proof.
Rig, it's
but
that's
that
encompassed.
doesn't mean this is real. Holy shit!
It is, yeah. It's addressed in the law. So whenever you said friction, like, well, what if there's friction? What if there's this? Those are forces. So
Hey, how
an
do you
object
know
in motion
that at
stays in
one point?
motion unless a force like friction or whatever else acts upon it.
Well, that's a claim of knowledge. Do you guys know 100%
It has
that
to be a force. It can just be present.
Yes, we do. I'd say, give me an example where something is going in motion, and then for some reason it's not doing it anymore, and the
You're
reason
gonna reverse.
that it's not
You're
doing it
gonna
anymore is
reverse
not a force.
You're gonna
It doesn't
reverse the
have to
burden
be a
of proof.
force if something's just
Hold on.
present.
You're gonna
Is
reverse
he
the burden
talking to
of
me or
proof
is he
what?
talking to you? Because I thought I was
So
talking to
hard
him.
with these interruptions.
Okay, I'll stay out of the conversation. Go ahead. I thought you both are Glovers. I don't know what the hell are you guys arguing about.
No, I'm not a Glober.
It's the assertion that something will remain in motion unless acted upon by something else. Essentially, when you provide the example of friction, you are providing something.
So it's wordplay.
No.
No, friction is
It's
a name given
not.
to a force. Friction is an actual force.
You see how they make this assertion and then they're gonna ask you to prove something that we cannot or they cannot provide.
No,
So they
something's
provide
in
an
motion.
assertion based on a falsifiable model, and then they ask you to prove the negative.
In a weird way, I approached validating that assertion or proving that law within my experiment, in which there was a rate at which my pendulum swung, and that took longer while under vacuous conditions. So it essentially was saying it took longer for this momentum to be
we could
lost
predict
when there
that.
was less things around it. And
Yeah, we
it's
could have
I
predicted
think
that.
that's I don't think that's a validation of the law per se, but there is
Not.
an extrapolation that occurs there where if you
There's a
add more
gradient.
stuff, you're going to reduce the momentum of something. If you remove stuff, you're going to reduce that that
Yeah, but
momentum.
can
You're
you,
going to
can you
reduce the
remove all
momentum
stuff?
loss.
But
How
it
do you know?
eventually stopped.
Well, it did. It just took a lot longer because there was less stuff around it. Essentially, validating the claim that if you add friction or add stuff for it to interact with, it will lose
Yeah.
energy.
The problem with the claim, though, is that it's saying that if you put something in motion, there has to be some other motion, which is you're applying something just to stop it, or reduce it, or whatever. I'm saying you don't. I'm saying that just putting something in motion at all will be subject to loss over time. Period.
The energy,
Because
right?
the nature of existence, you can't remove all interaction. So it's a baseless assertion or a claim whatsoever.
I would describe it as a 0 point, in which that's where you branch off of when you introduce friction to an experiment,
the
or if
thing
you
is, the
introduce
claim
a
that you
different force.
have requires a 0 point even to make the claim.
No,
No,
that's what I'm.
dude. Friction is encompassed in that law. Friction is one of those things that when a force acts upon it, including friction, then it changes. But friction is a law. I mean, it's a force that will change the,
Well, let me
movement of
ask
something.
you.
So it's not. It's
When
encompassed in.
Okay, I get it. So when you're talking about friction, that's a physical, like it could be it could be air, it could be another object or whatever. Yeah. Now, could it actually entail something that's invisible, like a magnetic friction, a static friction?
Yeah, any force. Yeah.
Okay.
So that's why they have in space, you know, they push something and it's gonna go on that direction to infinity, right?
Yeah, that's why when you play air hockey, the puck keeps moving, and it doesn't just fucking randomly stop on a whim.
Yeah, there's a whole lot less friction occurring if you remove the air. It's at solid on solid rubbing, and then if you put it in the air, it's at solid
We
against
understand that
gas.
concept, Bio.
So it's a lot less friction. That's why it maintains that momentum much easier.
Don't you think it's ridiculous to make the claim that something would move forever except for this the fact that it's impossible because of
No, you
friction?
can measure. You can
Like it's
measure
literally
this.
claiming within itself that there's the situation that's possible if we remove reality.
No, they can literally. They don't make this claim willy nilly. They make this claim because it can be measured. Meaning, you can do something. You can make an object go in motion, and then you can measure the speed and the persistence of whatever motion is going in, and then you can measure the things that slow it down and the
To a
amount it
great
slows it down
degree,
by, and
but
what it is
not
that's slowing
to
it
the
down.
point of no
And
loss.
if every single thing is accounted for,
But
then
from that to say that
then the
it's
law's
gonna
true.
move, but from that to say that it's gonna keep moving to infinity, if there's nothing obstructing it, it's just it doesn't
Yeah,
make
it's a
any.
baseless assertion. It
If
literally
there's
helps
nothing,
nothing.
if there's nothing to stop it, what's gonna stop it?
Well, guess what? Give me a situation where there's nothing.
No,
No,
exactly.
it's a legitimate question. If there is nothing
Yeah,
to
it's a
stop
legitimate
something
question.
moving,
Give
no,
me
hold
a
on.
situation where there's nothing.
If there's nothing to stop a thing, what's going to stop it?
What do you mean,
Maybe
like a
the
black
energy
hole?
you
What's
put it,
nothing? What do you mean?
the energy you
Define
put in.
nothing.
All right, that's
Define nothing, which is part of your proof of if there's nothing there, it'll move forever.
He's gonna say space, maybe.
Dude, it's a ridiculous
No,
claim.
I'm not going to say anything. The question
I
is
know
out
you
there.
can't.
I'm not going to press it or get upset. It is there.
There's
Everyone
nothing to
heard
get
it.
upset
I don't have
about.
to repeat
You
it.
literally have you're basing your idea of reality on something that's totally proposed that's not possible.
Like I said, this is measured and
No, it's not.
qualified.
No,
It absolutely is.
You're so full of shit, Kocho. You know what? Say it again a million
As
times.
I
This
just
is
said,
recorded.
You're
if,
funny.
if you're that afraid, if you're that
Say it
afraid,
again a million
then
times,
if
bro.
You can measure, yeah, you
if
can
you're that
measure,
afraid, then be afraid.
no,
Yeah, well,
I love it. I love it, Coach. Keep going.
you measure the acceleration and the velocity of an object, and you measure the persistence of that, and you measure the amount that it's decreasing by. Then you measure the amount of force that's acting on it to make it decrease by that. If everything's accounted for, then guess what? There's literally nothing. There's nothing that would have stopped it from continuing to increase. Or
yeah,
continuing
then
to
you're gonna assert, and then you're gonna assert that that thing will keep moving to infinity if there was
beyond.
nothing there, right?
No, you're not. You're
Yeah, that's
not
what
an
you're
assertion.
doing.
That's not an assertion. That's a natural inference implication of that. If there's nothing to slow something down,
Oh my God!
if there's nothing,
what is
to slow
implication and
something
assertion, bro?
if there's nothing to slow something down, and there's nothing to decrease the speed of something, and there's nothing to stop something from moving, then how is it a wrong claim to make that it's going to continue moving?
Well, you can assert that, but you don't know that.
Can we say?
Motion.
Can we say it's being propelled? If that's the case, can we just say that like we wanted?
This is why I did this Silent Zero, because I wanted to show you that the idea of there being nothing is stupid, and these guys fell for it.
Well, I mean, what's the difference between an acceleration or a propulsion or like a fall or a climb or a? I mean, what?
Acceleration requires.
To me, the ether, because like I said, let me explain. The ether to me is something that is impregnating everything, right? It exists everywhere. That's how I understand it from your point of view. It cannot
But we
be.
don't know how to define it yet. All we know is that there's a persistent medium. It's yet to be understood.
Yeah, I understand that the concept. The only problem I have is when people try to bring it into like, well, it does exist 100%. When we're asking from the other side to quantify with the scientific method their assertion of things,
Right.
that's where I have the problem. But
there is a
if you ask
problem
me,
where
I'm more on
people
the side of the ether,
they
because I know
replace
a lot of cultures used to mention this ether thing, and they use this name a lot. A lot of cultures. That's yeah, I'm more on board with the ether thing.
there's a problem where people they use the term ether the same way that Globers use gravity, because it's just kind of a catch-all. They don't have to explain shit.
Gravity's not a catch-all and actually has an explanation. And a better comparison would be ether and the thing that quantum physicists call the quantum fields, because the quantum fields do the same thing that different people say the ethers do. The ether field does, except for the ether or the quantum fields have actually been tested and verified.
Oh
So
my God!
that's really difference there. But
Hold on a minute.
other than that, they do the
How
same
many
thing.
parts of your model depend on
Coach,
gravity, Kosho?
Hold on a second. Quantum fields of what have been verified?
Quantum fields of the electromagnetic quantum field, the electron magnetic quantum field, the they call it the Higgs field. What else? I mean, there's a field for every
Verified
particle.
by what?
By tests.
Tests of what?
Testing.
What type of test?
A virtual.
Virtual. You said.
What's that one test? What's that one effect called? The I forget what it's called. Where they have the plates and they have them moving together because of the virtual particles. Where they, predicted the electron dipole moment.
So a plate has electrical continuity.
Casimir
And that
effect?
means
Say what?
You're not talking about the Casimir effect, are you? I'm trying to find
The Casimir. That's one. Yeah, Casimir
So-
effect is the
yeah.
one where the plates are moving together. Yeah.
So that means what?
That means that there was virtual particles that was being created that was pushing it together that weren't existing inside the plates. But the other thing that was proven or shown to be true was the Hawking radiation. And Hawking radiation, what Stephen Hawking had predicted, was that because of these virtual particles being created, there is a probability that they're created right near a black hole, and there's a probability that the black hole
Whoa,
would
whoa, 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 whoa. Hold on, hold on.
only one of those
How
virtual
could you
particles, and
hold on a
not
second?
the
One
and not the
second, Coach.
antiparticle, and
How
what you
could
would
you
control
go?
the radiation.
Kocho, you
And
need to
this
wrap
was
it up, bro.
witnessed. It's wrapped up. I'd love it if everybody would have to wrap it up, right?
Yeah, you took like 2 minutes or 3 minutes there.
Bitch,
3
that was
minutes,
like
huh?
25 seconds. Relax.
We all
So,
can't
What
be
was that, Bayo?
time.
Said relax. It was like 25 seconds.
Oh,
how
hell
many
no.
different parts of your model do you depend on gravity to explain?
The size of the Earth,
None of them
the
really.
orbit of
You're gonna
the
need half of
thing.
that.
Nuclear
Gravity
fusion in the
just ties two
sun,
things together.
the
Ties two things
tides.
together.
Tides,
Gravity ties two things together.
the
That's it.
air, the
It
air
ties how
that we
things
have
fall on
to
Earth
breathe.
and how
Atmospheric
things orbit
pressure.
things in space.
Don't you
That's
guys?
it.
Let's
Yeah,
see how many times we can interrupt
saying-
and not be like 24/7. Let's
Well,
do that.
Coach said that they
whoa.
created something out of nothing from two
Whoa.
discs. They
Bio,
had two discs.
why do you say that it doesn't affect anything other? It
I didn't
affects
say that.
your model without gravity. It goes down to crumbles. It affects the atmosphere, affects orbits, affects the size of the Earth.
I answered this answer, but you were so busy talking that you probably didn't hear it. But yeah, but he asked.
Stuff that
I
doesn't
said
exist.
it affects. It's two things: how things fall on Earth and how things orbit things in space. These are two things that
and
do
the air
connect.
that we have
And how the
How
sphere
did
was
the
made
planets
in space. Yeah.
or how do stars form in your model?
Right. The formation of stars has nothing to do with the globe model. It'll
It
be
has
the
to do with-
globe model, not the
Okay, well,
heliocentric,
let's-
perhaps not the
Earth made?
universal. Those are separate
How did the
things.
globe get to be a
How
globe
was the
without being a
Earth
star
made?
first?
Yeah, how
Starbird?
did it become how did it become a sphere then without gravity? Tell me, Bio.
But gravity will be part of that.
How
Gravity does
Let me
interact.
ask it
Hold on,
this way.
Silent. Hold on,
I'll ask
Silent.
it
Hold
this
on.
way. What
Silent,
caused it
I'm not going to
to
go
become
through
a
this
sphere?
bullshit game. I'll explain it to you, Silent.
What caused
Gravity
it
has a real interaction with reality.
What
Because
caused
we
it
live
to
on a
become
big
a sphere?
mass. Silent.
Bio.
Relax.
Relax. What caused it to
If you're going
become
to
a
self
sphere?
spiral, I'm not going to be interested in talking to you.
No.
We
I'm
can have a
really
legitimate
calm.
discussion.
You are the one spiraling right now because I got you on this.
I'm trying to
fucking
explain
question.
it to you, but you keep interrupting.
What are you gonna explain me? My question that I'm asking, or
Yes,
something
that you already asked.
that you have
The
in your head?
question you already
All right,
asked.
repeat the question that I'm asking.
How was the Earth formed as a sphere without gravity?
All right, go.
Right. Relax. The gravity interacts within reality in many ways, but it's not a requirement. If mass happened to not attract mass, but we still had this same effect, all of the implications from that would still be the same. That's the thing, is that gravity is hyper specific, in which it is actual requirement as far as the explanation. But everything else would just have a different explanation from this effect that we witness.
You done? All right. To anybody on the panel, did he answer the freaking question?
Where am I?
Anybody?
I think he did.
He did.
Yeah.
Okay. Right.
That's
There
why I
you go,
use
Mike.
the analogy. That's why I use the analogy with magnetism, because that effect is very similar, in which we have a particular distance from a magnet that there is an attraction. And the closer you get to the magnet, it's a stronger felt attraction. Much like putting two magnets close together, you can feel that it really wants to pull each other to each other. But then when you put some space between, it might feel like they still want to attract to each other, but it's a lot less that you have to prevent it from doing. A lot less energy is required. That's why I use
With magnets,
that's why I
because you
use
cannot do it
magnets
with
analogy.
yeah, you gotta do it with magnets because you cannot do it with the things that you are claiming.
Of
be
course we can.
happening, right?
You're going off on a tangent and you're not understanding what I'm saying. Is that we can use that. So if for some reason mass attracting mass didn't exist, it would be just as easily to postulate that it was magnetism causing things to be
No,
spheres,
you're not
because we would just have
understanding.
a magnetic object, and there would be tiny little objects, and they'd be attracted to this magnet, and over time in accumulation it would form a sphere naturally due to just magnetism.
Yeah, you're not understanding bio. I don't know what I don't get is why are you using something else to demonstrate what you claim to be happening?
Well,
what I'm
magnetism is much
specifically
stronger than
saying.
what Force is invoking. So
Sorry. What I'm specifically saying is that the globe, the Earth being a sphere, doesn't require gravity as far as a possible explanation. There are other natural things about reality that could form it as a sphere. We just have an explanation because it is a fact. That's the only reason why we push it as the reason why it happened. If we were to magically remove gravity altogether, magnetism could do the same thing.
The Earth to become a sphere.
What is I just kind of got back into
Oh,
the
look,
thing.
first answer. Here.
what
Let
is-
me just say this. A
what
planet
is
is
the
round
topic
because
right
of gravity. Fuck you, bio. There it is,
Holy
your
shit!
answer.
Did he not understand anything that I said?
I don't care what you say. Here's the fucking answer. See, I was right.
Silent. Let me be very clear.
Yes. What?
The way that the reason why the Earth is a sphere will be largely due to gravity and mass attracting mass. That is reality facts. What I'm saying and answering your question is that there are other natural effects within reality that could form things into spheres, much like gravity. That's why I use the analogy with magnetism, because they are very similar effects as far as their interactions within reality.
Read and chat and shut the hell up, bio.
Wow. Well, all right. You literally have no idea what I'm saying, so move on.
No, I have. I just have to dismiss it because what you're saying is ridiculous.
Would you admit then that your
It's not,
model?
it's not in your model. That what you're saying right now?
Holy
it's not
shit,
in your
man.
model. Holy shit!
Do
Yes.
you think that
holy
I'm
shit.
asserting that the Earth is not as a sphere not because of gravity? Do you think that's what I'm asserting right now?
That's what I've been fucking asking you the entire time.
Fantastic.
That's what
Fantastic.
I say. That's what I say. You're answering something other what I'm asking you. You're answering something else that nobody has asked you. I ask you a specific question, and you go on this answer that nobody asked you about, and then you complain about me interrupting you, trying to bring you back to the subject, right? Because you're trying to answer something that nobody asked you. And then when I try to correct you and I bring you what it says on Google, right? And I show you that what I'm asking you is correct, you complain of me not understanding what you're saying. I don't care what you're saying.
Here's
You're
the
not answering
analogy,
my
Silent.
question.
Silent, here's the analogy.
Bio. The problem is that the people are
Was that
asking the
Terry?
question.
Yeah, let's give Terry the floor. What do you got, Terry? What's up?
I'm just going to say the obvious thing is when people ask a question that they don't like, they need to reform their question if they don't to get a different answer.
So I think he answered pretty well, to be honest. It's just that he tried to use, because we were asking what would the globe model have if it didn't have gravity, and he did say, well, even without gravity, he kind of logically deterred that magnetism would take the part, yeah, for gravity
which is
to form the
which
globe,
is another
what he thought.
force, which is another force,
I know,
and analogous to gravity.
but he did answer the question. All right, he's trying to
Yeah.
invoke another force, but he did answer the question.
It's a similar analogy to something like if you didn't have semi trucks to deliver goods to Walmart, what could you have or what would you have? And I'd say, pickup trucks or other vehicles. And then you give me a source that these long bed trucks are the ones that are delivering it to Walmart. We're just exploring the idea of if not this, then what else? That was your question, Silent.
All right, let me explain myself. Hold on, guys. So we were talking about your model, bio, right? And we were saying without gravity, so many things go wrong, such as the atmosphere, the shape of the Earth, the orbits of things. And you say no. We were talking about your model. In your model, why are you bringing magnets to your model if gravity is the one causing the Earth to be a sphere?
Because I thought that you were asking an honest question.
Nobody care about the other options. Yeah, I understand that, bio.
That's my fault that I thought it was an honest question. My fault, Silent.
So that was a question talking about your model. That was the assertion. Without gravity, so many things go bad in your model, such as we get no atmosphere, we get no shape of the Earth, we get no orbits, and
Silent,
don't
I
know,
addressed
many
that.
other things,
I
right?
addressed that because you.
And,
What was
and
the
then
first
you
thing that you
go
said
ahead
there?
and answer a question of what alternatives can make the Earth be a sphere, which nobody answered.
Holy shit.
And for
Silent.
some reason, somebody here says that you answered the question. It's
Yeah, I did.
ridiculous.
Silent. Slow down. What was the first part of what you just said? If you don't have gravity, then, right?
No.
Oh, hold on. I appeal to the rest of the room. Did Silent say if you
Nope.
have no gravity, you have no Earth shape?
No, he asked if you didn't have
In
gravity,
your model.
what would you have left?
There you go. Exactly. That was
I
your
didn't say
question,
what you have
Silent.
left. Okay,
Well,
we're having to. Oh, okay, I see the
restate
problem.
your question.
Yeah. Okay.
That's
We're
exactly
talking
what
about.
I'm saying. Restate your question. Reform your question.
All right. Maybe it's my English. I'm sorry.
That's okay. That's okay.
So we're talking about your model, right? And we're trying to show how your model, without this thing called gravity, breaks, right? It stops working. Okay. So that's the whole point, to show how without that gravity causes the Earth to be a sphere, and it has a lot of effects on the model that you guys believe in. That's the whole point. I'm not trying to ask if without gravity, what else could make the Earth be a sphere. I'm not asking that.
Okay,
I'm
I have a
trying to
simple
point
response.
out. I'm trying to point out that in your model, gravity rules a lot of things in your model. That's it.
All right, that's fine. I'll respond in the most simple way I can. Correct. If you remove a big part of reality, reality breaks down. I agree.
Well, BioDual, the thing is, looking back, just in terms of the default cosmology that always existed before this kind of globe Earth idea, was always a stationary plane which was surrounded by some kind of a celestial sphere. So there would be a spherical nature in that type of idea to the universe and to magnetic fields, and that would be a part of why things fall as well. Like, it's all connected in terms of that. However, this idea that we're on the outside of a rock, of a sphere, flying around through space, that's where the whole thing is an assumption, and the whole thing breaks down because there's no proof of that. So just trying to claim that because things fall to the Earth, that all of a sudden that makes things into spheres, I think is conflating two fundamental structures within the universe. In my viewpoint, would be the stationary plane we're on and the celestial sphere that surrounds us.
Yeah, I would disagree with like half of those assertions that you made. You know that we provide evidence and we provide validation for many of the things that you call assumptions. You know that that's provided.
So bio without gravity, right? Let's consider entropy. Now, when you consider a sphere and entropy, doesn't that have some type of So basically, if there's no gravity, things are still going to try to get to the least amount of entropy, right?
Yeah,
so
sure.
wouldn't things still form spheres because a sphere has the least amount of entropy?
So long as you have a force. So long as you have a force present, and that's why I brought up magnetism, because we wouldn't disagree to that. And the implication of a strong enough magnetic force with enough loose material, and let's just say it's just a pit of it, and you drop a magnet in it, you're naturally going to form a sphere because of the equidistant potential. That's really all it comes down to. So long as you have that force, a sphere will be formed.
But
it's a nice like magnetic fields. That's what I was talking about. Magnetic fields are toroidal fields, and they are somewhat spherical. They're not necessarily perfect spheres, but they can have an oblateness as well. So all of these concepts that exist, what I just feel like you're doing is conflating and trying to kind of blend the two into something to support, just an assumptive model in terms of the globe Earth idea.
But that's a good point, because you just brought up Silent Zero's older argument about ether, because I think that's what the ether does as well.
Yeah, so Bio, maybe answering Silent Zero's question in a slightly different way, right? Now, imagine a universe where gravity doesn't exist, how do you vision the universe looking?
That was
I
not my
think,
question.
I
Go
think,
ahead, Leo.
yeah, I know. He asked a different question. I think, I think that we would still have planetary bodies. I don't think that they would. It would be an obvious difference in materials, because it would be the strongest magnets being attracted to each other, or perhaps repelling each other. But it would be that magnetic material being at the base level towards the center, and then less magnetic material towards the end, just because the more magnet is going to push the other out of the way. So I think everything does change, but I think you still end up with spheres in some capacity.
May I
As
ask you
far as
something
like
about that, Bio?
gas planetary bodies, I don't know what would happen then if it was.
Let me ask you something about what you just said. Do mass has a stronger attraction than magnets?
The gravity is going to be your weakest force by and large. If it was 1-to-1 materials, gravity would be a
Gotcha.
weaker force.
So why don't we have a universe of magnets?
Because you don't have
magnets
enough.
are
You don't have
stronger.
enough material. You don't have enough material to do that.
Well,
Oh, so
it's
you know
because they're
how much material is there in the universe of like magnets, huh?
Silent.
two
These things are
different forces,
quantified.
man. Yeah, magnets have a relationship where their charge gives them strength, and their distance, their distance is same way as gravity. But the other biggest difference is that strength. Two magnets will lose their strength a lot quicker than gravitational attraction. So if you have two magnets that are like across the room from each other, or across, like a far enough, close enough distance, and not that strong enough charge, they're not going to be enough magnetic attraction to even bring them together. So I think if there's no gravity at all, I think that more things would be repulsed. Like there would be some spherical objects or whatever, but mostly everything will just be magnetically.
The interesting about magnets, right, is that only solids can be magnets. Gases or liquids cannot be magnets.
At the most pedantic level, they can have an attraction or a repulsion, but that would be that's why I'm saying with analogous to gaseous planetary bodies or gaseous sun stars. I don't know how that would form within.
So at the moment of the Big Bang,
instead of a presumptive cosmological creation concept that things are clinging to spheres, we could actually look at what actually happens in nature and in electric fields, which would be the actual field itself is what is in motion, and there's the dielectric plane at the center of that, the dielectric inertial plane, and then the centrifugal and centripetal forces create essentially the energy is going from above, the top of it, as it were, down to the plane, and vice versa. So there's actually a centrifugal and centripetal relationship between the outside of the actual sphere and the dielectric plane in the center. And so that's something that we actually can recreate and can observe directly. This concept that things out in some vacuum are clinging into balls is literally completely an assumption, and there's no indication that's occurring.
I posted a video in chat that's extremely interesting because it pertains to exactly what we're talking about. What's occurring is that they're levitating a magnet and they're putting a ferrofluid onto it, and you can see where it's poured and you can see how it's forming. And this is why I'm saying if you have a strong enough magnet and you have enough material, it will form a sphere. From these tiny, tiny examples, we can see, despite the liquid being poured on top, it finds its its path of least resistance. Meaning, if there's a part of that magnet that is exposed, rather than being covered by ferrofluid, that ferrofluid is naturally going to envelop that area because that is the path of least resistance. And these are different shapes throughout the video as well.
The problem, Bio, is this: right? It won't.
I've never heard before. This is something I've never heard before. Branch, sorry, if you want to say something, you can. But I just so you're now making this is wild. This is just like, okay, you're now making a whole description about magnetism clinging things into a sphere Earth as like a backup plan. Like, what is this right now?
It's no. We're so the initial start of the conversation was just hypothetically without gravity, what would happen? And I would say magnetism would probably rule
wasn't
the universe in this way. And all I'm saying is that because gravity and magnetism are analogous, this is a perfect description in which if you have the source of a force be the center, and it's attracting, you know, bits of material all around it in some way, such as magnetism, ferrofluid, then what you'll have is a naturally forming sphere because of the equal potential of energy as far as to the source of this force. So with gravity being right in the middle, magnetism in this example is right in the middle, and we could see these sphere shapes forming.
Bio, I gotta disagree with you, man. Look, magnetic fields, they're not spherical. They don't have an equal pull to the center.
No, I would agree, not perfectly, no. But I wouldn't call the Earth a perfect sphere.
Well,
but
it's
I'd still say
actually
the word
pretty
sphere.
freaking lopsided, right? Because every magnet has a north and a south pole, and basically what the field lines are doing is they're going from north to south. So, you know, it's essentially going to be an oblong kind of. It would
Slightly, sure, yeah.
definitely not be a sphere.
I mean,
No,
it
not
totally
perfectly, but
depends.
it will approach
the
it as a
attraction
sphere.
the attraction of a sphere is that it's the most efficient. So in some situations, it would be the result anyway. You know, with or without gravity or magnetism. I mean, there's many different reasons why a sphere could be formed.
It's like, okay, so, you know, for example, you know, if you take a spherical magnet, right, and you drop a whole bunch of iron, or you basically drop it into a bunch of iron filings, or even ferrofluid, and then you pull it out. Iron filings probably work better. Then where do you expect the iron filings to fall? They'll fall on the poles, right? They wouldn't fall on the sides of the poles, because they're basically going to be attracted to either the north or the south.
I understand what you're saying. The most amount of attraction would be at the poles, sure. But it's still going to form a sphere. And if you look at the video, it's about 2 minutes. They do use a spherical magnet, and then they pour the fluid, and you can see the first little bit that gets dropped onto it. Yeah, the what we would call the north and the south poles of it do get the liquid first. But as they pour more, you can see that it envelops the entire thing, and it seems pretty even, and it seems to have some type of spherical shape. And it's not perfect, and it's not a perfect analogy to gravity.
The problem with ferrofluid is basically ferrofluid is a bunch of iron filings suspended in a liquid. All right. It's not magnetic liquid. So what you're not seeing when you look at ferrofluid is the fact that most of those iron filings are still on the north and the south, and like basically if you look at the picture that you're shown there, the whole black liquid on either side of it, the reason why there's no spikes is because there's no iron filings there. Well, there's very little iron filings.
Yeah, but Branch, the one thing,
I hear you.
the biggest difference is you have to have the poles of the ferrofluid aligning with the poles of the magnetic field. You know, whether it's north or south or, but find
yeah, I mean,
distance,
magnetic field,
the strength, whatever.
I think you're cutting out, Kosho. At
Yeah, I
least you were
couldn't
for
get
me.
that, Kojo.
Yeah, but just because magnetic field, I mean, I was just talking a minute ago about magnetic fields and the spherical nature of them. So just because those exist, and because you can do that with magnets and create these kinds of structures, we all know you can. And, you know, things like raindrops exist, etc. However, the Earth is not a magnet, so why would it function that way?
So
I disagree with that.
So it's just an analogy, but it's just explaining that if where your force is coming from or originating is the center, and it's attracting bits and pieces somehow in any way, whether it's magnetism, gravity, whatever, the most natural shape that it will form is a sphere due to the many reasons given. That's the specific point.
So because magnets can be formed in spheres with condensed metal and then attract a fluid that's also metal to create a spherical structure, you then make a leap and say that everything else is doing that?
No. The extremely specific point I'm making is that if your force is originating at the center of an object, as you add materials to the object, it will naturally form a sphere. The reason why I provide magnetism is because I I would provide mass tracking mass and perhaps Jupiter's moons, but you don't accept that. But magnetism is pretty, it's easy, and we don't disagree to it, and that's explaining the principle behind what I'm presenting.
Come on, man. You're making an attribution. Like there's bubbles in my soda, right? I mean, like there's a lot of different reasons for what you're talking about. You're saying that as an anecdote, like okay, a mass attracts mass and it forms a sphere. Like you're basically attributing, okay, well, like okay, my bubble could be a sphere. It has nothing to do with mass attracts mass. You know, like
No, but
there's like a million
your
different things.
bubbles,
Dude.
your bubble's a perfect example. I was actually going to use that same example because that's
No,
if I'll
another
do a
one
full,
could be surface tension. Oh, look, there's a drop of water. Turns into
no, but
a
it's not about
sphere.
what's causing it. It's about the fact that the equal potential when you have something emanating from a source, whether it's acting outwards or bringing something inward, with the equal potential from a source, that source is always going to create a sphere, at least as the most efficient. If it's able to become the most efficient.
Yeah, it has nothing to
Yeah,
do
that's why
with
bubbles are
gravity.
created like.
It has everything to do with nature.
We're explaining nature. You're right. It has everything to do with nature, but we're explaining.
Yeah, but you're trying to attribute gravity to it.
Are you
and then
saying
say
that gravity is
nature
not
makes
part of
spheres
nature?
Works the same way is what we're
because of
saying.
gravity.
No, not because of gravity. Gravity is one of these things that also works the
So
same
what
way
came
as
first? Nature or gravity? Spheres?
No. Hold on. Are you separating gravity from nature?
I don't know. Is that what you're trying to do?
No, obviously not.
Are you trying to join them together?
We're trying to explain nature using this phenomena that we have validated and measured, and we're explaining nature with gravity.
You haven't
we're just
validated.
saying gravity.
You're kind of
Gravity
asking
is
what
one of the things that
came first, the chicken or the chicken?
Yeah, a bit. I mean,
Moss came first.
No, it's almost like
Did
it's almost like
nature's
asking
most
what
efficient shape come first, or did gravity come first?
it's almost like asking what came first, the chicken or the chicken's beak. It's
Exactly.
like, well, it's they're the same thing. You're just explaining one part of the entire thing. I wouldn't call one
Chicken
before
and
the other.
chicken's beak? No.
It's the cause and the effect.
Yeah, I mean, in the default cosmology of all of humanity, it often is rooted that everything comes from the center. So, in terms of that, the North Pole and whatever is at the center of this whole world, it's interesting. Everything circles around it: the sun, the moon, the stars, and then Polaris. So there's certainly something to that. And but this idea that actually everything is coming out in a spherical fashion, as it were, meaning that, like, well, let's say the core of this sphere would be in the center. There's a plasma sphere that it has expanded out to create the physical world, and then the plane, like the inertial plane itself, is where all of the land is coming out, and then the water creates that midpoint. So you have land under the water and land above the water, and it's all emanating from the center. So in that way, it's almost the opposite of things clinging to a sphere, and actually it's more of an unfolding or a growth. Now, not necessarily expanding into infinity, because they take that concept in heliocentrism and they spin that into the infinite space idea.
I need a translation, unless somebody wants to explain.
Yeah, I'm not sure either.
We kind of jumped from some abstract ideas to like a total
Toroidal
specific flat Earth
vortex.
cosmology.
Geo does have an interesting perspective on flat Earth, though. I just don't think that we fully understand it, which is why we probably didn't really understand what you just said, Geo.
Well, it's how I relate the spherical nature of the cosmos is my in terms of how I understand how a sphere does exist within this whole system. And so we're talking about spheres and gravity and things clinging to spheres and magnetic fields. So I'm just describing from my perspective, there is a spherical magnetic field that is spinning that surrounds us. And then I was just talking about a lot of these ancient cosmologies that have these different creation stories of everything emanating from the center, which also is connected to the great world tree concepts as well.
Naked. I am naked. Testing. My mic works. Yes, no.
It seems like in this heliocentric model,
Okay.
they absolutely want to make the Earth on a limited sphere. They want to make that thing spinning, and then they want to convince everybody that you're one of these little balls within, spinning spheres within this heliocentric world. I just think it's a profound inversion of reality that has very kind of a dark energy to it, actually, like fundamentally inverting the geometry of reality to convince people of something that isn't the case.
That's just gibberish. The whole body of science, Gio.
Well, it started out with the false premise, and then it was perpetuated with funding for contracts and shit. Follow the money.
Just provide the evidence, man.
Well, whether somebody's personal cosmology is a spherical type structure surrounding a plane or not, either way, there still needs to be some motion that's happening. So if we're stationary, then that motion is the sky or something that is above us or surrounds us. Whereas on the globe Earth, yeah, they put the whole thing onto a ball and then make the outer space and then make the ball spin. It's pretty opposite concepts, really.
You're right, and only one is supported by evidence.
Oh, like such a thing as nothing?
Yep, good addition.
I'm not the one claiming it.
Fantastic, man. It's good.
Good job, Riggs.
I mean, I don't know about you, Bio, but I'm like I guess you want to like maybe defend or like push this globe Earth idea, but I guess in my mind it's just such like old news. Like it's kind of boring to me, really, because I understand the model and in no way do I think it's reality. So I'm much more interested in actually exploring ideas, concepts, possibilities, and figuring out a way to actually be able to get back to where we can have sovereignty on the Earth and be able to explore it freely, rather than just going back to this false model and just looping it in circles. It's just uninteresting to me.
Right.
I agree.
Reality
I
is.
agree. Well said.
Oh, never
well
mind.
said, mate.
Reality is quite boring sometimes, Gio. You're right. It would be more interesting to make shit up and explore those ideas without evidence. I agree, 100%. That sounds like a fun time. But if we're going to discuss reality, then that's going to be separate from all of that.
No, the reality is it's the realization that you're a slave in a system that's devaluing the human race and making life difficult for the animals that are on this earth. That's the reality, really. That's the main thing. Then you've got to get on with that. And then the flat earth is a release. It's the key to like opening the door and taking back your freedom. That's what that's all about now.
I got a question.
Yeah.
If something's in motion, right, and something is not acting on it, does a bear still shit in the woods?
No.
Oh, it certainly does.
If there's no force on the shit, how's the shit going to come out?
It's going to come out because
And
it's
it
going to be
depends if the bear's still alive or not.
Yeah, because he'll eat the food and it's got to come out somewhere.
Oh, the bear's alive, obviously.
Yeah, and it does consume food, obviously. But yeah, Gio's right though. Gio is right in his last statement. He said he was bored of this, and he's looking to solve the problems. How do we move forward? Is what he's saying.
Exactly. Yeah. No, we're definitely got to keep it moving forward. I mean, I think the globe discussions can still be useful because a lot of people aren't aware of this discussion yet. So I think that when they're able to hear all the different sides of it, it's very be more clear for them to see. However, the kind of individuals in this community that want to just like loop in circles with it and just push it, it's the pushing that's also just unproductive as well, just in general. So I think there's a difference between discussing ideas and when people get into forcing or pushing their particular globe idea. It's like a different energy.
Yeah.
Yeah,
One is made up and one is validated. You're right. Completely different energies.
Yeah, I mean,
that's
at this point, Bio, you're just pretty much heckling, so it's kind of just toxic. And
You're doing the same thing, Gio. I'm responding in kind. If you don't like my answer, that's fine. I don't like yours either, but I'm still responding in kind.
It would be great though if a different theory of how shit works actually was derived through these rooms, one that doesn't have a million holes, right? The problem is that, you know, most flat earthers, when they do present their ideas, they're just full of holes. And, you know, instead of
that is a fabrication. Objection.
Jin, can I
Your
finish, Jin? Can I just quickly finish?
off.
Because I may answer your question just by finishing, right? The problem is that when somebody points out one hole, instead of trying to come up with a reason of how to fix that hole, people get extremely defensive.
Well, you're not answering my question. I'm just saying objection. Okay, carry on. Go on, Gio.
No, you go ahead. You started first. Go ahead, Jay.
Oh, sorry. Yeah, thank you. Yeah, I was just going to say objection because we present the truth. That's what we present when we present the flat earth. There is not one shred. Listen clearly. Those of you who are listening in the chat room, on this server, there is not one shred of evidence for this globe. Not one shred of evidence or proof. We don't experience it. So don't say it's our flat earth is full of holes. It's all we experience. Okay? Thank you. I step back.
Yeah, but Gio wasn't talking about the globe Earth, right? Gio was talking about coming up with a model, if you want, a flat Earth model that actually works, that doesn't have holes, right? And
we don't need a model.
Well, yeah, I mean, so I mean, the name of this platform is Earth Awakenings, and I, came to that term, those words. However, I feel like when it's not as if I necessarily invented it. It exists in some way beyond my consciousness, and I just sort of came to me to use the name for this particular platform. But in that sense, in my viewpoint, the way that it came through to me is that indeed the Earth is not a globe. So there is an awakening happening, a very real awakening happening of humans figuring out what the Earth is, perhaps rediscovering what the Earth is if our ancient ancestors had it correct as well, and their knowledge and wisdom, and possibly even advancing it. So in terms of that, the globe Earth is not the case in my viewpoint and in many of ours. So that one's just sort of like we can still discuss it if needed, if other people want to discuss it in a sense. However, the awakening in my viewpoint is the actual understanding and process of humans coming to what actually is the truth of this reality.
Yes, that's it. Exactly.
Yeah, but when you guys say model, when they say flat Earth model, they're referring to what, like the heliocentric model is for what purpose, really? For space travel and a map of, a 3D interpretation of a map of a galaxy, of a world. The model in the flat Earth doesn't have this, like my understanding of what I understand the world to be is enclosed, encapsulated within a closed space. It's not this endless modeled universe of exoplanets and exogalaxies with plasma everywhere. It's just an enclosed container. So how do you model something that doesn't have these outer rings and outer circles? Like what are you modeling for? Space travel?
The flat Earth.
Exactly.
Not the galaxy.
You're not understanding. You're not understanding the exercise. The exercise duo. The exercise duo is philosophy inside the mind. If you want to have a model or representation, what is the model for? The model
for testing purposes against reality.
Hold on, but it's for that reality. So if your reality is to go to other planets, and other planets have this particular pathway, you're going to create that reality, and therefore you're going to write it down. See, flat Earth doesn't have that reality. It isn't about these concentric elliptical path orbits with rings around them.
We agree.
Everything's enclosed. Everything's enclosed within a containment, right? So you can't really represent that as a model that you can go to and be exterior of.
We're not talking about the exterior. No one's mentioning the model of the exterior. We're mentioning the model of the Earth.
That's what the heliocentric model is. There's this
I absolutely agree
exterior.
with you. You said a lot there, so let me jump in for a second. Dude, you said a lot there. That was awesome. And I totally agree. And what I was thinking when you said that is that a sculptor, when it creates something, has some medium that it's sculpting. So it has whatever that is, that medium, and then it sculpts out the universe, as it were, whatever that thing is. So in the same way, like whatever this whole world or universe is, that's how I see it as well. Like it's essentially sculpted within a medium, within a structure of some sort. Whereas what they've done with the globe Earth model is they've made our globe just this tiny little ball, and then claim that there's just this infinite vacuum. It's a very different concept, because in alchemy, the whole concept of alchemy is you have the vessel, and then that's where the life and the transformation exists, is in the vessel. So they took that vessel and they just inverted it and completely used a demonic energy to invert it.
Data, I'd like to respond to you. We're not asking for one-to-one replacement for the heliocentric model, the solar system, the galaxy universe. That's not what we're asking for. What we're specifically asking for is what analogous to what Gio said just now, the globe Earth model. We're looking for the flat Earth model, not the flat Earth galaxy.
Yeah, I know, but what you're looking for begging the question representation of a philosophy, because at the end of the day, I can't get outside of the reality that we're in to actually prove that reality. What I can do is look at my reality that I'm subjected to objectively, that I'm in, and deduce that it's stationary. There's no curve to it. Okay. Now you're asking me to quantify my field of view, which has been done through Euclidean geometry. The sextant and the astrolabe are representations of perspective.
Why are you using models though?
So no, those aren't models. Those are actually, those tools are derived directly from our perspective, our reality.
Yeah.
So that's
right, there you go. Yeah,
right?
that's my claim for the globe Earth model. Sure.
I know,
Well,
but you're
Bob,
asking
but you're
hold on. Every heliocentric representation is exterior. You're always outside of the model to see it. I'm saying that you can't step outside. There's no outside. We are inside of that whole thing. There's no outside of it. So you wouldn't be able to represent these galaxies of cylindrical shelves properly because of what we're seeing for the limited viewer that we are on a massive plane Earth, right?
No,
So
I get that.
You can take our
Bio,
vision.
let me just say this real quick. Hold on. So Bio, like just tagging on to that, like if the Earth indeed is not a sphere and it's not spinning, and it is a planar surface, and you're right along with us, like meaning you were born in whatever you were, 1970, 80, however old you are, and you were taught the globe Earth, and it's a lie, and you know it's a lie. Why would you expect? Because at that point you would be the same as the rest of us that have figured that out, and unless we have tons of money and can do research projects and and so on, how would you expect that we would have some perfect model of the entire Earth?
How would I expect these really smart people who validated that billions of people are perpetuating a lie? I would feel like those really smart people would find a way to be able to do all these things. But specifically to respond to Flat Earth Data there, we're not asking for a galaxy model.
We're literally in phase 1 or phase 2. We're just
Look,
getting
man,
started.
if you want to have a legitimate conversation, let's not overtalk each other, right?
Yeah,
Flat
but
Earth
what's
Data,
the model
what I'm requesting,
So I'll give you an example.
You talked for like a minute and then Gio had 30 seconds. I'm just trying to respond to specific points that you were made. That's all I'm trying to do.
I understand. You're not looking for a galactic.
I mean, I don't know if I'm muted,
Go
but I appreciate
ahead,
it.
dude.
I appreciate
Go ahead.
it. So the specific thing is that we're not looking for a one-to-one analogous of the galaxy. We're the most specific way I could put it, and the most easiest I think would be a flat Earth map of the United States. That to me sounds unbelievably reasonable given the amount of people who are flat earthers around America. The collaboration, I think, would be easy to do that.
The case may be, dude. I mean, most of us, you know, we all grew up, we lived our lives, you know, in our local cities. So, you know, people travel, obviously, sometimes you get a chance to go somewhere else, but it would be a real project to start. Like, if you just threw out all of what NASA gives, all of what government gives, you know, just right out the window, said, you know what, I'm not going to trust any authority that's run through the government. Let's just say you're going to make that simple thing. I'm not going to take my cosmology from anything related to the government. I'm going to figure it out myself with my friends. If you're going to do that, that's awesome. But that is going to require an enormous amount of resources and energy. Now, the community within these last, you know, 7 years or so has done a tremendous amount with the resources that have been available. And perhaps there'll be bigger breakthroughs in the future, like when, you know, millions of dollars of resources can be available. But at the moment, we're all doing what we can to do all of this. And in terms of mapping the entire Earth, yeah, that's a huge, huge undertaking that I think is awesome to do. But the idea that, you know, folks like you and I just that are living our lives would be able to do that, yeah, possible with a lot of resources and time and money, but we're all living our lives, and so we can only do what we can.
So Gio, there's I see there's a lot of denialism going on, right? So, you know, for example, Biodual, he did a whole experiment proving gravity, right? That same experiment could be done by a flat earther. But what I haven't seen is a flat earther, you know, recreate the same type of stuff that Biodual did and actually show that it doesn't work.
Yeah. What example are you referring to there, Branch?
Sleeping
Your
Warrior
Cavendish.
did Cavendish. Sleeping Warrior did it.
Yeah. Okay. So you did the what you circular reasoning,
Wiggling
Therefore,
balls.
I saw attracting balls, therefore mass attracting mass. Like that's.
Oh, I didn't use balls.
experiment.
Yeah, wiggling magnetic balls. Believe it or not.
I didn't use magnets and I didn't use balls. So.
But I mean, Branch's assertion was that no flat earther had done it, and I could just point you, Sleeping Warrior
Yeah.
did it.
So,
but
yeah, I also did it, and I did it with different weights at the end of it. It doesn't matter the oscillating pattern that is there, even if you weight for the
Hey, Biodual,
natural.
have you seen Sleeping Warriors?
I have
Cavendish?
not. No, I have not.
No, no,
You're using an oscillating pattern that's already there to begin with.
I'm not.
And then
I'm
you're
not using an
going to-
oscillation pattern.
So it's already there, right? The mechanism itself oscillates, whether you like it or not. It's already there, whether you have weights at the end of it or not. You hang a bar, it will oscillate. So that the fact that air is right off the get-go, and you say, well, the solution to that air is we'll just wait. We'll wait till it's still and stop moving.
Correct.
But
yeah. Wait for it to come to rest.
Yeah.
Yes.
Yeah.
Everything
At the end
is in some motion.
Yeah.
Yeah. Everything has
It's
some
just-
motion to it.
It's just, yeah, you're waiting for the tension of the downward pressure due to the density of the object pulling on the string, right? So
there's a
energy
there's a
in it, right?
rotational momentum, and I'm waiting for the energy within that rotation to decrease enough in which the movement is not detectable with a 10-foot radius.
Yeah.
So whoever
you've seen the mice experiment on the two rods, right? Where the guy moves the two mice around.
No, I was speaking to my experiment.
Seen that? Yeah. Well, I'm just saying your experiment has been applied to other things, right? And the two mice at the end of the rod, and using magnetic energy to push the rod back and forth, right? So the fact that you want to use this example is beg the question: what a 100 and I don't know how many year at a date bullshit gravity that you're trying to use when there's alternate examples of how you can make the objects move, and it's via magnetism.
There's a lot of ways to make things move. You're right, but gravity is one of them, and that's what I'm validating within my experiment.
You're not validating anything because you're not separating the idea. It's not magnetism is the point, or dielectric magnetism, or whatever you want to call whatever superlative you want to use to describe the action or function or mechanism. The point is
Yeah,
that
I mean,
it's
we've talked
happening.
about it. Yeah, we've talked about it a million times, though. I mean, the Cavendish. I mean, to make an assumption that it's mass attracting mass again is just an assumption, because what you're observing is the movement of metal within the environment, or what I would say the ether. So there's a medium that's existing within, and that would have to be considered to actually look at it in a fair and balanced way, in my viewpoint.
Did you ever do it? Did you ever do it with turkeys? I think it was doing.
No,
it with
not
turkeys.
yet. I want to soon. But no, that's why
You should
you
do it.
you would
You should
that's
do
why
it,
you would
Brent.
put. Hold on, man. That's why you would perform this experiment with the external masses flipped around. You could do them upside down. You could put them on either side of the masses, because let's say it was this type of if you subscribe to an ether drift, this drift would occur in one direction. So perhaps performing it in one direction consistently isn't good enough to invalidate that proposal. So you would place the masses on the other side. When we have a different rotational deviation, not an oscillation, when we have a rotational deviation in two different directions, depending on where that external
Still
mass
gonna
is, we
deviate.
can invalidate some things.
It's still
I
going to
mean, I
deviate
personally
because
think.
the actual pattern is there.
Hey Fed, I personally think this is super productive, right? If we talk about the next experiment that Bioju is potentially going to do, you know, maybe we discuss this with you guys, or he discusses this with you guys first, and make sure that he does it in a way that you guys will be happy with the results. Instead of, you know, coming back later and saying, well, you should have done this and should have done that. Why not do it ahead of time? And that way, when he does the experiment, everybody can, you know.
There's no way to rule out the magnetic or dielectric energy, any of that stuff during his process. He's using something out of date and begging the question.
This is, I mean, Branch, this is an open research community. So yeah, people can do their own things, but it sounds like you're trying to pit people off against BioDuo, which I guess that happened on another server as well. I don't really see any benefit to that. BioDuo is free to do whatever he'd like and come to whatever conclusions he'd like, but there isn't really like any invitation that people are making that BioDuo needs to do something for anyone.
No, I don't mean that. I mean that, you know, Bioju is going to attempt to do a Cavendish with, if you want, organic materials. And some people say at the same time, but so, you know, that's his way of negating the things that were said to him earlier, which is, well, you used metal balls, which is why it's a problem. So, you know, if he does decide to do this, if he does do this with organic materials,
happens with paper balls too.
And that's an organic material, right?
Yep, you can make it move back and forth with paper balls.
So if he, let's say he does the same experiment he did last time, but now he does it with turkeys, right? Why would that?
Do it with
what would be the explanation? Because people were before saying, well, magnetism causes it, stuff like that. But if he does it with turkeys,
what I think is happening, and it may sound, yeah, I'll just share what I think is happening, which is that the ether itself functions in vortexes. It's the Fibonacci golden ratio thing I was describing before. It's basically fractal, like ether drift is actually fractal vortices, which is actually what Bob Nodell from Globebusters has mentioned as well. So I think him and I have seen that the same way, because when I heard him say it, yeah, like, anyways, so he has said a similar thing in terms of why the ring laser gyro. So that, yeah, so basically there's vortices of drift that are like vortexes, that is what the ether is made of. So you're going to get
you're just talking about gravitational waves now.
It's the magnetic
talking about
field.
gravitational waves.
Field. Like, it's the actual vortex of, hold on real quick. It's just, I'll finish real quick. It's the vortex.
can we let Gil finish, please?
Hold on 1 second. Let me just finish the thought. Yeah, so there's, the idea here is that there's actual vortexes within the ether that are creating the ether drift, and that is connected to the sun and the moon drift as well. And those vortices are what create the pendulum that does its precession, and this Cavendish component is why those things are doing that. Yeah.
So it's like the path of the sun. It's creating a the path of the moon in conjunction create a well of magnetic energy above the Earth, and as it moves, there's a well, like a dip in between.
Yeah,
as it's
that's a
moving,
cool way to
right?
see. That's a cool way to describe it as well. Because on that, macro level, the sun and the moon and the stars are and the wandering planets are all making their frequency vortices. They're making their spirals. Yeah.
Yeah, I didn't find any of those deviations when I ran it for 28 hours.
Well, what I'm suggesting is that the reason that you're getting what you're getting is because the ether medium itself has its features to it. And so if you use metal or just whatever compounds you're using, it's going to be connected to that, which is why the pendulum shifts directions during
If that was
eclipses.
true though, then if you had the identical same weight, same string, same pendulum apparatus, that they should sync up if dropped at the same point to the same place. That wouldn't happen though, would it? They would deviate from each other as well, correct? So if you're setting up a pendulum experiment and you had both apparatuses at the same position, at the same angle of release, are you telling me that they would oscillate exactly the same pattern?
I'm not going to continue with you on the Cavendish because it's not an oscillation pattern that you're measuring or detecting when you're doing this torsion balance. I know I've said it before many times to you, and I'm saying it again now. You're not measuring an oscillation pattern. You can make mathematic predictions as far as where the resting point is, or perhaps the masses that you're using. You can derive that. But as far as when you're making these measurements, you're doing this when it's at rest, when it's not oscillating. If you're making measurements or conclusions while it's oscillating,
I understand
you're destroying the experiment.
You have an apparatus that already has a default air in it. And for you to justify using that default air is to say, well, I'm going to wait for all of the apparent motion of it to leave, and then I'm going to start measuring the deviation between point to point.
But to a certain extent, sure.
This to me goes when I see this, I'm like, first of all, the apparatus has an air built into it, which means it will oscillate back and forth. In other words, it would cause a deviation. Now, how do you know that? Well, the apparatus, you have to wait until it's done. That could be an hour. It could be 45 minutes. It could be 2 hours. It could be 3 hours. The point is, you have to wait. And how do you know at that point? How do you know at that point? How do you know at that point it's completely ready to go? You observe. You say, "Oh, there's no more apparent motion. Now it's time to measure." Like it's just to me, it doesn't sound
so
like
let me explain
science.
it. Let me explain it because I did do it.
It doesn't sound like science at all. It sounds like an
of course
ad
it does.
hoc explanation and a contrived observation, and then a mathematical manipulation based on the observation. The reason why I say that is because if you have two apparatuses side by side, and you set them up exactly the same time, two crews working together side by side, both let them go side by side at the exact same time, they would not stop oscillating at the same time, and the deviations wouldn't happen at the same time. In other words, whatever field force, whatever gravitational whatever effect or mechanism is causing these points of deviation, you're trying to measure that mechanism and claiming that mechanism is gravity, when those two apparatuses would act independently, showing that the effects are not the same.
I literally ignored the second half of it because I'm trying to make I'm trying to specifically respond to your assertion of it would be irresponsible scientifically to wait for them to come to rest. The reason why you wait for them to come to rest, or at least an apparent rest, in my case, a 10-foot radius laser light. Of course you did. You called it ad hoc and unscientific. So anyways, I'm going to continue the same way you did. So as far as this coming to rest, of course you allow it to come to rest. If you have momentum still been built into it, or perhaps your air conditioner is on and it's causing the movement, you're fucking up your experiment from the get-go. But if you allow it to come to mass, use a 10-foot radius using the light, you can see the tiny, tiny deviations of motion. If there's still apparent motion, you don't continue with your experiment. You wait for it to come to rest. Then you make your mark. Then you would introduce the variable that you're testing. If you want to use a magnet, use a magnet. I want to use a non-magnetic material and put it close to it. And
how do you measure
it
it without affecting it again? When it's come to a standstill, how do you come to it without making it move again? Like,
No,
is it in a
you're right.
room
This
and
is
you're
your
looking at
baseline.
it from a distance, or
This is your baseline without masses. You're just allowing it to come to rest without external masses. There's nothing that you've introduced to the experiment yet. You've only set it up.
You're walking up to it to measure something, right?
It's in a chamber. Mine was in a chamber, a vacuum chamber.
And you can predict the amount of attraction.
You got all kinds of stuff going on in that field. Yeah, I mean, just the wires in your wall are creating electric fields, even just in the house that you're in. So there's all kinds of stuff going on within that environment, fields, and basically you're just picking up on a wiggle. And yes, things will wiggle if they're dangled. They'll wiggle because there's always some motion in the medium, like, of course, the air and the actual weather that we live in as well on the larger scale, but there's definitely movement in that medium. To assume that that's mass attracting mass is literally just a complete leap of logic based on an observation.
There's a complete leap of logic in which you think that I'm done yet. That's your leap of logic right now. So yes, Omni, in this moment, when it's come to rest without introducing any external masses, or perhaps your experiment magnets, whatever, when it's at rest, you just make a mark as far as where it has come to rest. And because mine is in a chamber, I could walk by it all I want, and I'm not going to cause an apparent motion to that pendulum. I could bump the chamber, sure, and I'll fuck up the experiment. I'll have to restart. But anyway, it comes to rest, and you introduce your external mass to the outside. You don't bump it, you don't push it, you don't do shit to the chamber or the apparatus. Yet, as soon as you introduce it, you start to see an oscillating pattern. But you're not done yet. You wait for it to come to rest again. What you'll notice is a deviation from your original rest point. So if there's, let's say, a tetherball, where if it's at rest, it's hanging vertically. Now you provide a force by lifting it and hold it there. The reason why it's in a new resting point is because there's a force present. When you remove your hand, you're removing that force, keeping it upright. Now it's going to go back to its original resting point. That's essentially what you're doing here, is introducing a force, in this case mass, and you get a deviated new resting point. It's not a wiggle, it's not a pattern, it's just a new point where it rests because there's a
Has this been
force.
tested over the span of, say, like a year or 2 years?
Yeah.
So you can have
Blue Marble has I think he said he's over 500 hours of footage. I think he's done it over 3-4 years now, something like that. But he's got like 500 hours of footage.
I mean, in my viewpoint, I'll just speak for myself. There's no conflict in the observation of these devices. So I'm saying for myself. Other people might claim that it's not doing that. However, first of all, it's not consistent. So that's one component to it. That's a whole other topic of it. But
yeah, that's why I was asking how long it.
Yeah, but the larger question is what is causing it, and that is where, because that's at the thrust of what you're trying to say it's proving, which is quote unquote mass is attracting mass. That's your end conclusion, that you're trying to claim that this quote unquote experiment, which really it's just an observation of a device. But anyways, that's what you're ultimately trying to claim that it's doing. So that's at the crux of it. Like the operation of these things, at least in my viewpoint, is not. I'm not questioning that. I am questioning the consistency of it. I'm also questioning the other factors in the environment and the way that it's set up. Absolutely. But
oh no, that's legitimate. That's legitimate as far as what you brought up earlier. I should have addressed it, and I wanted to. Yeah. There are electromagnetic fields within your house as far as your wiring goes, as far as nearby objects. All of these.
Here's an issue.
All of these do exist within it, but that's another reason why you let it come to rest. So if there are these fields that do exist around it, by it coming to rest means that all of those fields, all those interactions are now not causing it to do shit. It's come to an equilibrium due to everything that's acting on it right then. That's another reason why you let it come to rest.
So if this was true, And if it was an effect that was actually true, that means that it would be in the pattern, let's say, it would be, okay, for instance, each radio frequency or each star has a frequency, let's say, a pattern to it. So in this case, this particular effect should have a pattern to it. In this case, you're measuring an oscillating pattern is what you're measuring after the energy from the setup has been dissipated. Really, that's what you're saying. It's like, well, I fucking set the system up, I moved it around, I got to wait for all that potential energy I put into it by touching it, and moving it, and letting it stop. And, it's putting some tension here on this apparatus here. It's putting some tension here. That's got to settle out first. And now you want to bring in 2 extra elements of electromagnetic frequency or magnetism and all these other elements on top of it.
You gotta wrap up at some point. You're just going on and on. You gotta at least stick to some succinct points.
I'm saying the apparatus itself has a default error in it, which is if you're hanging an object off of another object, there is going to be a tension. In this case, if it's steel on steel, the metal is going to fatigue. It's going to have energy into it because of the density of the object putting pressure on it. That's going to cause an error to the device. So anybody to think that this device would be a tool to measure anything accurately, to me, is ad hoc.
Okay.
Personal incredulity. Go ahead, Branch.
So Gio, you're saying that you're thinking the reason why the stuff moves is because of the ether, right? So let's say he does the experiment one time using, let's say paper balls, right? Something with a set volume and geometry, right? Then he does the same exact steps using something that has a greater mass, still the same volume, same geometry, right? So the only thing that's actually changed here is the mass of the weights that are causing this. Right? His actions of performing the test and everything he's doing is exactly the same. It's just the
Branch, are you predicting the rate of attraction?
Well, hold on though. I just want to see what Gio has to say, right? So, Gio, if the only thing that's changing is the mass, right? How could it? And let's say that when he does the experiment, it shows that there is a difference because of the mass. How could that be explained by the ether causing this?
Well, I'll just be brief because I know other people want to get in as well. I'll just say this briefly, and this is just my viewpoint as what's going on. So, mass, what we call mass, has an electrostatic charge to it because of the nature of all things have some electrostatic charge, and the mass itself is not attracting other mass. The electrostatic charge is working within the system of the ether. So the ether is the medium, and the electrostatic charge is what is causing all motion to exist.
Okay, so basically, you're kind of getting mass attracting mass being caused not by gravity, but by the ether.
Well, yeah, like there's an interrelationship on, like I was saying earlier, like in my viewpoint, you've got light, sound, electromagnetic, and electrostatic. So that's what matter is actually made up of. It's actually different frequencies of light and sound, electromagnetic and electrostatic. It's basically, it's the 3 main modalities of creation that make up the ether. So if you have like the electromagnetic and electrostatic, those are combined in a sense. Well, they're dualities, but they are connected. And then the other one is light and the other one is sound. So that makes the triangle. And so all physical matter is made up of light and sound and electromagnetic and electrostatic energies. So by the nature of what it already is vibrating in those ways. And then what we call matter, physical matter, is going to have its own charge in the electromagnetic and electrostatic spectrum, which is what makes up the layers of the ether. And then the ether itself is swirling. It has its own like Fibonacci vortex structures to it on the micro level, like on small scale, and on large scale, which is what causes the entire sort of flux of the system that we're in. So if you're getting something like Cavendish that's doing that, it's connected to that vortex structure is how I see that.
if you're basically
Yeah, but
saying
if that was
the-
true,
if
hold
you're-
on. If that was
man,
true,
hold on,
if
man.
that
You,
was
you
true,
keep you're not
Theo,
letting
if
me
that
and
was
Gio
true,
talk here.
yeah, but
Seriously, Fed,
listen, if that was true,
are you adding
if
to
that
this, Fed, or
field,
are you gonna go on a tangent?
Just let him ask the question, man.
Well, Data, you can go next, but yeah, let's let Branch respond. Go ahead, Branch.
So, Gio, basically what you're saying is the reason why we're seeing mass attracting mass is because the ether's causing mass to attract mass. So, regardless of how Biodrew does this experiment, it doesn't matter because in the way that you're describing it, mass will attract mass because the ether causes it to. Is that correct?
Well, no, but it's not attracting by the nature of its mass. Like mass is not attracting other mass because it's mass. Masses might have different relationships to each other due to the actual field that it's within and the movement of the field. So it's not the mass attracting anything. Just like with magnets, when two magnets attract, that's not mass attracting mass. That's magnetic fields pulling the mass together.
Okay. So I guess what we're trying to say here is that, you know, regardless of what material or how Biodrew does this experiment again, it's not going to help, is it? Because your explanation of it is basically saying there is no way to do Cavendish, and not explain it by just saying it's the ether causing things to move because of its mass.
Well, to me, it's not really about just explaining something away. Like if somebody else comes up with, if they say, hey, this Cavendish is doing this thing, therefore, and they want to make conclusions on that, I suppose they're free to do so. What I'm interested in it for myself is what is actually happening. That's what I'm most interested in. So if you have a Cavendish device and you're getting these readings on it, so there's the movement within the system, what is actually at the root of what's causing that movement? If somebody else wants to claim it's something else, I guess they're free to do that. But I'm just interested in what actually is causing it. And yeah, I definitely don't think mass attracts other mass by the nature of its mass, but the fields that are the mass and the field that surrounds it can cause this kind of these kinds of, like the precession of the pendulum as well. It's the same thing. It's the same thing that's, well, it's not the exact same thing. It's the part of the same structure that's causing that, but it's a partly different modality.
Well,
But
the precession of the pendulum's got to do with rotation, right? It's about movement. It's completely.
I'm gonna ask it over and over again, and like I don't know why people don't bring this shit up, man. Like, how much attraction is expected? How much?
It's
Depends on the mass.
It'll
Depends on the mass.
Yeah, it'll depend on the size of the masses that you're using, both the internal and external. It'll depend on the distance from the center of those objects, and it'll also depend on the torsion value of the wire that's holding the inner masses. It'll depend on
this
those.
already. I didn't do the experiment. Did you have an expected rate of attraction, and did it perform?
No, so I didn't take quantifiable measures.
Then it's bunk.
Hold on, no, it doesn't.
If the whole point is attraction in a specific way, and all you're doing is saying, well, it attracted, therefore it's bunk.
Do you know why, or what purpose my experiment fulfilled, or can I explain it to you?
I mean, what's the point of the Cavendish experiment?
The Cavendish is to make quantifiable measures of to determine a constant. My setup, my torsion balance, was to answer the question whether or not this apparatus would deviate under vacuous conditions, and it did.
Oh, well, great. You proved nothing.
In your opinion,
I mean, it proves nothing.
In your opinion,
Yeah,
that's fine.
you're saying it's
I
a
agree.
constant. He's asking you for the rate of it, and you don't know.
No, I do know, but that wasn't the purpose of my torsion balance.
Right.
So
No,
when people come in here, they say, oh, here's two paper balls attracting each other. How much attraction is expected? What is the rate of attraction? Do we observe this? Can that attraction overcome the other forces or friction involved in the observation? Yes. Like I post this shit all the time. Look at this. Okay.
Yes.
Gravity. Who the fuck was that?
The answer is yes, Riggs.
Xanax, was that you?
What could cause it? The air resistance, or the air, how much air is around it, like the medium that it's in, the amount of the density of the air could affect it as well. Yeah.
Resistance.
Yeah, there's
Resistance
air,
of
there is air
gravity?
resistance. When there's air around a moving
Yeah,
object,
and it's all calculated for, right? And you got the
How does that
expected
make
result,
sense
and
when
that's
the
how
ground
Cavendish
is
works?
locked
No,
up?
that's not how it works.
yeah.
The way Cavendish works is, hey, we see attraction, therefore. That's
No.
how it works. It doesn't
How
prove
can
the
you
rate of
have resistance?
attraction, doesn't make these correlations. It
It
doesn't
does.
show, no, it doesn't. Yeah, I'm sorry,
Wait,
it does make these correlations.
you could
It
say
doesn't
that.
prove it, though.
Okay, you could say
How
that a
you
million
having
times. That's fine.
resistance in
My
lockstep by
torsion balance, Demok 2. My torsion balance was not doing that. That wasn't the purpose for my torsion balance. I can provide you scientific papers with these
Oh, great.
highly
How
precise.
about just show me your rate of attraction? You went through all the effort to do this experiment. How many hours? You said 25 hours?
At some fucking
What
point,
was the
Riggs.
rate of attraction? Was it expected? Was everything accounted for?
At some fucking point, Riggs.
What's the
No, I
point
think
if you're not going to make the point?
What's the point if I
Well, no,
can't explain it without you interrupting?
because
Gravity is
I'll do
so weak. How are you excluding all other influence?
I'm not going to talk over you, Riggs.
Yeah, and you're not going to prove the point either.
No, I can. I'm just not going to be talked over, and I'm not going to talk over other people.
It is quite an interesting question, though. Like, do you have a predicted rate of attraction before you
Yeah,
do
yeah.
the?
There is, yes.
And you were saying that it depends on certain things, and I think you weren't finished because I was going to ask, would it not depend on where on Earth you are as well? Because the gravity is not supposed to be the same everywhere on Earth.
No, you're right, and that's a legitimate question, and that's why it's set up in the way that it is, because we understand perpendicular forces aren't going to fuck around with the forces that are perpendicular to it. So that's why you set it up vertically. So no matter where you are on Earth or the altitude, if you set it up plumb and you have it only move perpendicular to that, then it won't matter what the local gravity is.
Look at that number I put in the chat. Tell me if you have an instrument that can read to that degree. Tell me that you actually made a prediction, observed the influence to correlate or prove your rate of attraction expected.
Yeah, so
you don't
Omni,
have any instruments to that accuracy, bro.
Okay, so Omni, if money was no object, if I had grants, if someone else were paying for it, if I had a GoFundMe, I could set up the apparatus in the entire.
Shit.
At some fucking point, Riggs. At some fucking point, man.
At some point, you guys will do it once. Do it once. Show the rate of attraction once. Have a prediction. Show the attraction. Showing it doing what you predicted. In reality.
The thing that makes me laugh is like
I'm waiting.
If you think mass attracts mass,
address
right?
Omni.
How can you account for, say, like an aeroplane going over, and that's not going to ruin or cars going past your house? You know, will these masses not attract or ruin the experiment?
No.
Yeah, I mean, the thing about it
never mind.
Kind of like on tapping onto part of what Riggs was saying before. The thing about it is that you're not isolating anything. So that's why you're only observing movement. And movement, we could talk about what's causing that. So if we have a device and there's movement happening, like the way I described it from my viewpoint, that's one explanation. From there's multiple different explanations as to what's causing that. Biodual is choosing to say that mass is attracting mass. The thing is that we could talk about all kinds of different possibilities as to why it's happening. I would say there is a truth as to why it's happening. But at the end of the day, you haven't isolated anything in order to detect anything, which is what Riggs was, I felt what I was getting from what Riggs was saying. You haven't actually isolated anything, and you're essentially pretending like you are, which is what's strange.
Of course, these things have been, accounted for. And that's why we would bring up scientific papers in which they are using higher technical equipment. Of course, me funding it with my own money in my garage, I'm not going to have state-of-the-art equipment in which I can make the most.
And you're not going to prove shit either.
Fair enough on that. Can you now understand why we don't have a complete model of the entire planet stationary Earth?
I can't understand.
Jill, where's your fucking model, bro? Give me the whole complete model. It's been 6 years.
At some
there's two different conversations going on, right? And that's why Bio's finding it hard to answer. Look, here's the thing. Gio's basically saying that he gets it. The experiments you're doing, Bio, it does show that the masses are causing something to move, But he's saying that, hey, I get it. The experiment shows that, but he's after the reason for it showing it. And the other people in the room are trying to come up with reasons why, the experiment is bad. There's two completely different conversations going on. Gio's basically trying to say, hey, is it if it's not gravity, what else could it be causing this? And everybody else is coming up with reasons why the experiment is bunk.
Right, do you have a problem with that?
Well, yeah, can we stick to one shit and fucking get to the bottom of it instead of talking about 12 different things at once?
No, I think that's a good recap. I think both of those things were happening. I think it was good. We were interweaving both of those components because, I mean, that is true, though.
The point is that we're postulating this argument when we're trying to tell you there isn't one, that your shit sucks. So all the flat earthers are allowing this conversation to take place when we already know this is bullshit.
Yeah, but have you guys ever?
Well, of course, but we're trying to get them
maybe
to come to that.
No, I'm trying to let them know that this isn't something that's going back and forth. Like, this is the fucking conclusion. You guys haven't proven anything. You've made an association.
How could you come to the conclusion when the thing that
I just
you're
explained
arguing?
why.
I know that, but the thing is, talking over me is not going to make you understand it better. I don't think that you understand the argument that you're making about electromagnetism being stronger than gravity.
That you don't have instruments sensitive enough to detect the amount of influence that you guys are actually trying to postulate.
We obviously do. The problem is that you're assuming that the ratio.
I'm assuming you guys haven't done it at all because that's what I heard.
Yeah, you're assuming that the ratio between which force is stronger means that because it's this much weaker, it's going to take this impossible mechanism to measure it. When they say it's that much weaker, they mean compared to the things that you're using or that are used to create this force. And in the case of electromagnetism, it's charge. In the case of gravity, it's mass. And so there's many cases that which the amount of mass is enough to overcome.
How do you remove that is that much stronger than gravity?
It's that's my point. Is that one argument or that just
I'm
saying
gonna make
that
this crystal clear for the room.
Understand what it means. You have to understand what's meant by that argument.
I'm gonna make this very clear for the whole room, Coach Show. I agree with you.
It's not that it's too weak to be able
But
to
you're
measure.
doing a bad job at explaining.
It's not that it's too weak to be able to measure. It's
No,
that the mass.
I agree
it's
with
the
you.
mass times constant. It can make is how that force is measured. Just like the charge times the constant is how electromagnetism is measured.
I'm gonna
But
help
there's many
the whole
cases
room
which
understand because they're not hearing you right now.
The mass is enough. If the mass is enough to create a big enough force, you can easily measure it. And the Cavendish is a good example of having enough mass to measure it. So I mean, it's not impossible to measure. It's easy to measure.
All right.
It's just
So
that
what Coach Show is trying to say is that in a game of tug of war, you tie the rope to a tank on one side, and on the other side you have, I don't know, 50 football players, and at the end of that rope is an ant. He's saying that, you know what, we actually have instruments dependable enough to tell the influence of that ant on that other side of the rope.
That is nothing close to what I'm saying. And anytime
That's
I need
exactly what the fuck
somebody
you guys are
to
saying.
incorrectly interpret what I'm saying and explain it to other people, I'll get someone to do that. Otherwise, I'll just explain what I mean, okay? Because that's not all. It's not in any kind of way what I mean at all. What's meant is that the two different take the Coulomb's law. You have two charges times the Coulomb's constant divided by the distance between them squared. Okay, that's how you get that force. Gravitational force, you take the two masses times the gravitational constant divided by the distance squared. Now the difference between those two numbers is that the gravitational constant is extremely small. So that force can be, the masses need to be big, need to be a lot larger than the charges need to be in order to create an effect that's visible. But there's many cases in which the gravitational force created is going to be much larger than the magnetic force because the masses are going to be larger than the charges. So it's very easy to measure if you create something big enough to be able to measure. If you have big enough masses, you can measure it easily.
We're all waiting.
I couldn't hear what you were saying. I mean, I was in the middle of talking, so I didn't know what you were saying. But yeah, it's a very simple thing to measure. It's not so weak that you can't measure it. You know, use the correct amount of mass so that.
I'm saying it is.
Yeah, but I know, but that's because you don't know what you're saying. You don't even know what you're arguing. Like that argument, is not really. It's not a valid argument.
Dude, you're saying you're basically saying that you can
but it
measure the
doesn't.
secret ingredient in a can of Coke. All right, man.
Yeah, it doesn't
Sure
mean
thing.
much unless
I believe you.
unless you have a sufficiently low amount of
No.
charge, low amount of mass and a high amount of charge. You can make the mass bigger than the amount of charge, in which case it's actually not weaker. It's only weaker on the in a general sense. But there's many cases in which gravity is actually much stronger than the electromagnetic force in specific cases.
I posted a paper in which in two independent ways, they make high precision measurements, and they do account for a number of things. Feel free to look through it and Control F magnetism if you want, or magnets. These things are accounted for when you're actually doing these high precision measurements. You can run the experiment just for cause and effect. You could do that just for it, and you're not making measurements. But as far as the precise measurements that you do want, this is done all the time, and this is just one method. 2018, further lowering the or becoming to a more precise measurement by a number of different ways.
Okay, does anyone think that they overcame my point?
I'm not sure what your point
Hell
was.
no. The fact that gravity is much weaker.
Right. I think the better analogy, if we want to continue with this tug of war thing, would be essentially that you do have a tank, and then you have 40,000 people on the other side, and the flag in the middle isn't moving at all. So you know that the ratio between 40,000 and of something and the one of something would be equal in that instance.
I don't know if anyone's brought this up, Virgil, but Rick, you're actually invoking the wrong force. It's the strong nuclear force that holds atoms together, not the electromagnetic force. That's one of the other four fundamental forces.
Oh no, we're not talking about that.
Either way.
Cool. Okay, no worries.
We're talking about the cavitation.
I appreciate the correction, but it still follows the same logic. Like the arguments still exist. Gravity is so weak. If you're actually going to put something, an apparatus together to demonstrate this attraction, then it should follow through with all the expected rates and types of attraction. Like it should be very observable.
No, gravity is not that weak in the sense that it's proportional to the
Well,
mass.
then you guys should have
Let me
consistent
finish.
results. Right? You should have
You're
tons
talking
of
over
these.
everybody. Just let me finish the sentence. So the gravity can be weak if the mass is small, and the gravity can be very, very strong if the mass is large. Do you understand that? It's proportional to the mass. That's one of the principles of gravity.
Me and Zanik actually had this argument before. It's one of the things we
But
disagreed about
normally,
before.
to have more mass, you'd have to have more matter, which would be more electrostatic.
Charge. No, not always.
The problem you've got with that is the strong nuclear force or the electromagnetic force, whichever one you want to invoke, works upon a principle of attraction and repulsion. Both actually work because it's both based on charge. Not that we know why anything has a charge, by the way. So that's another fundamental thing that we don't understand why. So gravity, you've got the amount of mass, and that's proportional to the mass that you have around you. So again, not really a problem. I don't see where the argument is here.
Yeah, but that's the point. Is that the argument is a general. The argument only exists in a general sense. That generally, one force is greater than the other force. But just as Zanik has just said, and also as I said against Zanik at one point in the past, we had this argument. Generally, those two things, one is stronger than the other. But in specific cases, there can be so many specific cases in which the amount of mass is enough to create a gravitational force, which is going to be much greater than any kind of combination of the charges, especially whenever you need either opposing charges or like charges or charges
you
at
guys
all.
are giving me a headache.
You're going to need charges at all to create any kind of force. If there's no charge at all, like a neutron star, for example, there's a lot more gravitational force there than there is any kind of electromagnetic force because there's no charge.
And the other thing I bear in mind, Rig, is the distance that these things operate on. So the strong nuclear force is really, really strong, stronger than the electromagnetic force by a long way, by the way, but only at very, very small distances.
Why are we talking about? Never mind.
These magnetic forces, they can prove to be
I
decaying.
just don't think you guys could
Some
pull
of
it
these,
off.
hold on. Some of these electromagnetic forces can be decaying with the square of the distance, not the cube of the distance.
Yeah.
And so that's key right there.
And then you got
Gravity's
the
always
amount.
following square of the distance. But
And then
Coulomb's
you got the amount. And then you got the amount of energy that's required to generate that force, and that's the other problem. So mass is its proportional representation. And again, with things like the electromagnetic force, for me to double the value of a field or the effectiveness of a field or the range of a field, I have to put a lot more energy in, a lot more. I think it's again, it's that inverse square increase. No, it's an exponential increase.
Yeah, again, we're talking about whether or not BioJoule's results for Cavendish was caused by magnetism. And now for some reason we're talking about something completely different. You know, BioJoule's already said that, you know, by basically doing the experiment in the way he did, he's got compensated controls to negate electromagnetism as being the reason for this.
Are we back to dielectric materials?
Well, yeah, or you could just measure. You could, you know, if you have enough instruments there, you're measuring the pressure, the whatever else, the electromagnetic force. You can measure all that stuff to see if it's influencing anything. And I think that in his case, he was.
I think it's just an excuse to hand wave away results you don't like. Sorry, Rick.
I kind of like Gio's perspective on it. Is he's accepted the results and he's trying to come up with an explanation for why it's shown. I mean, you know, basically, you know, what Gio's saying is, okay, I accept it's not magnets causing this. It is the mass, which is the fundamental thing that's causing this, but he's saying it's the ether that's playing part with the mass instead of gravity.
Yeah. Gio and Lemon are they're both tied at the #1 Flurf position, at the capabilities of being able to come up with arguments when I didn't think there was one. So I gotta give the both credit for that. I give
you
both
call me a
credit for
Flurf
that.
again. If you call me a Flurf again, you're banned for life.
Well, Fleur, you know what I mean.
I like exploring. I like exploring Gio's side of it, right?
My
you know what I mean, man. I'm giving you the #1 spot, dude.
Well, what I was
sorry, go.
Branch said, okay, well, thanks. Okay, Gosho, but okay.
I mean, no
but
offense.
yeah,
I'm giving you credit, my man. Because Lemon, I'm especially impressed by. Because there's arguments I've had that I thought nobody can have an argument against it, and Lemon has actually I wouldn't call it a sound argument, but an argument that at least has merit and is, you know, not just made up on the spot. Yeah, exactly. It's coherent, and actually it does make some sense, and it actually is a rebuttal. I'm like, wow, I think there was one.
Right, it's a better rebuttal than, you know, just throwing out random things out, you know, debunking the whole. You know, it's better than just throwing out bullshit. In other words.
Just real quick, Branch, to what you said though, because the way you described my position, I mean, I hear that you were just kind of trying to, you know, share it, but I guess I didn't fully feel like I align with what you said. Although it's cool that you said that. But I'm not saying that it's just electrostatic fields necessarily. In the same way that you could just measure. I'm not saying it's like necessarily static, like the way you can get a balloon to stick to your head. What I'm referring to is the actual field that the matter exists within, like that the matter itself, whatever we call matter, that has its own electrostatic potential. And so that potential is going to be unique to whatever that matter is. So if it's metal, it'll have a particular type of potential. If it's paper or plastic, different things are going to have different components of that. And then the way that interacts within the actual system of the actual ether, it's the fields essentially that are moving the matter. The fields are what exist before the matter. Yeah.
You know, the interesting thing though, Gio, is what you're saying is actually, you know, there's two different ways of thinking about gravity, right? One is, you know, there's two masses attracting each other. Another way of thinking of gravity is the bending of space-time, right? What you're describing is actually pretty similar to that notion of gravity, which is actually bending space-time. But the way you're expressing it is slightly differently.
Well, I think gravity, you know, a rose by any other name is still a rose, you know, and it's the observations that we have, you know, stuff falling to Earth, geodet moving through space, the fact that we can see behind stuff in the right conditions, all these kind of things which sort of comport to the explanations that we have. An incomplete explanation.
It's almost similar a little bit to like in water, you have things in water, right? Like fish or little pieces of dirt that are floating around in water. Well, if there's a movement of the water, it's going to move the little pebbles, you know, like if you're dropping pebbles in water, if there's and in the same way, like this medium that we're in, it's not water, but it's similar in the way that we are actually enveloped in a medium, and the movement of that medium is going to cause movement of what we call matter or mass.
Well, but would you agree that we have less understanding of what ether is, to the explanation that sort of supports the observations that we call gravity? It seems to be a weaker argument with less to it than what we already have. So I'm trying to work out where the efficacy is.
Okay, I don't quite know what your definition of ether is in that scenario, but
I want to use yours.
I think it's all interconnected. The reason things fall towards the earth, the reason pendulums precess, the reason Cavendishes wiggle, the reason weather happens, it's all interconnected within the same system, which is why some of these theories, quote unquote, on gravity, they have some truth in it because, you know, what you could call gravity is a very real thing. It's just the interpretation and the model that they pull from it that I don't agree with.
So, Gio, super interesting question here, right? Say if somebody did this experiment, right? Just what would your explanation on this be, right? If they did three of the same experiment, they basically set up a Cavendish and a pendulum side by side, and they did it on the northern hemisphere, on the equator, and the southern hemisphere. Now, the three Cavendishes all have the same exact results. The three pendulums, however, the one in the northern hemisphere, it basically changes direction clockwise. In the equator, it doesn't change direction at all, and down in the southern hemisphere, it goes anti-clockwise. What would your reasoning for the ether causing that type of behavior be?
Good question.
I was really hoping it was going to be a crap question, Branch, so I could have been slightly sarcastic at this time of the morning. You upset me. Good question.
Well, so before Gio, I guess if Gio comes in, I'll stop. But I was gonna say your question or comment was, I think, good. Also address because I asked earlier today as well that you know, it's funny that they criticize that we have two gravities, Newton's and Einstein's. They criticize it like it's a really horrible thing and blah blah blah. And then they have an infinite amount of unique ideas of ether. You know, basically each person has their own idea of what ether is. And that's not a problem at all. I don't know, but yeah,
Well,
I know Branch is waiting for Gio.
Well, it is for some of us. We've already, a few of us have already said about that. That's why I put them in the same basket.
Yeah, I mean, for me, all I'm looking for is a consistent standard of evidence used to evaluate stuff. And that's one, I think, for Flat Earth, I think that's one of the majorly big problems. I mean, you know, I'm quite methodological, quite process orientated, you know, what I call that, the bump guy. You know, I go through my process.
I hear you do a lot of math, yeah.
I do no math.
Well, you're saying you okay?
No, that brings Branch had a question for you though, G. I don't want to take away from him. I just I was only saying something because I don't know if you were coming back. Yeah, Gio, you're making my Cavendish wiggle right now, dude.
Oh my god.
I thought it was funny you said that. It makes the Cavendish wiggle. And
Branch has been on point. He's had a very clear understanding of the conversation. He's been able to articulate what's going wrong and how people are going off track. And he's been able to bring it back to the point. I reckon Branch should be a mod. That was really well done.
I wish Branch was paying me to lobby for him too. Side note.
No, that was a freebie. I'm just paying it forward.
That's funny.
Branch is paying me. So.
Yeah, go ahead, Kosho. What were you gonna say, Kosho?
No, Gio. He was asking you a question. That's what I was saying. I was only saying something because I was waiting for you to come back. But Branch had asked you a question, and we were anticipating. I don't remember what the question was. I do remember it, but I think Branch could probably repeat it if you didn't hear it.
You can repeat it, dude. I'm smoking a cigarette right now, so.
He's smoking.
Okay.
Smoking
I'm on my phone. I'm on my phone, and I think it did drop out a little bit. Like it's been going in and out a little bit because I'm on my phone right now.
All right, so Gio.
Gio,
the question is this, right? Assuming that it is the ether causing the Cavendish to do what it does and the pendulums to do what they do, if you had an experiment set up where you basically had the Cavendish running side by side a pendulum, and you do this in 3 different places, in northern hemisphere, southern hemisphere, and on the equator, why would the Cavendish experiments all show identical results, but the pendulums on the northern hemisphere they'll rotate clockwise, on the equator they won't rotate at all, and in the southern hemisphere they'll rotate anti-clockwise? Why would the ether be causing that type of behavior?
Sorry, you may have to repeat that one more time. Sorry, one more time.
Don't worry about it, dude. It's all good.
No,
you should. It's
for real. No, just what you're talking about the star rotations, or
no. He was wondering if you were to conduct a test where you did the Cavendish and Foucault's pendulum kind of together in 3 different locations, one north of the hemispheres, southern hemisphere, and also at the equator, and at all 3 locations, they behave the way that we predicted they'd behave. That means that the Cavendish worked correctly in all 3 places consistently. North of the equator, it spun or it precessed clockwise. The equator didn't precess at all, and the southern hemisphere it precessed. And so all these things occur.
I got you.
He was saying that in your idea of the ether, because it was such a good idea, it was a great idea. But how would you say the ether is making this happen?
Yeah, I got you for sure. Yeah, so the equator is the dielectric inertial plane of the magnetic field on that vector. So like the equator is the midpoint between if you imagine like a toroid and then you have a plane in the middle of it, that plane in the middle of it, that's the dielectric inertial plane. So that's the middle point of that field. So that's more of like that kind of structure. But if you imagine in terms of more of a magnetic structure coming out from the center, more like a dartboard, then the equator is the midpoint, which it's the point at which the polarity switches. So when I'm saying that the equator is the dielectric inertial plane version of the toroidal field. So the actual equator is that midpoint, which is why you get different readings in the north on the equator in the south. It's not because the Earth's a globe and because it's spinning. It's because of the actual magnetic field and the way that the equator is the midpoint, which of course, like the equinox, the way the sun works and the moon, it's literally the midpoint of all of the sun, the moon, and the wandering stars as well. So there's something unique about it. But that's why it's because there's it's the polarity shift. So it's the midpoint.
But then, okay, so that explains why the pendulums work differently. But then shouldn't the 3 Cavendish experiments have different results?
Well, the thing about quote unquote Cavendish in general is that generally there's a lot of different readings that are picked up and they end up just taking an average of them. So kind of like Riggs was saying before, there's not a single specific attractive value. There's a range of values that fluctuate, and then what they do is just claim an average. So yeah, so they're not actually getting one consistent reading. So if you were to do it at different areas, you could get slightly different results, which they do.
Good answer, man.
There should be completely different fluctuations, though, right? Because you're basically saying the impact of the ether is completely different on the equator than it is on the northern hemisphere. So that there should be consistent differences in the Cavendish experiment if you do them on the equator or if you do them on the northern hemisphere.
I mean, that's a good question. That's a good inquiry. What I was actually saying is just that when people do Cavendish, they get a range of values. So I was just saying that in general. So it's not just one specific number that you'd be able to compare. So if you did it in those different areas, yeah, you'd have to see what you get. But I would say that the pendulum and Cavendish work through different they work through different systems. Well, they're similar in some ways, but they're different. It's still like the actual vortex of the ether that's causing both of them, but in the case of Cavendish, it's only working on one vector to get the quote unquote attraction or that wiggle, whereas with the pendulum, it's working on more of a full 3D vector. Like it's working on multiple different forms of movement to cause the precession. It's one additional vector.
Okay, just want to see what your thoughts were.
Hey, what's your vector, Victor?
Yeah, I think like Cavendish, this is interesting to think about. Yeah, the Cavendish type apparatus, yeah, that's picking up like the flux in the field, whereas the pendulum is actually getting the entire drift, the actual sideways drift as well.
When you say picking up the flux in the field, I'm just I'm picturing the Cavendish because I know let's just describe Cavendish in the simplest way possible, and that's you're just hanging two masses, and then they happen to come together, attracting. When you say it's picking up the flux in the field, what do you how do these things correspond? What do you mean the flux in the field and the masses attracting? Like how are these things related?
Yeah, it's interesting to think about for sure. I would say that when you have physical matter like that, like hold on, I'm driving. I gotta get on the right exit.
It's kind of a weird thing to just ask for an answer from you on without giving you time to think about it, right? It's not something that's easy to answer. So I don't expect I don't expect an answer just off the top of your head, you know.
Well, if it's asserted, then it should be well enough understood to be able to explain it.
Yeah, but it took.
Oh, this is ultimately what I think is happening. Like when you have metal balls and a metal torsion rod system, doesn't even have to be metal. It could be something else as well. But in particular, they often use metal for these. But there are other ways to do it. But when you set that up, I mean, this is ultimately what I think is happening. You have the masses, and those have their own field, their own electromagnetic, electrostatic, their own feel to them, and the light and sound frequency that makes it mass. Light and sound is what makes it mass in the first place. The electromagnetic and electrostatic field is what allows that to be in the environment. And I was talking before about like the vortex nature of the ether drift. Essentially, it's vortexing in a way where it's causing those two masses to sort of like a you know when you put a screw into wood and it like spirals into the wood, and in that sense, in the same type of idea, when you're balancing those with such a delicate balance, there is going to be that natural ether drift because of the vortex nature of it, which is the two fields that are surrounding the masses are going to come together. So it's the fields that are coming together. The masses are just coming along with it, and it's happening because of the vortex of the ether.
I've got a small problem with that because we can measure sound, we can measure light, we can measure electromagnetic fields very easily.
Yeah, that was going to be my next question. How can we measure or confirm that these fields are doing what's being claimed?
Yeah, and all you need to do is to have two fields that have an opposite charge, and hey presto, anti-gravity, baby. And so and again, when you go into Gauss, when you go into Maxwell, you know who was a proponent of ether. Let's not forget that. But it's not as a mechanism to make the change, but just as a carrier. That's
right, exactly. Yeah, the fields. Yeah, the fields are the carrier for the matter, and then the medium is the motion of the ocean, as it were.
But all we'd need to do to be able to then hover is have an opposite charge to the ground or the ether around us, or whatever the mechanism. Because charge is what gives you your attraction and repulsion when it comes to electromagnetics. So therefore, creating anti-gravity, if this was all based on electromagnetics, would be a piece of piss.
Yeah, that's how these quote-unquote UFOs, really those are just technology that the government has, and they're claiming that, oh, you know, they even released, you know, this physics that, you know, transcends all of our current knowledge of physics. So yeah, if you were to be able to manipulate this environment, you could create free energy, of course, and you could also move around in it, not where you're having to propel yourself, not like you have to take a rocket, not like you have to take a rocket to propel yourself, but more that you would be able to manipulate your position in the environment directly and potentially have no excess forces to where you could make like 90-degree turns and, you know, and not have all of your organs explode.
Did you have a way to measure these fields, Gio? Namely the flux interaction.
Which ones? The electromagnetic and electrostatic fields?
No, I understand that. I understand that we can measure those. I don't object to that. When you were talking about the flux interaction between the masses, I'm wondering how we can measure and detect those.
Yeah, well, that is what unlocks free energy technology. What you just said right there. Yeah, that's the ultimate unlocking of it. That's how it's being able to tap into that and pull it out. Yeah.
So no is the answer.
To put it
into, yeah, got it.
And there's no such thing as free energy. Energy can neither be created nor destroyed as matter. We can only transform it.
Yeah, I didn't say no, so I don't know why you said that for me, and then Bio answered as if I said that. That was weird. I
It
didn't
was
say any
essentially
of
a no. I asked how can we detect and measure it, and you said yes, that's how we get free energy. But that's not answering my question. So I assumed it to be no. Do we have a way to be able to
Well, I
detect
asked
and
you
measure it?
I asked you what you wanted to measure, and we were talking about the electromagnetic electrostatic field. You're talking about the actual vortex movement in particular, the vortex, the ether drift, essentially.
The flux vortex that you asserted. That's what I'm asking.
Okay, two ways to pick it up are mechanical and ring laser gyroscopes.
That's not measuring a field, though, is it, Joe? That's just you're taking an observation and then you're making a claim that this is the cause. So what we want to do is understand. So if I want to measure an electromagnetic field, I can use like a Gauss meter to do that, and that's working on the background field properties and registering changes in potential.
Gio's right, man. That you can pick up the flux with the ring laser, as far as I know.
That is one great way to do it. Yeah, and actually, this is what Bob Nodell did. Ironically, you guys all say this, Bob. Well,
I'd say it was the best way to do it, really.
Well, then I'll just basically say that
different altitudes and different positions. The results vary in relation. I'm cutting out. Go ahead.
Yeah. I'll just say
No,
cool.
you were breaking up, man.
Then a pair of scales proves gravity in case closed.
You were breaking up a second ago, Gio. I don't think anybody was trying to interrupt, but you cut
He
out.
said I've got a bad connection. Someone else go.
Oh, I got you. Yeah. He's on a mission, dude. He's going into Compton. Sounded like. That's what I heard.
No, I've got water bottles in the car. While you hear the clinking of the water bottles.
No. You said you were on a road trip, and Compton's right by San Francisco, right? As far as I know.
LA.
Wait, which one
No,
is right
dude,
next
I'm
to? Wait, which one is that? That's where were the what do you call those? The pirate team. They're in
Oakland
Las
Raiders.
Vegas now.
Fuck's sake, you're American.
The Raiders,
dude.
yeah. Where were they from?
Oakland.
Oakland. There you go, Oakland. Yeah.
I don't even like
Well,
American
but yeah,
football.
but in terms of back to the gyroscopes for a second, yeah, I mean, those are picking up a drift in the environment, like they're picking up a precession.
Yeah, they're picking up movement of the rotation of the Earth. And Compton's bad, but it ain't no 7 Mile. You get me?
8 Mile?
7 Mile.
For some reason, Kosho, when you said that, because yeah, like I went to get my spring water today, so I've got the water in the car and it's in glass bottles. So when you said that, I thought you heard the clinking, and then you said Compton. I thought you were talking about like that you were hearing some. I didn't know.
No,
Yeah.
shit. No.
7 miles.
San Francisco's an expensive place to live right now.
San Francisco's always been an expensive place to live, even back 20, 30 years ago.
Funny thing is, all the people.
Well, yeah, I mean, Bio's original kind of thing he said though, which I don't even know if he's still in here still, but he was, in terms of measuring that ether flux that I'm referring to, I mean, that is the ultimate. That's what I was saying. That's like the ultimate forefront, into free energy, is to be able to do that. And all of the pseudo physics of today's world is built to cover that up. So yeah, I mean, of course, that's a huge question, and to be able to get to that level. Oh, go ahead.
I've been looking into what's that guy's name? Edward P. Little or whatever he's called.
Yeah.
Yeah, I'm
Of course,
starting
you'd be
to.
looking at Edward P. Little.
Yeah, I'm having a bit of a conversation with him at the moment. Well, not with him, but with someone who's a proponent. So I think he's dead, but I'm not sure.
You're. It was a name that brought you in, but when you heard what he was talking about, you stayed a little bit longer. But you had to get in touch with the P. Little.
No. I'm chatting with someone else that kind of is a bit of a proponent of his. I did go and have a look at sort of where he came from and his creds, and I've read through some of his papers.
Was he Did he work with Sir Edmund Poopsmall?
No.
Okay, because I know they were in the same line of work. Surprised they didn't work together. Okay.
I think you'll find that Sir Edmund Poopsmall worked with Lord Dingleberries.
Of course, yeah. Of course.
Were they the ones wiggling the Cavendish?
No.
They all make the Cavendish wiggle.
Did they
Oh,
marry
right.
into the small cock family?
Well, how come you sound so different all of a sudden? Have you got a better mic?
Compared to when?
Well, when I was, when I became the exile.
Oh, I got a phone call, guys. Sorry, I am on a different mic, but I'll be back.
You sound awesome.
Take it easy, Mr. Wise. What I know about Wise, Mr. Wise is usually mobile. I'm recently mobile also. Geo is almost never mobile, but he's got some sort of contraption. His whole apparatus at his house, he has like a smart house or something like that, where he can hear Discord from anywhere in his house, and he's got to basically run back to the room to respond, but he can hear it from anywhere. I mean, it sounds like a cool setup. I don't know how it works, but I wish I had something like that.
It's not hard. You Bluetooth headphones. Bluetooth speakers.
Good old speakers, yeah. Good old speakers.
You say you just have it super loud?
No, just got a number of Bluetooth speakers spread around his house. That's how I would do it. And then you can have them all linked to a single unit. Bluetooth 5. You can have 4 or 5 devices out. No props.
Oh my god, man. That's taking shit way too far to have Discord playing throughout your whole fucking house.
I know. I do not have that. Whoever's making that up, that's not. I mean, I do have speakers. I have my whole computer setup, which has speakers, and they're loud enough, but to go some distance. But yeah, it's kind of like my whole workstation, but
I got you.
It's not like piped throughout the house.
Well, that's how I imagined it.
I go no radiation, radiation free.
Scott Beach does something similar to, I think, though, because sometimes he'll be like that, or I think he has multiple computers set up, so it's like he'll be able to hear somebody say something, and it takes him a whole minute to get back to respond. I think he's just, switching computers over, whereas I think you have to walk back to the computer to respond.
He could just be slow.
No, because Gio said that before. He's like, "Oh, I was doing dishes, or I was actually cooking some food." So it took me a second to respond. I'm like, "How did you doing dishes?"
I mean, I've got a pair of headphones that's got about 100-meter range, so I can be at the back of my garden and still hear this stuff if I want to.
Yeah, Kosho, because at my computer setup, I have a studio mic type of a mic. So yeah, if I'm gonna, and I use push to talk, so I have to go over to it to talk. Yeah.
Right. Fair enough.
That would be a cool little feature, though. Imagine if they use Bluetooth to say, as soon as you get a certain distance away from your computer, your phone automatically switches over to Discord.
I just got UHF headphones, and they've got a mega good range.
So you reckon I sound different here, Druss?
Yeah, you sound really good.
It might be the regional Might be the regional server here compared to what's used over there.
Yeah, no, you just sound really clear,
Can
really
anyone see
good.
what? Can anyone
Great
see what
tone.
region? Sorry.
I said you just got really. It's a really good sound, really good tone. Yeah.
I think you sound great, Waz, but you sound the same as always. I'm
Yeah,
not
it
like a
sounds the
dick, like
same to
just
me.
like, man, you sound so different. You sound good. It's like, wait a minute.
It's the content, Kosho, of what I say that makes it sound good. I get what you mean.
I think you sound good always, man.
Yeah, can anyone check what regional server we're using here?
Yeah, but that wouldn't make just you sound better, was?
It might do.
Oh, because you're the only Aussie.
If it favors me.
Maybe.
Yeah, I could check that. But also, I could actually turn the bit rates higher in this room as well. It's only set at 64 right now, so I could set it to higher if we wanted even higher quality.
That affects people on slower connections, I believe. Not that there's many of those around.
Yeah, that's
anymore.
why exactly. Yeah, that's why I didn't change it yet. I just left it because yeah, I didn't know if it would do that, and I guess like just trying to get the server going, it seemed like trying to add another factor, of unknown. So I just left it at that. But yeah, I guess now I could move it up and then see. I don't know, maybe at least up to 128. That would at least double it. Maybe not all the way up to 384. I think the max is 384.
Yeah, what you want to look at is really the average response time, because the longer the latency, the more chance you have to introduce what's called jitter. That's the non-sequential delivery of IP packets for voice. But I'm getting a really good ping off the server, so I'm on a 20 milliseconds on this server, and it's EU Central.
Big in Australia, the regional server was once changed to Japan, and I found that the everything was a lot cleaner and more clear, as opposed to when it was on either the UK or the one of the American coasts. Japan seemed to be, I don't know, more in the middle of the three places.
That's
Australia,
surprisingly
UK.
racist of you, man.
Yeah, what's up with that?
I never heard
They
Waz
just-
fucking get like that, but that's what's up.
They just do it better in Japan.
I do agree though. Japanese girls, there's just something about Japanese girls.
They got better
They
ping
live
rates,
to
mate.
service.
Much better ping rates.
I thought that was Thailand, or is that better ping pong rates?
I think everyone knows the ping rates are best in Vietnam. From what I hear.
Right. I will catch you, gentle people, later.
Seizure. Wouldn't want to be here.
I just realized the three of us, me, you, Branch, we're the three brownest people in this room right now. And that's something to be proud of.
Just the three of us, Kosho. We can make it if we try. Just the three of us, you, and I.
3 brownies.
Exactly. 3 brownies. 2021, man. I never thought we'd make it this far.
It's like someone dropped the kids off in the pool.
Well, leave it to Waz, man.
We're just at the beginning.
That's right, man. So no one's flushed yet. Fucking Waz.
Watch out for the whirlpool.
We're just collecting collectibles along the way.
Some shit, man.
But isn't that ultimately what memories are? They're like a collection of something. It's like a collection of memories. And then as each moment passes, everything in the past is just a collection of that memory.
Yeah. Absolutely. That's why false memories are a thing. It's because the things you remember the most, other than the things that were the most intense, The things you remember the most are the things that you recall the most. So the more you recall something, the stronger of a memory it's going to be. That's why you can create a false memory, because you can just recall something that never even happened again and again, and
It's burnt in as a
it'll
memory.
seem to you like it happened. Yeah,
That's not what
that's why people who are
Scientology-
compulsive liars. Go ahead, Mr. Branch.
Oh, Scientology is all about that shit, right? The whole I forget what they call it, but that whole regression shit they do, where they just keep going over the same memory over and over and over until you feel better about it.
Oh wow, I didn't even know they did that.
Yeah, that's like their I don't know, that's like one of the biggest things they do. They have the whole fucking electric meter that they hold in their hands and shit.
Oh yeah, the audits, yeah. Yeah, but that's exactly how you create a false memory, and that's how I was gonna say compulsive liars. That's why if you know a compulsive liar, it sounds like they actually believe the bullshit they're saying, and they actually probably do, because they've said it so fucking often that it probably becomes like a real memory to them, like it actually happened or something like that. Like if they said something over and over again, and
becomes their perspective on things too, yeah. And your
Yeah, exactly,
perspective is your reality.
Yeah, exactly. Perspective is real. Yeah, that's exactly what we say in the Navy. That's what at least the higher ups always say. Perspective is reality, because truth. Yeah, doesn't matter what actually happened. It matters.
The head honcho of IKEA said that to us once. Your perspective is your reality. He's talking about marketing stuff in the shop. You're trying to give people you're trying to give people perspective to make it their reality, sort of thing. It's all about trying to make $1.
Oh yeah, well, I guess that's true. Yeah, if you can portray something honest or true or not true, then people are gonna receive it that way. So, but yeah, I think about people like QE, or there's people who just say the same bullshit over and over again. Even though it may have started out as a lie, they say it so often that it's true to them. So I have friends like that. I have friends who I know are compulsive liars, and they say the same shit over and over again that they probably believe it at this point.
Like, I know some flat earthers that they obviously started off trolling. They did it so much that they started believing their own troll.
Yeah.
And they became full-blown flat earthers. They almost talked themselves into it.
I can think of 2 girls like that. I don't want to say one of their names, but one of them is Soda. Yeah, Soda said that, or she was like that basically. Like, she was trolling for a long time, but then she started believing some of the shit. But there's another girl. I'll just say she's an Irish girl, and or maybe Scottish. Actually, yeah, she's Scottish. And she said she started out like that, but I think the same thing, like, just became a reality for trolling so much.
What are you saying is their reality? That the Earth is a stationary plane?
Not that. Just like they argued it so much that they start to, believe that they believe it. Basically, I mean, that happened to me today, dude. I was arguing this dumb shit because they were talking about some dumb shit and gems about fucking. I think Zant brought it up. He's bringing up fucking how they did this rat experiment where they fucking gave this rats a utopia, just see what would happen. And I was just fucking around. I was like, dude, like, what kind of sick fucking person gives all this money to these rats so you can have a utopia just to do some scientific tests? Like, I could have figured that shit out without giving them anything. I was just bullshitting because, I mean, it's an interesting test, and, I could see them putting money into that. But I was arguing it to the point where I was actually, coming up with valid arguments to validate the point that I was arguing, even though I didn't really even agree with it. I mean, that happens when you're trolling,
I wouldn't know.
Try.
I can't think of any time I've ever trolled, so I wouldn't know.
You get real bored, it becomes easy
What-
to fall into.
Yeah, in that case, like somebody is like attacking an idea that they're actually curious about.
Yeah. So you're attacking something that you actually kind of would normally agree with, but it's cool.
Yeah, it's definitely coming. Like when people, if someone's doing that, like most likely it's coming from some kind of a uncompleted energy that they're trying to resolve somehow. Branch, are you still there? Dude, Kocho, was Branch not on fire earlier?
He was on point, man. He was doing well.
Yeah, Waz, what do you think? Was that not just like that was amazing? Branch was killing it.
He's pretty good when he wants to be.
Yeah, it was amazing. It was one of those special moments.